Welcome to the very first Azure Developers Day dedicated entirely to Python devs.
We have a jam-packed day for you all featuring Python cloud experts at Microsoft and in the community.
I'm Haley Huber. I'm a product manager for the Azure Developer Experiences team.
Hi, all. I see you all rolling in. My name's Dawn Wages, and I'm the Python community advocate here at Microsoft. I'm the chair of the Python Software Foundation, and I'm a Django developer and open source community organizer. I'm so excited to be invited here today. The team, Haley, has done such an amazing job planning this full jam-packed day for us.
You do so much. It's so impressive every time you list all the things you do. Yeah, we're so excited to welcome you all here today for a day full of building and deploying and optimizing Python apps for Azure.
So we have some folks all across Microsoft who build the products you know and love, like AZD, App Service, Cosmos DB, Azure SDK, Microsoft Fabrics, Container Apps, Functions, Cognitive Search. It's jam-packed. I was just so excited when I saw the lineup, and so much more. So we're going to show all the amazing things they have been working on.
And Dawn and I will be here all day to make sure that we answer all of your questions live. So make sure you put all your questions in the chat. And once the session is wrapping up for each of the speakers, we'll make sure to ask them. We're super thrilled for all of y'all to be joining us here today. As Dawn said, we have a jam-packed schedule, and so we're going to give you a sneak peek of the agenda. But first, I got to make sure to mention, please like and subscribe our YouTube channel here. We have community stand-ups from all of the services that Dawn just mentioned. And so each month, every Tuesday and Thursday, and sometimes Wednesdays as well, we have a bunch of great new information coming at you, demos, all the things that the teams have been working on. Join us live each Tuesday, Thursday, and sometimes Wednesdays for the community stand-ups. So I'm going to add the agenda to the schedule here so we can do a quick walkthrough of what we got coming up next. So we're going to start with the very first session. If you want to see this agenda at any point in time, there's the link above there, the aka.ms link, and so you can see what is up next. So I'll pass it to Dawn to intro our first session.
Awesome. And I see so many hellos this morning. It's morning time for me. Well, a little afternoon. I'm on the East Coast. And I see hello from Tokyo and Oregon. Hello, Atlanta. Hey, Jay. Peru, Chile. Awesome. Thanks so much for joining. And we have a bunch of people rolling in. So I'm so excited for this next talk today. I love a demo with real world use cases. And we're going to get cooking with a restaurant app with Emmanuel Delatong. Make sure you're adding your questions to the chat, and we'll be answering them at the conclusion of the presentation. Emmanuel.
Hello. Nice to meet you. Thanks to invite me. It's a big honor. I'm based in Paris. I am a global black belt at Microsoft in NoSQL. And I will show you a real example how we can build very quickly and fast with using different Azure services, restaurant management applications. And the goals arrived during the COVID. There are some restaurants where I live who don't make any delivery at this period. And I say, yeah, why not make a kind of sample applications and working on this? So what I will do, I will really build web applications that manage restaurants. And of course, any applications need a persistence layer. And for this, I will use a NoSQL engine systems. So let's just do a quick introduction. So before to build my applications, and the application you are going to show, needs some business needs. So they need to have a kind of automatic module of authentication where our user can register, receive an email that he is welcome, and after have the capacity to log in with their own login and password. We will propose, and the restaurants have some food, but they change the starter every day, they change the main course every day, so you need a kind of product catalog that you can expose with an administration page, and when you log in, you will see this product catalog. We will store all the order of the people, we're making some aggregations, how many order do you have made, how much have you spent, for example. And due it's an online system of delivery, what they want, for example, they want to have suspicions detection fraud. So if I order from Paris, but I use an IP from US, maybe it's a fraud detections. And of course, we want to open at multiple language, multiple things. Why can I not use a translation system, especially for the menu? Technical need, when I start, I didn't know a lot around Python, so I tried to find a language of development and a framework to easy work, especially in a web framework. So that's why I decided to use Python and Flask. So all is in Python and Flask. It was really easy to develop because you have all the SDK, especially with Cosmos, there are different SDK, and you work with Dict, and Dict is a JSON, so very easy to work all of this. After, especially, can I have some service API where I can call to translate, for example, and accelerate my business requirements? Yes. And okay, now I have developed my application. It's on my laptop. How can I publish my web application? This is easy to deploy, redeploy, because I will have new features asked by the people, and all having one database that's all these business needs. So my persistent layer, what they need? They need to have the capacity to store data, structured and unstructured data, like authentications, menu. It's very structured data. It can be relational. Okay, order, but I want order and all the data in order. So it's more non-structured data on aggregations. And fraud. Fraud is very different because I want to store user, what's the IP used by user, what city, and make some, not really a select, but try to make a discovery. For all, I want to have a flexible schema, so capacity, especially for the new features, to add new information like country, city, phone number of the user. All will be in native JSONs, and I want especially a full managed database. So that's been all made by automatic backup, auto index, scale up, scale down. If possible, if it can be a serverless database where I will pay only if it's consumed or not consumed. So if my application it's a success, I will pay, but it's better because that means I will have a lot of order, and we like very high responsive. I would like to have the capacity to have global distributions and very easy to scale. And of course, I want something very easy to develop. Can I have SDK very easy? Can I have an event system? So when a new user register, can I have information and send this information? Best, it's to make a demo. So here, what I will do, I will first, of course, every people know Python app API. So I will launch locally my applications, and we will discover. So my applications will be launched directly in Python. And here, when I go, I have, and everybody can go, and I will send the link at the end of the sessions. You have this application, it's deployed in a web application, so you can create your account. Of course, here I have deployed locally, for example, for some tests and all, and you can see you can create an account. I will say, okay, let's create an account for me. I will say, okay, I live in Paris, France, country. I will give password, and here I will sign in. So this is just a sign. What you was done. It just write in a database a new systems, and now I can log in. So I can log in as Emmanuel, and here I can choose a language, for example, and I say, okay, by default, all my menu is in English. Let me take, for example, Italian and login. What happened here, he will go to login, of course, and when he log, he will go to check my menu, and you can see the menu of the day with some starter, main course, dessert. And here you have the description, my database in English, and I have had automatic translation using Azure Translate. Very easy. I can choose the different language, detect. Here for this menu, of course, I can do and select what I want to order. So yes, I'm a database developer, I'm a Python developer, but not web user or user interface developer. So it's not very nice or beautiful HTML, but it's here to explain. And here, when I made my order, what you will do, you will just add a new order, and I can see that I have a number of order 12, and I have spent this total of amount. So I go to run in the order database, and here I have had in a graph database the new command, so the new IP, if I use the new information. And here, for example, to show you, I can go and connect my graph and query my graph to see, okay, for this IP address, who have used this IP address? There are different people, for example, and from which city he have make this order. And here I can see that he is in relationships with a lot of city, a lot of order. So this is the applications developed, very simple. Now let me go back and explain a little more around the architecture, what I have used in terms of services, and after, of course, show you the code. So how to choose the right database? I will say the first module was authentications. Authentications, what I have sent and write something in the NoSQL, and I have used in Cosmos DB something named ChangeFeed. ChangeFeed have systems integrations with Azure Functions. So that means every time I have write something or modify something, it's launched on Azure Functions, and I have received, for example, an email. Let me go back. Here you can see that I have my function will run, and he say that I have one document modified with the name Emmanuel. And if I go to my email here, I should have received an email. Oh, yes. So the functions, because I changed something in my database, send me an email. It's just a sample. Of course, you can do what you want in terms of integrations behind the scenes. So here, very simple, write my information in a NoSQL database, all managed database, and working with this. After, why I would choose Cosmos DB? Because all is in one collection. All the user partition key to scale is very easy here. It's my email. It's my unique identifier for the people, easy to scale fast response. It's a full managed services with serverless. I will pay as consumed, so I use Cosmos DB serverless, and very high performance, very easy to program, change feed, link to function directly, capacity to have a change feed, so build an event programming. Let me show you, for example, quickly, what is this in my database. So here I have my database, it's my Cosmos DB. If I go to the overview, you can see I use serverless capacity. I'm based in West Europe. And if I go to the Data Explorer here and show you, I have my table, right, with all the informations of the user. Oh, sorry, it's not the right table with the user with all these informations. Here, it's another email, but it's just what I had. And here I have the last update of the information of the document. So all manage, some feature activate, very easy to use, and change feed to launch directly another function. So very interesting and very easy to program and to do. After, when I'm registered, yes, I have an admin page and I have my login page. When I log to my login page, it will run, check the menu of the day. It will call a translator, and okay, all in Flask API. The translator will give back some description in the language choice when I made the login. And all the menu is stored in a Cosmos Mongo API. I can do the same with NoSQL and Cosmos Mongo. I do one with NoSQL API, one with Azure Cosmos Mongo API, just to for training purpose, for educational purpose. But and show you that there are really no difference, just different SDK that I use. Here I use a Mongo, and here's the Cosmos DB client. As you see in the menu, I have some images, and the images are stored in a Microsoft Azure Blob storage. So in my menu, I have the link directly to this. And when I made an order, the order is right directly in a Cosmos Mongo, Azure Cosmos Mongo API directly. So all order is one collection. So I have the order and the historical detail of the order. I update the order every time I receive an information. It's really a JSON native document. Please.save. It's very flexible because here the model change a lot. The order, I have all the historical. Some order have two plates. Some are 3, 4. Depends. It's a full managed application, and Mongo API very easy. You can find a lot of sample, for example, how to develop with Python on Mongo. So very easy to connect, to write a document, to read a document, to observe a document. And in all SDK, you have the concept of upsert. Or if the document don't exist, I create. If the document exists, I will update. Very interesting. Other things that in Azure Cosmos DB, NoSQL or Mongo API, I can have an analytical store. So I can, with no ETL, I can connect, for example, a Power BI to get statistics around where the order comes, where all this. I do with Mongo for training purpose. I can do the same with Azure NoSQL API. And when an order is done, I will go and write inside the gremlins the informations, so inside the graph. And when I launch my fraud detection page, my fraud detections go to the gremlins and query the gremlins from DCP, from this IP address. Please give me all the people we use, and for this email, give me all the city he has made some order. Of course, you can make more efficient query, but very easy to make a discovery of the data. So why I use Azure Gremlins? Because when you make one have a fraud graph model, system of object and relationship between object is very, very adapt. I use in Azure Cosmos DB Gremlins API, you use a standard Gremlins language, easy to reuse, easy to find some sample of query. It's a full manage. All is encrypted, all is secure. I can make in a VNet, all is serverless. So all my database here are serverless. And if I need, I can have a global distributions, and it's enterprise ready. So let's show you now the code of my application and show you. So here you have my project. In my project, the main, of course, you have all the HTML page, but I will not go. So it's a Flask engine. And when you go here to my API, what I have done, I have really first include all the SDK, and you can find the Pmongo, you can find all the gremlins Python. Will, of course, make all my connections in a config. So all my master key, my gremlins to connect to my gremlins, to connect to my endpoint with my translator services, all my clients. And here I have some methods to connect. It's more for very easy to do. Okay, I will get from my request form the name, the email, the password, the city, and I will say, okay, do I, the user exist? Yes or no. If the user exists, I will update my item. If it's not exist, I will create a new item. And how to write inside Cosmos here? Just container observe my item. And I will show my thing. So very easy. The login, very easy. I will just go to query my informations. Sorry, it's in the check. Okay, so I get my email, my password. I will detect the language, and here I will go. Okay, the email is admin. I will go to my page with a manage page. If not, I will go check does the email and the password okay? Yes. In this case, I will go to call my API to detect the language and to translate the text I want. Here I just want had, and I will update and show this. So very, very, very easy. Something else, for example, I can detect all the change, and of course I can have functions that will be launched when something is new. But other things I have developed, and I will show you here, it's I can at any moment, for example, query and get to check if I have any change in my container. So here my container is the user container, and if I go to my Python code here, I can launch something named Python.change. So it will connect, see if there are any change happened since the last times, and it will show me all the information that they have changed. So all the last informations. It's take a little of times, but it's the same as the functions. It will detect all the event happen. Let me continue. I will come back after. Just because the time fly and maybe there are some question, it's Alf. So why I use Python, web application translator, Azure Cosmos DB together? I already have one model of database. It's the same operational system. It's serverless. It's full managed. All my, I will say, backup are considered the same. I use all our same encryptions. Inside Cosmos DB, I can create a Cosmos DB Gremlins API. I can create a Cosmos DB document database or NoSQL API or Mongo API. So here I have already two kind of model I need to use for my applications: a graph model for fraud and a document database. Graph model very adapt with Gremlins. It's an event-based database. So what I want is really when some new user register, you will receive an email. So making this kind of mechanics in automatics. And Azure artificial intelligence service are ready to help me, especially translator. In the future, if I want, for example, to give the possibility of restaurants to add their own images, I can have a content moderator to check if the images have, for example, it's prohibited in some country or all of this. I have all the SDK ready to and very easy to use. pmongo for the Mongo API, Cosmos DB client, very easy to use for Azure Cosmos NoSQL API. Gremlins, it's a standard Gremlins. Pythons can be used for Azure Cosmos, but other Gremlins database. And JSONs, because I work with object, and JSONs and Python are very easy to manipulate, especially with Dict. And Flask give me all the web framework. In addition, when I have developed my web applications, one of my goals was really to run an Azure inside a web app and deploy a Python web app. You have the Python runtime now in web applications, and already one CLI command, and all is very, very easy to develop. So how to deploy a web app in Python? I send here, I put the link of translator, or the link of Cosmos DB. You have the link of the applications and the link of the code. So here you can go in my, in my GitHubs, you will see the NoSQL app. In the NoSQL app, you will see all the concept and all the code in more detail. So you can go introspect how all was done. If you are interested, for example, here I made a query to detect how it's done. I will have, for example, what I have done, especially it's more for demonstrations purpose. I don't, based on the IP, go to detect the city. I made something not very, very clean. I just make a list and a random choice in the list. But here okay, you had, for example, update your email, update one. So you have some method to update and to add some information. And here I go to execute a Gremlins query, for example, to give me all my labels. So Gremlins, it's particular language, but something easy to develop and something very easy to use, especially with Python, because you can create a generic method like execute Gremlins and send all your informations to this. So very, very easy. Here I have my load. So I will add a new property user with email use. I will have a new city where the command was order. And here it's more, for example, try to add the relationships between the two. So if you go in, for example, the graph database, so here I have a Cosmos graph, you can directly, through the graph, show my graph. You can introspect, and here, for example, I can show from my graph where are all the information, all the relationships. So Idiomatic, he makes some order from Tunis, Clermont, Bruxelles, Paris. So I can see from every city he makes the information. You will have a lot of details. You can check the query statistics, what was the statistic of the request, and you can introspect and go directly in different, go inside the graph and show inside the graph some information. So here I can see from Doha who have used, what are the emails who have used, for example, the Doha city, order of Doha city. And last things I want to show you, it's here I have an Azure Cosmos Mongo request unit systems with serverless, and you can see one of the order, for example. So it was not the last. If I go back here, let me go back to, sorry, here it's the new, yes, order document. And so Idiomatic, so it was 11, now it's 12. I have the last order in terms of date. I have the total spend, and I have all the detail or all the order he have done. You can see in the image it's stored in a blob storage to recover all these informations. It's 30 minutes to present this. It's very quick. I don't know if you have any question. So do you have any question? Any?
Yeah. Hey, Emmanuel. Thanks so much for that. That was super awesome. We do have time for a quick question here. So KJ Miller asked, the runtime Python 3.9 was selected. Is there a service or feature that prevents using the latest version of Python?
No, in my case, I just used the last versions to deploy because it was really easy. But when you go to the web app in Python, you can select different runtimes of Pythons. I just use 3.9 just because I know it's work and I have no dependency of this framework no more. But it's really easy, and it's a by default last versions.
Perfect. That makes sense. We also had questions on a link to your GitHub repo, which we'll put in the chat, and we will make sure to share out all of the links and information from all the sessions today with the attendees here. I don't know if you're pulling that back up here.
Yeah.
Perfect.
Yeah, you have the code of the, so you have the code. It's explained that you need to create how to run this sample, that you need to create different systems, different Mongo, and change all the information in the config string. So you need to create one translator, one Gremlins, one Mongo API, one Cosmos, and it's explained.
Awesome. We'll add this link into the chat so that everyone can access this afterwards. Well, thank you so much, Emmanuel. I am here to introduce the next sessions. Have a great day. Thanks for joining us for Python Day.
Yeah.
Before we get into the next session, I wanted to ask or answer a few of the questions that I've seen. First off, Harry said, will these sessions be available to watch later on? And yes, they all will be available on the YouTube. And so the YouTube that you're watching here today or the Discord, this is where all of the YouTube videos from all of the community stand-ups that I previously mentioned, this recording from all of the sessions that we'll see today, more on-demand videos on how to use Azure for all languages, not just Python. They all live here on the Azure Developers YouTube. Please also follow us on Twitter, @AzureDev, for more information on things that is happening around Azure. And what is the link for the weekly event? Those are on the YouTube here. And so we stream weekly for a whole bunch of different Azure services. And so the next session actually is App Service, which I believe is on the first Thursday of every month. They will be having their community stand-ups talking about what's new, what's great, what's awesome, and answering questions live. So with that, I would love to introduce our next speakers, Byron and Jeff. How are y'all doing today?
Hey, Haley, thank you so much for having us. I'm doing great. And yeah, like you said, we usually have the Python stand-up on Thursdays, but today's Python Day. So what we're going to do is the App Service Community Stand-up Python Day edition. I have with me Jeff, and today is going to be all about Python, but we usually talk about App Service, and we have different topics. I think the one for next month, we're going to be talking about WordPress. So we try to bring you updates and news about all the different things that we're doing in App Service to keep the platform fresh and new features, etc.
Awesome. Well, I will let y'all take it away.
Thank you very much. And like I said, hi, I'm Byron Tardif. I'll be your host today for the App Service Community Python Day edition. And I have Jeff. Jeff is also from the App Service team. And Jeff, you want to talk a little bit about yourself? What do you do? We might be having a little bit of audio issues. Jeff, I'm not sure if you can hear me.
Yeah, sorry, I can hear you. Just one second.
Okay.
But yeah,
Okay,
hi everyone.
so-
Jeff Martinez, a PM on App Service, and
Awesome. So today we're going to talk about all the different pieces that you can put together to build a Python app that is going to be using OpenAI. And we also want to do it through gRPC. So gRPC is a platform that we added to it's a feature that we added to the platform recently. The reason why gRPC is interesting is for this type of chatbot scenarios where you're going back and forth. If you're doing it over traditional HTTP requests, there's a lot of overhead, right? And there's a lot of complication if you're doing a 201 continuation or you're chunking requests and responses. gRPC is a lot more efficient because you can do it over a single HTTP connection. So with that, Jeff, do you want to walk us through a little bit of like the intro for this? What's gRPC? What all this is about?
yeah, absolutely. I believe the slides are loading, and there's just a couple of them. Can we see them?
Yep, I can see the slide.
Yeah. Okay, so what is gRPC? If you're unfamiliar, gRPC is a remote procedure call framework from Google that uses protocol buffers to streamline messages between a gRPC client and server over an HTTP2 connection. The benefit being that it enables streaming scenarios, which can be done over just a single connection. So apps can stream messages from the client side, the server side, or both simultaneously with bidirectional streaming. It also enables language agnostic implementations since it uses these protocol buffers. So you can have a gRPC.NET client talking to a Python gRPC server, vice versa. Let's see. And for app service support, we do support each type of call with gRPC. So unary, that one is just a single request and response, which we'll be showing today. Server and client streaming, as well as bidirectional streaming. Okay, so
Today
enough
we're
of the
just
slides.
showing you the Python side, but this works for all of the different languages that we support on App Service, right? So .NET, Java, Python, Node, and right now it's just for Linux.
Correct. Right now it's just for Linux. It's in public preview, and we're working towards getting it to GA. And for Windows support, that will be only for .NET workloads, but that'll be coming in 2024.
Awesome.
Yeah.
So let's dive into the demo.
All right. Now let me go and make sure I share the right screen here. Yeah. Okay, it should be coming up in a second.
There we go. Okay, so what I'm seeing here is you have an app that's hosted on App Service, and this is just telling you that there's an app there, right?
Correct.
Web
Yeah.
page.
So right here we have the Python server already hosted on App Service. It's a simple chat service that uses OpenAI and LangChain. And then if I go to my client, you could see that let's see, that it's already pointed to the deployed application at azurewebsites.net. So if I start the client, it should prompt me for a query to ask the server. So I'll ask it. What is Azure App Service? One line TLDR. It gives me my response. I'll ask it one more. If you're familiar with LangChain tutorials, you might have seen this one. And it gives me that one, Socket to me. It's a great name. Okay, so what's happening here is the gRPC client is pointed to the gRPC server hosted on App Service. And it creates a channel that enables you to send these messages over a single connection. And since we're using a unary call in this case, it sends a single request and gets a single response back, which works for this particular use case. If you're dealing with a lot more data that needed to be streamed, we can use a streaming method, either from the client side, the server side, or again, both, that would still send messages over that single connection. So the benefit being here, as Brian mentioned, if we didn't have gRPC, you could be dealing with a multiple HTTP request, but because we can use a single connection, it reduces that overhead needed on the server and any complexities on the clients to handle HTTP patterns. So you don't need to deal with things like JSON serialization, since it uses binary payloads over an HTTP2 connection.
Awesome. So did you have to do anything special in your app to configure it for this?
Right. So on the app server side, there's three main configurations that you need to take into consideration. So if you go to your configuration blade and the platform settings, you'll need to set the HTTP version to 2.0. And this configures the app to allow HTTP2 client requests to come in. You'll also need to enable this HTTP 2.0 proxy setting and set it to on. This will enable the HTTP2 request to be passed along to the worker via the proxy. Right now, there is a bug. So when you set it, you'll see that it's not actually showing enabled, but it is. We are working towards getting that fixed. And the last one that you need to be concerned about or add is this environment variable, this HTTP 20 only port. I have set mine to 8282. It doesn't have to be a very specific number, but
this is a cool little segue because you're showing the new environment variables feature. This used to be part of configuration. It was called app settings because when we started with the platform, it was just Windows. Most people were familiar with app settings from the old IIS days. But we've had overwhelming feedback that what people think with this environment variable, so this basically up-leveling that configuration, and it's going to give you all the features that you already know and love, like the advanced editor and the being able to see all of your app settings and connection strings in one place.
Mm-hmm. Yeah, and to sort of wrap up, this environment variable is needed specifically because it's a requirement from app service to have a port that specifically listens to HTTP2 traffic.
Right, and in this case, the way the request gets routed is it goes from the client, it reaches the app service front end, and then from the app service front end, it gets routed to the worker, and then from the worker, it gets routed to your application. And this is the port that is going to be specific to the app, correct?
Mm-hmm. Correct.
Awesome.
Yeah, it's the port that's specifically listening for it. So. Yeah, but that's the demo. Guess we can go to any questions.
Yeah, and I guess also to mention, if you guys want to see bidirectional streaming demo, we did something similar for .NET Day, so we have that as well. If you wanna take a look, it's basically .NET with kernel syntax or syntax kernel. What's the name, Jeff? Remind me.
Mm-hmm. Semantic kernel.
Semantic kernel.
Yeah.
Right.
So it's sort of the Microsoft version of LangChain semantic kernel.
Right. And that one we're doing the bidirectional where we're uploading it. We upload a chunk of text and then we do the processing there with the OpenAI. You were going to say something, Jeff? Sorry.
Right. No. Yeah. I do have a link to the demo that we're showing today, and I will share that in the chat so you can see or try it out for yourself.
Awesome. And just to fill in a couple of blanks, I think we have a couple of questions. Do we want to pop them up, Haley, or? So I think we have one that is about the environment variables features. Is that going to be coming to functions too? Yes. Right now we're starting with it on web apps. We're flighting it, so not everybody's going to see it, but eventually it will get to everybody. That's how we do releases, so that we make sure that everything is working and we don't break everybody at the same time. If we have something that's not working, that never happens. And then the idea is to take this experience over to both functions and static web apps. So awesome. I have the good luck of owning the user experience for all of those services, and we try to make it cohesive so that it's all kind of like the same. And if you're familiar with one, you should be familiar with all the other ones.
Awesome. And you knocked out the first question yourself. I just wanted to say thank you so much for the presentation as well. I love app service. That's where I usually deploy. I've had a little bit of fiddling with LangChain, and I'm not familiar with gRPC. So I'm definitely going to go to the demo application that you're putting in the chat and check that out for myself. Really excited for the presentation.
Awesome. Thank you.
I think we have a little bit of time for the next question.
Yes.
Is there one that you see that looks interesting to you and I can read it out? We'll add it onto screen.
So there's one, I think there's two people asking the same thing. It's from Jason. Where did you get SSL channel creds or awesome. gRPC creds? Do you want to talk to that one, Jeff? I think all of this is the way SSL is negotiated. It's all negotiated on the front end. So that's where the handshake happens, and then the stuff that we get over on the worker is unencrypted. So two things are happening there. One is we're offloading that CPU that is the overhead of doing the SSL handshake to the workers, which is shared infrastructure. That's super convenient for you because you're not using CPU cycles on your worker that you're paying for. That's happening on the front end. So I'm not sure if that is answering the question, but that's how I understood it.
And I think we have time for maybe one more.
Mhm.
Let's see. Let's get another good one. There's so many great questions. Could we do the, how about the environment variable one? Does that one make sense, fit what we're looking for today?
I think we talked about that already. Like what
Okay.
are the, yeah. And people I think are asking for the link to the repos. We have it there.
Great.
The other thing, just a reminder that we also have, there's the Azure developers handle on Twitter, but there's also one for app service specifically, which is at AC app service. I'll drop it in the chat so we can probably throw something there. And that's also like a couple of things. We're not going to do support requests, so don't come at me with my app is broken type of questions. But if you want pointers to docs or links, or talk about where can I file a feature requests, those are the types of things that we deal with there. And we also put links to docs or things that we see people doing interesting stuff. If you want to learn more about what other people are doing, that's like a good channel to get connected into that. Let's see what else. Just in general, I know that we're talking about Python, but I think this is the second session where people talk about deploying their web apps to app service. So I wanted to touch on why that is a good idea. And the way to think about it is when we talk about infrastructure as a service versus platform versus containers and Kubernetes and whatnot. We think of app service as a high developer productivity environment, which means you don't need to learn how to manage a kube cluster if all you need to do is run a single container or run a web application. And app service does a lot of stuff for you from a platform perspective, right? Like we make sure that the Python runtime is always up to date. I think it's something like no more than 30 days from a minor version being released that we get it on the platform. The new version of Python is coming out, so I think that's going to be happening in October. You should see it in the platform shortly after that. So those are the type of things that the platform gives you, and then we're looking at also like features, right? Like for example, in this case, we were demoing gRPC. From your perspective, you're not having to build this multiple layers of how am I going to distribute the gRPC traffic that is coming into my applications. Just you turn it on, you enable the proxy, you say what port, and the platform takes care of that, right? The SSL uploading, that's another great example, right? We make it so that it's not something that you're necessarily having to pay for. It's taken care for by the platform, and we try to do it in a way that is battle hardened, battle tested, so that from your perspective you're just turning on a feature, but behind the scenes there's thousands of lines of code and multiple hours of work from our engineers that basically build those things, so that literally all you need to do is turn the feature on.
Yay! Oh my gosh, that sounds great. I'm excited to jump into the demo. And I think we're also going to provide a link to that demo as well. We had the name of it below, but I think we're already also going to put in the chat the link to that demo.
Yep.
Cool.
So I think that wraps it up for us. Thank you so much, Jeff. Thank you so much, Dawn and Haley. And I know Jay is also doing work over in the comments. So
Jay is our
so
superstar. All right. Thanks for having y'all. Bye, y'all.
Yeah, and we'll see you all on the next App Service Community update coming in October. Yep, Thursdays. Bye.
Thanks so much. I'm so excited. This was such a great presentation, and I wanted to go over another question we had in the chat about cloud skills challenges that we have. We do have cloud skills challenges planned for today. These are guided learning materials that will take you step by step through Python competencies and many other competencies. We have like tons of cloud skills challenges over in the Learn section of Microsoft. And today we have one that's set up for AI and machine learning. We have a web development one. We have a data challenge. And then we also have a beginner Python challenge. So check those out.
Yeah, so it's super cool because we're learning a lot today about how to get started, but how do you actually take what you learn and put it into practice? How do you get started doing this hands-on? And so looking at our Cloud Skills Challenge, if you follow the link that we just added here down below, the aka.ms/Python CSC, which is the Cloud Skills Challenge, there's a lot of different places that you can get started. And so yeah, as Don mentioned, AI and machine learning, web development, depending on what your skill level is, what you're looking to learn, there's so many different ways to get started and get hands-on learning to understand what you can do with Python and Azure. So I love these. I think this is a great way to practice your skills or learn new skills. So definitely follow that link below. So yeah, thanks for asking that question in the chat. Going back to the agenda as well, we have a whole bunch more queued up for the rest of the day. But I, of course, have to comment. Make sure you please subscribe to the YouTube. As Byron mentioned, and we keep mentioning, we have the weekly Azure community stand-ups, and so all of the great services. And so here we see AZD is up next. Their community live streams are on Wednesdays, every third Wednesday of the month. Azure SDK also has their live streams. I forget what day their live streams are, but I'm sure Rohit will tell us when we get there. So that we have a full day of really exciting things, lots of resources to get started. And so it's not just about learning new things, but it's about trying it yourself and being able to download this. So all of these will be available on the YouTube to keep watching. So if you missed something or if you want to go back, all of it will still be available afterwards. Completely forgot to mention, if you need to access this afterwards, here is the link to all the information. We will also be posting the links that people and PowerPoints people have been sharing. All the speakers have had great resources, great demos, and so we want you to be able to access those, and so you can try those as well. So those will all be available here, aka.ms/azuredevelopers/Python Day. That's where a lot of people went to register, and so all the resources will be there, including the agenda, the speakers, the what's what of Python Day. But Azure Developers has been a really, really cool addition to our ecosystem for Azure, just a way to connect with the community. We had been missing that, I feel like, but this has been a great way so we can actually talk and answer things live and share the newest things that's going on in Azure services.
And I love a full day of Python. Yeah, you're not going to have me miss out on that. So thanks everybody for joining. We keep having people come in. It's been such a great crowd today. So keep putting things in the chat. And we also have some, we gave Jay a bit of a shout out, but we have some superstars of Microsoft Pythonistas jumping in the chat and answering questions as the presenters are speaking too. So if it doesn't get answered on live, hopefully we can get someone to answer your questions in the chat. And could I plug our Discord now? Would that be a good time? Okay.
Oh, yeah.
So we have two different Discords for you. So we have a Python Discord, aka.ms/Python-Discord. And that's where we talk all things building stuff with snakes. You can find me hanging out in there. And it's more general purpose, but like really a lot of fun. And we also answer Azure questions or playwright questions and things like that there too. And then we have another Discord that is more polyglot, aka.ms/Azure Discord, no hyphen. And that's specifically for what we're talking about today, all things Azure, getting your Python up in the cloud. And we have a bunch of really cool friends who hang out over there too.
I do see a comment here from Doug. They did attempt to access the first coding challenge. I will look into this to make sure that everyone can get access. Yeah, this is not just for certain people, this is for everybody. And so I want to make sure that all of y'all can access the coding challenges. So we will look into this and we will get back to y'all.
I love the Cloud Skills Challenges. I'm sure we'll get it turned around quick.
Yes.
Because I love those. Jump into those.
Yeah, this is such a great way to get connected with the community, be able to answer your questions live. I love being able to pull the actual people who work on the different services to talk to everyone. Sometimes it's just everyone's hiding behind a screen of they're developing it in secret in the dark. And so it's really cool to actually come on camera and talk to the community, show off what you're building, and answer the questions that people are actually really want to know. And so it's, you get to ask whatever you want, nicely, of course, but pop them in the chat and we'll answer. These are the real people who are coding the actual services, the features, the updates, people who are planning what's coming next. And so if you have things that you would like to see or issues that you're having, this is a great way to surface those to the teams who are in charge of this. It has been super cool for me to be able to experience these and see what the community is working on. We also love showcasing some of the things y'all have been building with these services. And so we like giving shout outs to the cool stuff the open source community has worked on. So connect with us in that way as well. Show us what you've done, and we would love to show it off in some of our community stand-ups and just give y'all shout outs. I think that's super fun.
I love app demos. I love app demos for the community and the audience. We had 2 great app demos today. I was on mute, thank goodness. But we had a silent ooh when we had a function sending an email with the database update, and we got a whole slide talking about why Cosmos DB. So I was so appreciative of both the presentations that we've had so far, and we have so much more in store for today. So it's a great time.
Oh yeah. Seeing the real world examples of like how we can use this, what we can do, and actually make these into real world features, not just some hypothetical hello world app, like the real deal. I think this is super awesome.
Exactly.
Yeah. So definitely go check out the Cloud Skills Challenge, as we mentioned before, and so you can start building all of your real world applications. Again, we popped that below here. But yeah, we are coming up near time, and I know Savannah is hanging out waiting for us. So we might pull her on a little early and cool. Surprise her. She's smiling over there. Are you cool with that?
I love more Savannah.
Oop. I'm going to stop clicking. There we go.
Hey!
We just teased you for too long.
I was like, there's some time between these sessions. I'm like, I don't know if they're going to pull me on early and chat. We're all friends here. It's all good.
Yeah. I count myself very lucky every time I get a meeting with you, Savannah.
Oh.
Hello from across the country.
We need more meetings together, or like less meetings, but just like we need to hang out more.
Yeah, can we just hang out on this chat together? Yeah, we can just hang out on this stream together. That works.
Yeah. I should do a Python Pulse app with you or something.
I love it.
Plugging Python Pulse if it hasn't been plugged yet today.
Mm-hmm.
It hasn't. I am on a live stream every second Friday of the month, and it is Python focused. We talk a lot about VS Code. We talk about Azure. I would be honored with with Savannah on the stream. So come. You said it out loud. So I'm gonna get you over.
Okay, let's do it.
I already see a comment on AZD. Everyone's excited for AZD.
I mean, what can I say? It's a pretty cool product. It's a pretty cool tool. Pretty excited to talk about it today.
Awesome.
As per usual, but
of course.
Is it my intro, Haley? I can jump in and say, okay, I'm honored. Okay, great. I love speedruns. It's such a fun way to absorb what the process looks like. And today, our process is using AZD to get our Python into the cloud. Savannah's done a variation of this presentation before, but I am so excited on what she has cooking, because she's always has something new for me. If you're interested in seeing that presentation from before or more things that we did at PyCon US 2023. It is under the Microsoft Learn. If you look for our events, we have PyCon 2023 content up there and like a lot of really, really cool stuff. But don't want to deter from Savannah, the name of the game today. And you can also see Savannah every third Wednesday on the Azure YouTube channel. So right where you're at. Take it away.
Cool. Yeah. Happy Python Day, folks. Really excited to be here today. We're going to be talking about how to speedrun your Python deployments using AZD. First, I'm going to, talk a little bit about like a problem I think a lot of us have faced in the past and why working in the cloud can be pretty challenging. Then I'll talk a little bit about AZD as a solution to this problem. And then we'll finish up with a live code demo, which I know everyone loves, and how AZD can help you in your end-to-end workflow. So to start, we're going to hop right in. I'm going to ask you to recall a time when you were building an application. You probably went through some form of speccing or ideation phase, or maybe you had like business requirements from someone. And if you can't think of something, maybe let's consider a to-do application or something super basic where you can an app where you can keep track of daily tasks. You probably want the ability to add tasks, add due dates, tick things off when you've completed them, or organize them by categories or into lists. And I think for most folks, this is fairly simple. Because at a basic level, you need 3 major components. You would need your front end, your back end, and a database to store all the tasks and all the right metadata. So from there, you may need to make the first set of big decisions about your application. And you might have some existing knowledge about libraries and frameworks, have a tech stack that you've used before, or you might need to do some research to identify the best options for your application. But after careful consideration, you might take those components that you outlined in your sort of like ideation phase and choose some libraries and frameworks to move forward with. So maybe that's React for your front end, Python with Fast API for your back end, and maybe MongoDB or Postgres for your database. Or maybe you started building and designing in tandem. I'm not here to mandate your development process. Either way is cool. But then you get your local prototype working, and then comes the fun part: getting the application up and running and hosted somewhere in the cloud. And from there, you probably need to do some more research, and this can quickly spiral into a lot of questions as you research and stumble upon official docs and blogs, tutorials. More questions pop up, like which cloud services should I use with my code? How do I set up my local development environment to be productive when working with the cloud? How do I provision the right infrastructure for my application? How do I know that what I'm doing incorporates security best practices? And some of these questions might not have answers that are super straightforward. And even after doing some research, you might end up with like, it depends on X, Y, or Z being the answer to any one of those questions, which makes things like pretty complicated and also maybe a little bit frustrating at times. But why is it so complicated, right? Why does it have to be so complicated? And I think that if you've ever considered investigating cloud services, you might have been confronted with a solution that looked something like this. And right off the bat, you can kind of see that basic web app, our 3-component app, turned into many more things when we added the cloud to the equation. And these resources don't really map one-to-one with those components, which adds complexity. But not only that, there are also new problems added to the mix, like setting up roles and permissions, getting our local development environment set up, configuring a CI/CD pipeline, and more. So obviously, that's like a lot to think about and manage. And what started as a pretty simple web application actually turned out to be a little bit more complicated when we add the cloud to the equation. All in all, answering all of those cloud-specific questions, provisioning infrastructure, deploying code on Azure, it's a lot to think about and manage, especially if you don't have, you're not well-versed in cloud infrastructure, architecture, best practices, all that good stuff. But if you're a new developer, you're already sort of like inundated with learning how to write Python. You might not have the bandwidth to take on learning yet another thing. And if I think back to when I was learning how to write code, I was usually focused on one piece of engineering or one concept at a time. Like I'm trying to write Python, or I'm trying to learn about React. So maybe you don't have the bandwidth to really go and dig into the cloud. And if you're if you're working on business logic or even a professional engineer, you might not have the time to learn about the ins and outs about the cloud. You might want to just focus on writing your application code, and cloud things end up being really peripheral to the primary task that you're trying to accomplish. It's kind of a hurdle on the path from A to B, where A is some problem and B is some solution for your customers. And sometimes you have a dedicated DevOps engineer or a dedicated engineer that thinks through all this engineering systems bits of your product. But sometimes that's not the case. If you're working at a startup or a small business, or you're working on a hobbyist project, or you're a student, this problem of, you don't have that person. So the problem of going from local development environment to the cloud, or provisioning infrastructure and deploying code, is ultimately something that hinders your productivity and your velocity. But thankfully, this is where I think tooling can really help us in that end-to-end journey from, your GitHub repo to local development environment to the cloud. So I want to take a second here to introduce something that my team has been working on for the last couple of years, which is the Azure Developer CLI, or AZD. AZD is an open source tool that provides higher level application developer friendly commands that map to key stages in your developer workflow, so that you can focus on writing application code instead of focusing on atomic operations on Azure resources. So we have commands like AZD provision and AZD deploy and AZD up, instead of commands that interact with specific resources that require you to pass in a bunch of flags and parameters and arguments and are maybe difficult to remember. We want to keep things simple and easy to remember. That's the name of the game here. But you might be wondering, where's the magic here? Like, how do we get away with keeping things so high level? And so our approach is rather declarative in that the CLI uses extensible, customizable application templates that include everything you need to get up and running on Azure. I like to think of these templates as like cloud blueprints or recipes that include sample application code that's like a proof of concept, reusable infrastructure as code assets that are either written in Bicep or Terraform. These templates go far past Hello World. They include kind of all the bells and whistles that you would need, even to set up your local development environment. So things like editor configurations for VS Code, pipeline definitions, like kind of like skeletons for that, dev container configurations, and more. And so with the CLI, like the idea is that we're not just supporting you in the provisioning and deploying phase of your development process, but also supporting you day to day as you work against cloud resources and use them as part of your application. These templates are also intended to be somewhat programming language idiomatic. So the conventions used in the template are conventions that you should be kind of familiar and comfortable with. We try and keep them as Pythonic as possible when they're Python templates. But really the idea here is that these templates are something that you can build on top of. So you might look at a template and say, that maps to my local application stack. It has React, it has Python, it has a Postgres database. That's the right recipe for me. And then you swap out the sample application code in the template that's included so that you can kind of identify it's the right thing for you, and then customize it and kind of leverage the infrastructure as code assets that are in there that define all your resources on Azure without having to get too deep into the weeds on day one. Okay. Last slide before kind of demo. I did want to take just like a brief second to talk about infrastructure as code in case there are folks that aren't super familiar with this space. As I mentioned before, AZD and any AZD compatible project has infrastructure as code files written in either Bicep, which is domain-specific language used for provisioning Azure resources, or Terraform in an infra directory. And this directory and the files inside it are like really integral to how the Azure Developer CLI knows what to provision for you and how to deploy your code on Azure. And if you're unfamiliar, infrastructure as code is really just a way that you can manage and kind of provision your cloud infrastructure and services via code. The files in this directory specify like the services you want to create, their configurations, and how they interact. And using infrastructure as code, we can really ensure that the environment is created the same way each time that we deploy to the cloud. And so infrastructure as code means that you and your team don't have to manage or maintain individual environment settings. You can all work off the same well-documented code that represents your desired environment state, which helps you avoid deployment issues by keeping everything super consistent. With the template ecosystem, you don't have to learn about infrastructure as code on day one, about learning about the cloud or using AZD. But I did want to highlight these files before we get into the demo because they're really important for AZD to like know what resources you're going to use and how to really deploy your code and actually set up your application. But the best part is that you start with these files and then, on day one, and then you can go and dig into the cloud specifics more slowly as your application requirements change. Okay. It's demo time, the moment everyone's been waiting for. Okay, I'm gonna hopefully switch over to VS Code. I think it is showing, so we're good to go. We are looking at a template that is a containerized React web app with Python API and MongoDB on Azure. So if I was writing a JavaScript front end with Python API, this app uses Fast API. You could use Flask, you could use Django. We have flavors for that too. But basically, if I scroll in here, and I hope this is big enough, and y'all can tell me if it's not. But if I look through here, we have a brief description about this template that I pulled from. There's a couple different places you can find templates. You can find them on GitHub using the AZD templates topic. We have an open source template gallery, which has Microsoft authored and community authored templates called Awesome AZD. Or you can actually just run AZD commands, and we have a selection of them in the product itself. I got this from our template gallery, but basically we have a blurb about the template. We have a brief screenshot about what's going to be produced here. In this case, it is a to-do app. I don't have to care about the to-do part. We're going to see why in a second. I have my prereqs. So we have obviously the Azure Developer CLI for our provisioning and deployment. We have Python, Node for our front end. And we're also going to be doing all of this in containers, hosting everything on Container Apps. So we need Docker. We have a quick start, which we're going to go through in just a second. And then the last thing I want to show in the README is an application architecture diagram. Because I'm so zoomed in, this is going to be like I have to scroll to show you it. But basically, this just shows us how all of our resources, all the resources we're going to use for this application and how they're wired up, how they interact. So kind of giving you a bit of context there. Okay, I also have the Azure Developer CLI extension for VS Code installed. If I can like scroll and find it in my list of stuff. Oh no, Ubuntu, sorry. Here we are. This provides us with some nice entry points to AZD functionality. It does not install the Azure Developer CLI, but it gives you some like nice gestures in VS Code that make it a little bit easier to use AZD if you're not a terminal or shell person. I obviously have the Azure Developer CLI extension or the Azure Developer CLI installed already. I type azd-h. We can see all of the commands, a bunch of commands, some of the ones that I mentioned earlier as well, like azd up, azd down, provision, all that good stuff. But let's talk about, before I kind of jump into it, let's talk about what makes an AZD template an AZD template or compatible project. So the first, and what I would argue is maybe the most important file, is an azure.yaml. This is a really basic YAML file. I am not a YAML fan. I think every time I see a YAML manifest or Kubernetes manifest, I'm like, it's kind of a lot of boilerplate. We try and keep this super simple. But basically, the takeaways in here are that I have two services, or you can think about those as your two components that we had in our local app stack. We had our front end and our back end, and we had a database. In this case, we have web, which is our front end, and API, which is our back end. We are pointing AZD to where the source code lives. In this case, we have an SRC directory with API and web subdirectories. You could structure this however you want. We don't mandate any particular like file structure. So long as you can pass in a path, you're good to go. We also specify a language. This is JavaScript with Python, both hosted on Container Apps. So this is really like how AZD knows what code is going to go where and how it stitches everything together for you. So I like to think of this as the AZD file. The next most important thing, and the only other real requirement of an AZD compatible project, is an infra directory with a main.bicep or a main.tf if we were writing Terraform. In this case, I have bicep. That is the domain-specific language that Azure has created for infrastructure as code. But in here, the thing that you can really like glean from this, if you don't want to go too deep into the weeds, is that I have all of my resources at a top level included in this file. So we've structured this in terms of modules. So there's no magic here. You could totally like click into each one of these things, go and like see what kind of SKUs, configurations, all of the knobs you could turn on the services. But we try and keep it high level so that if you went in here, it's not like immensely overwhelming because there are a lot of configurations you could set. But in here, we can see we've got a resource group, which is our like bucket for our resources on Azure for this application. We've got a container apps environment and a registry where we're going to push our container images to. We've got two container apps instances for our front end and our back end, Cosmos DB with MongoDB API for our database, Key Vault for storing our application secrets. We do not want to be inlining our tokens and passwords because that's not a security best practice. Monitoring infrastructure, which includes a dashboard in this case, which I'll show in a second. And then also optionally a feature called Azure API Management, which would mediate requests between your front end and back end. We're not going to enable that for this run, as it does take a little bit to deploy and or provision, but you could enable that. And then at the bottom, we've got like a million different outputs. These are all things that are going to end up in a .azure directory. I've already run this ahead of time to save us a bit of time. But basically, these things all end up in a .azure directory, which is in here. I've got like a .m file, and all of these basically end up in here at the end. And this is like how AZD knows, where all of your endpoints are, all that good stuff. This is not checked into source control. It's something that is required for you in your local or wherever you're running AZD though. Okay, let's get into it because I've talked at you for a while. So I'm gonna clear this out. I have a couple different ways of firing AZD commands. I could obviously just type it in the terminal, but because I have the VS Code extension installed, I could right click on my Azure YAML, go down to the context menu, which has Azure Developer CLI, because the CLI or the AZD extension kind of inserts that into this context menu on the Azure YAML. And then I could go to a command called AZD up. This is what I would argue is the most magical AZD command in that it combines 3 commands into one command so that I can, run it and kind of go get a coffee and wait 5 minutes and then have everything be done for me. It's not really magical, but I like to think that it's a little magical. So I've already run this ahead of time. When you run this the first time, it gives you some prompts. It asks you for an environment name, which is really, I have that in here as well. Let me find it. Well, the environment name is really this, my Python day, this string. Yeah, here we are. This is not your virtual environment name. I want to like really echo this for this audience because I know that environment is sort of an overloaded term. But in this case, environment name is like a string that will be used to differentiate copies of your application on Azure. And so it ends up being part of your resource group name, which is your bucket for all of your resources on Azure. We support multiple environments, and you can imagine why that would be powerful if you think about having dev, test, and prod environments. AZD does handle that. We're not going to show that today, but we could do that. We also are asked for a subscription, so I can authenticate using AZD. I've done that ahead of time. Pick my subscription that I want to use, and then pick a location. In this case, I just picked West US 2, but you could pick whatever you like. So then, once AZD has that information, we kick off each one of those commands, AZD package, AZD provision, and then AZD deploy, which are combined for AZD app. During package, because this is a containerized application that includes Docker files in each of these subdirectories, AZD will go off and create the container images for you. You could also, use these hashes and to test the images locally if you wanted to. We try and keep things, again, very transparent. We strive to be very non-magical, and you can really think about AZD as like a buddy that is like orchestrating a bunch of work on your behalf. And so AZD creates these container images for you using AZD package. I will plug that as of today, literally today, this morning, we now support cloud native build packs. So if you don't want to write a Docker file and you're targeting container apps in your Azure YAML, like we are for this project, AZD can use cloud native build packs to infer your local application stack and then generate the container images for you. If you opt into that experimental or alpha stage feature, no Docker file required, which is pretty cool. All right, we are already like blazing through provisioning. So now what we're doing is we're essentially going through that bicep file that we looked at earlier. Let's go back to that top level bicep file. And here, like all of these big top level resources I talked about, like the resource group, the key vault, we got log analytics workspace, Cosmos DB, container apps environment. All these things are being created for us without having to go to the portal. And I really love this because they're human readable names, which I love. I also have a unique identifier that I could go and reference in the Azure portal, look at the deployment, get a sense of, what's going on, but I don't have to. For me, like staying in my local dev context is really important to me. So I don't want to go jumping around between, browser and editor. Like if I can stay in my editor, I'm pretty happy. Okay, so this is going to take like five-ish, 6-ish minutes. And the reason for that is that we're not just zipping your application up and throwing it on a VM. We are literally creating all of the cloud native infrastructure that you need to run this application, trying to give you kind of a best practice foundation. We're creating resources, setting up roles and permissions, wiring everything up for you so that you're set up for success and you can make big changes later on with very little effort. So really thinking about this in a cloud native way. Okay, we're going to do some demo magic here because I don't want to wait for 5 or 6 minutes because we are getting close to the end of the session. But as this would finish, we'd see the last of our container apps created, and then AZD would go and they take the container images that we created, push them up to a registry, and then use them to create the container or to set up the container instances for our application, for our API and our web, and then print out 2 endpoints for our API and our web services. This completed in 6 minutes and 38 seconds, which I think is pretty cool because with AZD up, I just ran this and then walked away for 5 minutes and came back and it was done. So if I go and I click this, I'm gonna see that I have a swagger.yaml or openapi.yaml or whatever you want to call it these days to explore my backend. And then if I wanted to, I have well, I do want to. This is arguably the most important part is that I have a fully fledged application running on Azure infrastructure. I can go and I can add things to my database. I can, actually interact with this, and it's fully set up for me, which is pretty neat. So that's kind of the main piece of AZD is that AZD up. The next thing I want to show really quickly is that we do also support we have a gesture called AZD monitor. I'm actually going to show a different way to get to AZD functionality by opening the command palette and running Command Shift P or Control Shift P, depending on your operating system, typing Azure Developer, CLI, and then monitor. When I run this, it just runs AZD monitor, and then I'm given some options. I can look at live metrics logs or the overview dashboard. I bet you I'm going to have to authenticate. We'll find out in a second. But basically, the reason that I love this is that it allows me to jump right to where I want to be in the portal without having to like click through a bunch of different screens. This was created for us during the provisioning stage, and all of this dashboard is actually included in your infrastructure as code. But what's really cool about this is I think that it provides you with like a pretty cool, solid foundation to get usage, reliability, responsiveness metrics, and then like a very seamless gesture to get right to where you want to be. Again, I like staying in my local dev context in my editor. So if I can avoid kind of all of that that ceremony of getting to the right place in the portal, I'm usually pretty happy. Okay, last sort of like demo is arguably my most favorite AZD feature, which is AZD pipeline config. I like AZD pipeline config because it really, for me, it's great that we can trigger a manual deployment, a provisioning and deployment. But if we're building like a real application, a real production application, we do not want to be doing that from our editor. We want to be doing that in a pipeline that we've like codified and that we have, you know, a GitHub action written that we can trigger on tag or push to main or master branch. So if I go into my .github directory, we have provided a sample GitHub action. I say sample because really you can customize this, but this will get you your provisioning and deployment in your pipeline. We also support Azure DevOps. GitHub Actions is our default provider, but you can totally use Azure DevOps if that's your flavor of CI/CD provider. But if I go in here, I can see that I have it set up to push on main branch. You could change this if you want. We also are referencing a bunch of like repo variables, repo secrets, instead of doing kind of interactive stuff. So we're like storing that on the repo and then referring to it in the pipeline. We use the official AZD GitHub action to install AZD in the runner. We are going to use federated credentials, which is OpenID Connect or OIDC, which is a security best practice. That's the default credentials source in GitHub Actions. And then, so this block will be skipped. And then we have AZD provision and AZD deploy, which are sub-steps in that AZD up command. The only difference is that we're using -- no prompt and then leveraging those repo secrets and variables instead. So in this case, I guess what I will say is that you might, if you've done this before and you've set up repo variables, you know that it's kind of tedious, especially when you want to deal with creating service principals and all that kind of stuff. So AZD has a command I'm going to show just generically in the terminal called AZD pipeline config. This will scaffold our pipeline for us. So what it'll do is it'll, in a second here, it will go off and start creating a service principal so that GitHub and Azure can talk to one another. And then it'll set up a bunch of repo variables for us so that AZD can reference them in the pipeline run. And then I will go and I'll commit it. If you didn't have a repo already set up, AZD could also push to a new repo or push to an existing repo. And then, again, I like to stay in my editor. I have the GitHub Actions extension installed for VS Code, which means that I can monitor my pipeline run from within my editor without having to go to GitHub. So I can see all the same steps that we talked about here and the progress of each one of those. And now every time I commit code or push directly into my main branch because I'm I don't know, breaking the rules, I could trigger this pipeline in this case. So that's pretty much the end-to-end AZD demo. I'm going to pop back over to my slides and close us out here. But there's one more feature that I want to talk about, which also was announced this morning, but is rolling out later this month. But we've talked about this template-centric workflow where I find a template, I modify a template, and then run an AZD up. As of this month, we're going to start rolling out a feature which we're calling the simplified or easy init flow, which will basically allow you to pass in your code base. So maybe you already have a locally working prototype by running AZD init, and then have the CLI infer your local application stack. So maybe that's Python, React, Postgres, and then the CLI will go and generate the configuration so that Azure YAML and the infrastructure as code to get your application up and running on Azure. And then hopefully you can run AZD up with little to no modifications for Azure. And so we're actually going to be leveraging those cloud native build packs that I mentioned before if you don't have a Docker file. And then for our V1 kind of experimental offering, because this is a very new feature, we will be targeting Azure Container Apps. So really, if you want to write your own Docker file for your front end or your back end, totally welcome to do that. But this is powered by cloud native build packs via the Oryx build system. And so you don't have to think about that if you don't want to. If you do see this feature come out, I think we're targeting around the 20th. It is experimental. Please let me know if it worked for you or did not work for you. And if you have any feedback, I would be so elated to talk to you about it. I'm super excited about this feature. I'm sure there are 1 million edge cases for us to go and chase down. So really looking forward to your feedback on that. Okay. Let's close out here. To wrap this up, this is kind of what we saw. This is the AZD workflow. So the first question might be, what do I want to build? And this is that ideation phase of the development process that I mentioned earlier. But via the AZD template list command or AZD init, or going to our templates topic on GitHub or to our template gallery, you can find a template that kind of maps, supports you in finding that right foundational recipe for your application in the cloud. You can use AZD init or just git clone or open it in a code space to get it into your local dev context. And then from here, you can modify the template to really make it work for your application specific requirements. Remember, these are designed to be very flexible. Make them your own. You could also make your own code base AZD compatible if you want to write infrastructure as code. We have starter templates included in AZD init that give you all of the bicep or Terraform modules to get started. Then it's on to the cloud with AZD provision and AZD deploy. These commands are used to provision infrastructure and deploy our code on Azure based on those infrastructure's code assets. But better yet, you can use AZD up like I showed earlier, which combines AZD package, AZD provision, and AZD deploy into a single step. And then finally, we talked a little bit about best practices using AZD monitor and then AZD pipeline config to set up our monitoring infrastructure and get to our dashboards, and then also set up our CI/CD pipeline. So that pretty much wraps up this talk. I hope that I convinced you that cloud doesn't have to be so hard when you have the right tools to support your workflow. And I will leave this slide up just to give folks some handy links. I'm sure some of these have been passed in on the stream already. Like Dawn and Haley mentioned, we host community stand-ups once a month following our monthly release. Our next one is on September 20th at, I think, 11 a.m. Pacific time. We would love to see you there. It's a good time to ask the team a bunch of questions and learn about new things that are coming to the CLI. Otherwise, there's some links here for installing the CLI, going to our docs, looking at our GitHub repo, which is fully open source, and then our template gallery. And this is a short link to get directly to all the Python templates. But yeah, thanks so much for listening. Would love to. I'm really excited to see what you all build.
I definitely thought the cloud was scary before this. Now I feel better about it. Now I like the cloud. I
mean, I'll be honest. So I worked on the Python language team at Microsoft before working on AZD, and I used to really be scared of Azure. I think there's a lot to learn there, and so I think we're trying to accelerate your journey, but not make it so magical that you can't understand what's going on. I think that's my personal goal.
No, I love it. This has been so exciting. Every time you do one of these talks, I learn something new. It's the coolest thing ever.
Oh, thanks, Haley.
So we have a bunch of great questions here. Okay. We'll go through a couple while we still have time here. So I did want to pull up this. Doug asked, can already existing applications utilize AZD if they weren't set up with it?
Absolutely, yes. So I think the intention really is that you're not just deciding to start with AZD. The idea, right, is that you can either go find a template to map to your local application stack. So maybe that is React and Python and Postgres or Mongo or something. And then basically pull that template code, initialize your application with that template, and then inherit all those infrastructure as code assets so that you can get up and running on Azure quickly. But also with that new template, that new feature that I mentioned, that simplified init flow, what you could do is also run AZD init and then pass in your local your code in your current context, and then AZD will say, oh, I detected these languages in these paths in the project. I think you will want it. We're going to do container apps for our first offering. So it'll basically say, yeah, we can use container apps for this, and then generate all of the infrastructure as code, all the configurations for you. It also will give you a nextsteps.md, which will help you kind of understand what was generated, if there are any troubleshooting steps that are needed before running AZD up, and kind of guide you through what just happened, because lots of stuff happened. But yeah, definitely like this is like the prime use case is like, I have my local prototype, now what?
Mm-hmm. How about the relationship between AZD and Copilot?
Yeah, so I mean, AZD is not AI infused today. That's you can definitely use Copilot to help you write like application code for your app, and like we also include things like dev container configurations in some of our templates, and so you could definitely like install it as part of your dev container image. But AZD itself doesn't have like a direct relationship with Copilot. I do think that they marry nicely together, and I use Copilot, like Copilot and Copilot chat in my workflow with AZD, and it is like a power move, I would say.
Cool. One last question here. This is very cool. Definitely agree, JD. Will this work with Azure Functions?
Yeah, we have actually many different templates that use Azure Functions. There's a to-do app flavor one that like of the app that I showed earlier. Instead of being on Container Apps, we have one that uses static web apps and then Azure Functions for the backend. But there are plenty in our open source template gallery.
Awesome. Speaking of the template gallery, KJ Miller called out Pamela Fox for some of the awesome work that she's done in the AZD templates gallery here. And I just wanted to pull this up because I think it's super cool seeing what the community has contributed. And I'll also pull up the banner here.
It's like it's very awesome to see people that are, you know, in the community contributing to the template gallery. I mean, shout out to Pamela, shout out to all the Python CDAs that I work with, all the cloud developer advocates. Y'all are amazing, and working with you is a joy. These templates there's like literally a flavor for everything. You want to do like an AI powered app with OpenAI. You want to create your own chat GPT powered by your own data. We got it. It's in there, and I'm like super excited. I will also say this website is getting like a complete revamp in the next like month and a half, and so it will look like even more glorious once we've had so many contributions that now the filters look a little wild, and so we're going to be restructuring this website to make it even easier to browse. So definitely stay tuned for that.
Yeah, this is super cool. Link is down below for the template gallery here.
Yeah.
But yeah, thank you so much, Savannah. This was awesome. I know I kept you a little bit late and we pulled you on a little bit early because you just have so much great content to show.
I can't stop talking about AZD, y'all. But yeah, come hang out in the community call or ping me on X, Twitter, whatever you want to call it these days. Happy to chat. Thanks.
Yep. Bye, Sav. Before we move into the next session, I also just wanted to add, we had great sessions at PyCon US this past summer here. And so if you go to the link, I'll add the link into the chat, but we had perfect, it's right down there. We had a bunch of great sessions. And so I know we've been linking the Cloud Skills Challenge. If you just want to learn more about Python and Microsoft, how we work with Python, there's a bunch of great sessions here. So check out that link below. We'll pause for a minute just to make sure that everyone can see that there. I also want to call up our next speaker. We'll be talking about Azure SDK. And of course, I have to plug the community stand-ups. Those are on the second Thursday of every month. And so talking about Azure SDK, all the great goodness that there is to learn about and connecting with the community. So I would love to invite Rohit up. How you doing, Rohit?
Hi, happy to be here.
Yeah, super thrilled to have you.
Yeah, just to piggyback on the community stand-ups, they're every second Thursday of the month, and next week will be focused primarily on Python, so I'll be there, as well as Krista, another engineer on our team. And if you saw us at PyCon this year, we both attended, so yeah, would love to see you there.
Yeah, a lot of great sessions, a lot of great things, learnings from there. What are we learning about today?
Yeah, so today is an introduction to the Azure SDK for Python. And essentially, I'll be going through the basics of what the SDK is, kind of some of the patterns that you follow when you're working with the SDK, and then I'll do a short demo of a few SDKs for our various Azure services.
Awesome. Make sure y'all add your questions in the chat, and we'll ask Rohit all the questions at the end. Take it away.
All right. Hi, everyone. Happy Python Day. And I see the comment from KJ. Hello. I'll get started. So yeah, the title of the talk today is Fast, Simple, and Idiomatic. So it's an introduction to the Azure SDK for Python. And let's just jump into it. So some of the assets, looks like they didn't load, unfortunately, but it's fine. The agenda for today is an introduction. Then we'll go into the benefits for the Azure SDK for Python, so why you want to use it. Some basic steps to using the SDK, which is pretty consistent across all of our various libraries. A quick demo, and then we can close with Q&A. So starting off with an introduction. So the Azure SDK for Python, what is it? The Azure SDK, in short, this kind of sentence, is a collection of Python libraries designed to provide an interface for developers to interact with Azure services. So in short, if I'm writing Python code and I want to interact with one of the many services that exist within Azure, I'll use the SDK to finish my task there. Just a quick shout out to our GitHub repo. We are open source. We have over 3.8K stars, approaching 4,000. Over 2,000 projects use it currently in GitHub, and we have over 180 libraries for a bunch of services across Azure. So just a quick demo of kind of the terms that we use. So we have two different types of libraries within our Azure SDK. The first one is a management library, or management plane library. So these are used to create, configure, and otherwise manage resources. So if you want to spin up a storage account or something like that, you'll use a management library. And if you're installing our packages, they're generally prefixed with MGMT in the package name to denote that this is a management library, versus the client libraries, which is our next one, or a data plane library. They're called we kind of use those terms interchanged. And essentially, those are used to interact with already provisioned Azure services. So if I've already spun up a storage account, then I'll be using the data plane libraries to be able to talk to that service and maybe upload a file and so on. So now that we know what the SDK is, we'll jump into the benefits of using the Azure SDK for Python. And the title of the talk was Fast, Simple, and Idiomatic. So we'll jump into those. So we're starting off with fast. So in general, the SDK will greatly reduce the amount of time to write Azure-specific code. It will reduce time needed to onboard the capabilities of a service due to the fact that there's a library that kind of describes what you can do. It'll reduce the need to write and maintain best practices for cloud-facing code. So if you had your own code that called the REST APIs, as opposed to using our SDK, it'd be a lot more complicated, and you would have to maintain that yourself, as opposed to using the SDKs, which do that for you. In addition, the operations within the SDK are optimized for performance, so you don't have to worry about all of that. And also, we have a very robust exception system that provides more details and helps debug code quicker. Moving on to simple. So we have built-in open telemetry support for tracing applications. You don't need to do any additional work to get that. That comes out of the box. We have a consistent design for cross-service and cross-language, regardless of the REST API underneath. Azure is a huge cloud offering. There's so many different services, and all these services do things a little bit differently. The Azure SDK team does their best to kind of unite this under one familiar and consistent system for people to use in their libraries. So you don't have to worry about all of the complexities that comes with that. We give you a convenient library to be able to complete all of your tasks and focus on the code that you really want to. Additionally, the libraries will keep up to date with new service functionality. So if a service adds a new feature, then the SDK team's job is to add that feature into the library so users can use it in a convenient way. We also have consistent retries, exceptions, and HTTP client management all through Azure Core. And this is one of the biggest value propositions of the SDK, where everything is consistent, again, because there are so many different services in Azure, it can get really confusing. So having one library that kind of unites all of these things is very great for developers to focus on business-facing code as opposed to figuring out things with Azure. Additionally, we have authentication libraries with Azure Identity, and this makes it so that you can focus less on auth, less on all the hassle there, and more on, again, the business-facing code. So the last point that I had was idiomatic. So we are very Python-focused. We were built by Python developers for Python developers. We have data models in this library as opposed to other cloud libraries you might have used, which allows for IntelliSense in your IDE, makes the development process a lot easier, and I'll show that in our demo here. We also have an active effort to reach full typing annotations across our SDK. So we have type hints for all of the data types that we have. Makes it easier, again, for you to understand what you're working with and where. We also have async operation support in the SDK. We try to follow the best trends for Python idiomatic libraries. And lastly, the reference documentation within Microsoft Learn is getting a Pythonic makeover. So it's going to look a lot more friendly and used to what Python developers will expect in the coming months, which I'm really excited about. That's one of the projects that I'm leading. The moving next is some fun facts. The Azure CLI uses Python SDK libraries underneath. So if you've ever used an Azure CLI, you've technically used the Python SDK as well. We actually wrote our own AMQP messaging protocol for Python in our messaging libraries. This is in-house, and it's one of our proudest achievements on the team. Additionally, we support PyScript and Pyodide, which is Python in the browser, in beta. And our RefDoc revamp that I talked about earlier is actually one of the largest Python documentation projects currently out right now. It is massive, as you can imagine, with all the libraries across Azure. We're figuring out how to organize and structure our documentation in a more idiomatic way for Python developers. And lastly, members of the Azure SDK team have attended PyCon US since 2014. I was there this past year. And yeah, we've been around for 8+ years. So we're definitely very in tune with the community and would like to continue to be so. Okay, so now that we understand kind of why and what the SDK is, let's jump into some basic steps for using the SDK. So for using a management plane library, you want to ensure you have the permissions in Azure to create and manage resources. You authenticate with our Azure Identity Library, create your client object, and then do something. And this will look really similar for data plane. So first, you want to ensure you have the permission to operate instead of create or manage. You want to operate on an already created Azure resource. You authenticate with Azure Identity, create your client objects, and then do something. So here's what that would look like. So first, you want to ensure you have access via RBAC. RBAC is role-based access control. So it essentially allows organizations to manage different capabilities you have on different things and resources within the cloud. So you could add a role assignment here, or if you're more comfortable with the CLI, you can also create for RBAC here. So you want to ensure that you have the permission to do what you want to do with the resources in Azure. Next, you will authenticate with Azure Identity. This class that I'm showing here is the default Azure credential. It's a kind of the crown jewel of the Azure Identity Library, where essentially it will try various different credentials. As you can see, it starts with, might be a little bit hard to see, but environment credential, then workload identity credential, Azure Managed Identity credential, and then so on. So it even goes into the Azure CLI, PowerShell, developer CLI, which you just saw before, and it tests all of those credentials until one works. You can also use a specific class of credential if you'd like, and that's what I'll do in the demo. But in general, you want to authenticate with the Azure Identity Library as like so. Next, depending on what service you're working with, you'll want to create a client for it. And some services have several clients. For example, here is blob storage, and there are 3 different clients that you can use to interact with it. And generally, that will show you the different scopes of operation that you can have. So for here, with blob service, with the blob storage service, we have the blob service client, which will allow you to manage the resources and containers. You'll have a container client, which allows you to manipulate a container and the blobs inside of them. And then lastly, a blob client, which will allow you to manipulate a blob. And a blob is just a file that gets uploaded into Azure storage. So now that you have the permissions, you have your identity verified, and you have the client to do something with, the next step naturally is to do something. So for example, we have this example code here from one of our quick starts. You can see in this squared off section, we have our container, or we have our container client. So then we can do something like list blobs. And now we have a Python iterable object that we can go through. And now it's just easy to interact with the library. This goes from very complex REST API call with all of the correct headers and auth to a one-line Python line that one line of Python code that just allows you to focus again more on the code that you should be writing as opposed to boilerplate and making sure you manage all of that. So I think we can jump into a demo. I may need some help putting this up. But yeah, I have 3 different files within VS Code here. And essentially, they'll go through, there'll be data plane SDKs working with different services. So first, I have the storage blobs. Next, I have Cosmos. And next, I have event hubs. And I'll explain what these services do as we go. But essentially, we started with storage. So storage is just where we upload our files to the cloud. And I just wrote a few lines of Python code to kind of describe how to interact with the service. So we start by importing the OS library. This is for accessing our environment variables, as you can see on line 7. We have our storage account URL in environment variables. We'll use that for creating our client later on. We import the Azure Identity Library, and we use the Azure CLI credential. So in here, in our terminal, I can type in AZ login, and then this will open up a new window in my browser. I sign in with Active Directory, Entra, and then I'm good to go, and that's my credential. And then from the Azure Storage Blob library, we'll import the Blob Service Client. And technically, I've imported the Blob client and Container client, but we get those implicitly. We can also add type hinting, which I'll do in a second. So we have our credential here with the Azure CLI credential that'll run, and I've already logged in, so nothing to worry about there. And again, we have our storage account URL. That gives us enough of what we need to create the Blob Service Client. So that's the first one. And the Blob Service Client configures the account properties. You can create, list, and delete containers and retrieve specific clients as well. So we've created our Blob Service Client here in line 11. And then we can go one level deeper and go into our specific container. And I want to create a container called Azure Python Day. So I've created that as my container name. And then I can use the service client, Blob Service Client that we've created, run the create container method. And again, part of the benefit of our SDK, we have very great IntelliSense support. If I want to learn more, I can scroll down. We have all of our doc strings here. And then we pass in the name, which is our container name. And again, we have type hinting. So we can have something like this. So now we know exactly what the type is of the value that's getting retrieved. And also, VS Code isn't complaining that I'm not using it anymore. So super cool. And now that we have our container and we've created that container, then we'll want to upload a file. So I have a file here. I have, let's see, Azure Python Day.txt. It's a haiku. Azure sky is so blue. Python scales its vast expanse. Cloud and code entwined. And I asked ChatGPT to write this because Python is easier to write than poems. So that's my file that I want to upload to Azure Storage. So then what we'll do is we'll create a blob client, and we'll use the service client to get a blob client. We'll pass in the container name, and then we'll pass in the file name that we have here. Then we'll be printing, uploading to Azure Storage as blob, and then we'll be uploading it with this section here. And then we'll also just download that just to see the multiple operations we can run with the container client and the blob client. So without any further ado, let's do Python storage-blob.py. Run some simple Python code. Our terminal should print in just a second. There we go. So you can see it says uploading to Azure Storage as blob down here. You uploaded this file, and then we've downloaded it here. So we have a downloaded version right here. So not pretty, but just a short little explanation of how you can use the SDK to speed up your operations. In terms of the actual logic with connecting to Azure Storage here, there's really not that much. We have our credentials, and honestly, I've split things out in multiple lines to make it a little bit more readable. If there was a little bit more business logic, you can see how the Azure SDK becomes a tiny part of what could be very complicated, and then you can focus on the code that you want to be working on. So if I wanted to, edit this haiku, if I wasn't a fan of ChatGPT's work, I can do that. I can re-upload it. I can upload it with a different name, and so on. So this is great for file management and so on. So that was our first demo, and like I said, the process was very similar. So I got all of my permissions from all of my permissions from the portal. I then used the Azure CLI credential to verify my identity to make sure that I'm the person I am that has those permissions. And then I just use the SDK to create the client and do something. We'll run into a Cosmos example next. And Cosmos is a database offering that we have in Azure. And it's very similar to the last time. We have our environment variables. We have the endpoint and we have the primary key for Cosmos. And this time, I won't be using the Azure Identity Library. I'll be just using a primary key to show that you can use multiple types of authentication. We have a database name called to-do list, and we have a container name named items. So then we have our client that we create, the Cosmos client, and that is the overall client for the service. So we pass that in. Again, we can have our type annotation here if we would like. This one is pretty obvious, but if we wanted to do on a method here to make it a little bit more clear what type we're returning, you can do that. Again, we have typing in our library, which is very convenient for more complex code bases. So we pass in the variables of our endpoint for our URL, our credential, our key, and then we have the consistency level for a session. And then we get our database client, and then we get our container client. So we have a database inside of this Cosmos resource, and then we get the container, which is where all of our values are that we can query on later. And if I run this code, let's see, Python Cosmos.py. It'll get all of the items in this container. So we can see all of the values here. And yeah, so that's that. So if I want to be a little bit more specific, then I can also do item and then text. And let's see what that says. Great, it says hello from the very first Azure Python day. So that makes it really easy. And there's a little bit of a spoiler below if you read the comments. You can see that we have, we can also query this database. So if I want to comment this out, then just like any other NoSQL database, I can use, or not only SQL database, I can use SQL here to select and run a query, and then pass in the value where I want to see that. I want to just retrieve something that says Azure Python Day. So if I run that, that's what it should be. I didn't print it out in a pretty way, but that is the iterator object that will have the item that we saw earlier. Moving on, we have our third and final demo. And again, following a very, very similar procedure to the other ones, it's Event Hubs. And Event Hubs is a streaming platform and ingestion service. So you can send a lot of messages, receive a lot of messages, and store them. So yeah, let's just jump into it. So again, from our Event Hub library, we'll import the event data class for what we'll be sending up to Event Hubs. From the async libraries, we'll be importing the producer client and the consumer client. Again, a great part of our library is you can just hover over something and you know exactly what it does. It has a perfect doc string here. So the producer client defines a high-level client for sending events. And then if we do our consumer client, it'll be the same for receiving events. So now that we know what that does, we go back with our credential here, and we have our same variables that we need to start up the client with our name and our namespace variable. So I have two methods here. I have one called send messages, one called, I guess three, one called onEvent, and then one called receive messages. So in the send messages, I'll be using the producer client to send messages, as we saw earlier. So I'll create that client object with the namespace, the Event Hub name, and then the token credential that I got from the Azure CLI credential up here. And then in an async with, I will then send a few messages. So I'll create a batch of events, and then I will add all of these events. So it'll say hello, the first message, then from Azure Python Day, and then I'll send that. And that's what my first method will do. So let's actually run that really quick. Python event. Great. So I've sent the messages. I didn't have a confirmation that I, or print or anything that confirms that I finished it. But if I comment, if I uncomment this line and comment the send messages, then we'll run a receiver, and that will receive the messages. And generally, we have an onEvent handler, which will essentially tell us what to do whenever we get a message from Event Hubs. So it'll just print out the events body as string using that method. And then we'll use the partition context ID as kind of the specific partition where these events are stored. And by default, this is 0 because we don't have any special partitions with this code sample. So to receive messages, again, very similar process. We have all of our RBAC first. We have all of our identity set. We create the client using the credential that we have, and then we can now do stuff with it. So we've created our credential in a very similar way. We use the consumer group default here because that's what Event Hub's default is. That's just an extra variable we pass in, and then everything else is the same. So again, async with, and then we receive all of our messages, and we use the starting position -1 to have the beginning of the partition. And again, the partition is just 0 because we don't have any special one. So if we run that now, where we run our receive messages function on line 60, we should be able to receive our messages. 1 second. There we go. So you can see here that our messages have been received. We received all of our events in order. Hello from Azure Python Day. Perfect. And essentially, that is it. That is a demo of all, the Azure SDK's libraries across 3 different services. As you can tell, it follows the same kind of procedure that I outlined, where we want to get permission, we want to confirm our identity, want to create a client, and then we want to do something. So These libraries exist all across all of our services. These libraries that I showed specifically are data plane services, meaning that we can interact with services. But if you just want to spin up something and maybe automate the creation and management of your Azure resources, you can use our management plane libraries for that as well. And again, very similar procedure where you get your permission, you get your identity confirmed, you get your client, and then you can do whatever you need to do, either manage or interact with services, depending on management plane or data plane libraries. If we go back to the slides, I have one last thing, I believe. One moment. Cool. Yeah, my one last thing is a Q&A. So if there's any questions, open to that. And if not, thank you. And you can learn more about the Python SDK here. I have a QR code here for any Python SDK users. If you scan this, this will take you to a SurveyMonkey survey that you can use to kind of give us some more feedback. Being an SDK, it's very hard to be a product manager because it's hard to get feedback without explicitly asking for it. So this is me explicitly asking for it. And this is the link to our Python releases, the first one. The second one is our GitHub where you can create issues and chat with us. And then also we have a Twitter at Azure SDK. If you have anything you want to say, tag us there, we'll respond. And then lastly, if you have any questions, you can go on Stack Overflow and use the tags Azure and Python, and a member from our team will take a look. But yeah, thank you.
Awesome. I'm just going to give people a moment to go to that QR code. I definitely brought my device out. I'm going to my QR code so we can give you some feedback on that. That's really, really great. Thank you so much for that presentation. You had me at Pythonic makeover. That's exciting.
Yes.
Do you want to say a little bit about what you're doing with that? And
yeah, sure. So the Azure SDK team, specifically me working on Python, has been coordinating with our Microsoft Learn team to completely revamp how our docs for Python libraries are viewed on Microsoft Learn, formerly Microsoft Docs. And yeah, I'm super excited by that project because essentially it means that Python developers can view documentation and navigate in a way that feels really natural to them. We did a bunch of user research, a bunch of studies on how Python developers like to organize their libraries. So this will be applying to all of our Python SDKs on Azure, but also for libraries that aren't necessarily on Azure, like our upcoming semantic kernel, which is kind of Microsoft's version of LangChain and so on. So it's really exciting to be able to kind of update the way that Python developers at Microsoft work. So super excited for that.
I've been seeing you talk about it a little bit on the channels and stuff like that. I'm very, very excited to see the work that you're going to bring to us. Awesome, awesome, awesome. And we also had some poetry in there too, so we got a little bit artistic. Are you familiar with the Zen of Python?
I'm not, no.
It's just a poem about doing Python. It's kind of ingrained to some of the Python culture a little bit, but we'll talk about that another time. I honestly like the ChatGPT poem.
It was pretty great, yeah.
And we got to hang out at PyCon last year, and you did a plug for some of the stuff you were talking about at PyCon. So that's great. I hope everybody gets to that list. Oh, yeah. And Jay mentioned in the chat, import this, and you can get the Zen of Python from your terminal, any terminal.
Well, pip install first, but yeah.
Yes. Yeah. Oh, good. And your demo was great. So very thorough. I appreciate that.
Cool.
Let's check to see if we have any questions that we can answer today. See.
I see a question about Cosmos. For that particular question, I will get back to you. I will chat with the Cosmos service PM there.
Great. And that was just about the support for Cosmos. And we'll get back. Okay, great. And how about this one? I don't know if this fits in the parameters of what we're talking about today. But once you have service principals and our testing utilization of those identities, it's not a problem. But during development, there's an annoyance with roles expiring every day. We do have some conversations back and forth getting to this particular issue. But do you have any thoughts on that, Rohit?
Yeah, we have the Azure CLI command to be able to add your role. Okay. I think the specific role permissions depends on the organization that you're in, but I believe those should stick. I haven't personally seen an issue with that, but again, I don't work in a company that uses it with their own policies and whatnot. But I believe there is a way to automate that permission, that RBAC permission with the Azure CLI, and then also I think as a result, the management plane libraries that we have.
Awesome response. And this is such a specific issue. I'm so glad that we have our experts in the chat. Pamela's been doing a great work. Jay, we've been shouting you out a whole bunch. Thank you so much for like doing some of that legwork and reaching out to our individuals, our community, the whole reason why we do this. So next Python day that I'm really excited for, we're going to do some more of this as well. And you got a round of applause as well. Thank you so much for all the work you're all doing on the Python ecosystem. You in particular, Rohit. Like, I want to give you a round of applause. Great. I think that's it for our questions. Thank you so much for joining us.
All right. Take care, everyone. Have a great Python day.
And I'm going to go through a few more announcements. We do have, and I'm going to share my screen. We have a link to all of the streams that we've been mentioning, the first Wednesday, the second Thursday, the second Wednesday. You can see that here. I followed the link. This is what you get to. You can subscribe. I'm subscribed. And you can see all the lists. And this is us at the top, Python Day. So thank you so much for being here. And a few more, right? Also wanted to list that we have collections, a collection of all of the links that we're going through today. This is me traveling through the collections. Oops, let me change my screen. There you go. Oh, missed that again. That's okay. Sorry, y'all. There we go. Here's the collections, and this is also where you can get to the Cloud Skills Challenge, and we have the Cloud Skills Challenge working, so please check that out. We have one for AI and machine learning. We have a beginner's Cloud Skills Challenge. We have one for web development. So tons of stuff, ton of learning today. Thanks so much for joining. Awesome. And I'm going to close this out, and we're going to introduce our next person. The interwebs was ablaze with the recent announcement. Many people know this about me in particular, but I used to be a marketing analyst before I was a Pythonista. So I was in the weeds of Excel for, all of the intents and purposes, sometimes pulling my hair out, but really just came to love Excel also between my half dozen business classes in Excel. So the internet was really, really excited about Python and Excel and its marriage and the announcement recently. And we have Sarah Kaiser, one of my favorite Pythonistas I get to work with, jumping into Python and Excel in our data science. Let's bring her on screen.
Hey, everybody.
How's
it going, Don?
Today?
I am super excited.
Good.
It's Python on Azure Day, not just any Python day. So
it is.
We've got a cool data science double feature that I am super excited to get started with.
Yeah, and I've had you talk about data science on the Python Pulse the second Friday of every month. And that's actually tomorrow. I have Sujin. We have a great episode with you, me and Sujin a few months ago. So I'll get out of the way. I'll let you talk all the good stuff. Bye.
Sweet. I am on limited screen real estate, so hopefully let me know in chat if you can see the slides here. I'm doing a screen share for folks. Okay, cool. Yeah, so thanks so much for joining me on Python Day here. And the first kind of topic that I wanted to share with you, what's new, what's exciting for Pythonistas with the Microsoft Cloud, is Python and Excel. So yeah, let's jump into it. I should also say I'm a senior cloud developer, as the name thing says. I'm a senior cloud developer advocate for Python here at Microsoft. And I've been working with data for over 15 years now. But something I do know about myself, and I think a lot of the other humans I work with, are we like grids. I am a big to-do, like column Eisenhower matrix person for my tasks. I play a lot of games that work in grids. I see a lot of cool people making art in grids. too many monitors. So, it seems to be a really natural way for us to understand and process kind of data and information. And we actually also empirically know that data science also loves grids. I highlighted a couple research papers here doing studies about how spreadsheets in particular are kind of critical to how folks collect both like empirical data and qualitative data. And so there's a lot of interesting pedagogy around how do we teach and use these tools, especially because they're also just a really common intermediary. So like I'm a Pythonista. I obviously work with a lot of Python stuff, and very often when I'm working with other tools and things, I will be exporting and importing from spreadsheets to basically interoperate with a lot of other tools. So like it's kind of a critical piece to how we work with data. So my question for folks in chat is, what is your favorite kind of grid or table? It can be for work, it can be for fun, maybe you play Factorio, I don't know. Drop it in chat and we'll highlight some fun ones. But so we know grids are good. We also love Python. So speaking from here at Microsoft, we do a lot of stuff with the Python community. We host the CPython core, a lot of the CPython core team, including Guido Van Rossum, who are working on making the core CPython runtime faster. We work with and help develop the Python language features and VS Code and extensions for all kinds of Python related things there. Developing Python learning paths and tutorials, really cool like embedded runtimes so folks can learn with Python and learn to program. We have a great dev blog that kind of highlights a lot of these things that we're working on. And that also includes events like this one. So I work with a really amazing team of developer advocates, many of whom are in chat right now. You can say hi. But yeah, we love to run events like this where we can kind of share what's new and exciting and what we are at Microsoft doing with Python. And I will definitely also plug the Python Pulse that Don was just talking about a minute ago, because it's a great show and so many cool people around there. So Microsoft likes Python. Data science also likes Python. So I found Brian Spencer says data frame is their favorite grid. Solid choice. But yeah, obviously data science also likes Python. Just pulling from Anaconda did a state of data science survey. Like Python is kind of almost far and away one of the most commonly used languages here for being a data scientist working with data. So like that's pretty much a no-brainer. Hopefully if you're here, you might love Python or maybe at least tolerate it as well. So the kind of main motivation here is, what if we could have both of these tools kind of in the same place? .grid paper is also a great choice, Jay, for grids. But yeah, so that's basically where Python in Excel, the Python in Excel integration comes in. So this was announced last week, I think, in public preview. And yeah, it's pretty much what it looks like on the tin. You can take in Excel, you could normally write functions in different cells in your grid. Now you can write Python functions and run them against a full Python kernel in the background, running on the cloud, and you can just write Python right directly in your notebooks. So you might say, why do this? Maybe you like your Python the way it is. Maybe you like your Excel the way it is. But I also work very regularly with Jupyter Notebooks, which are kind of like a 1/n grid. But why try doing this combination? kind of some of the things after playing around with this for a while now that kind of stood out to me as really good reasons to try this are that you can basically mix. Normally, there's definitely all kinds of plotting and charting and tabling features in Excel. But now you can actually use things like matplotlib and Seaborn and make some like really fancy plots, with just a couple lines of code, as opposed to hours, if not impossible, sorts of work in configuring like the UI plot editors in Excel. And that kind of speaks to the second point here, is like you can kind of mix those features. So Python, you have as a part of the runtime here, packages like scikit-learn, all kinds of machine learning tools and stuff like that. So you can actually now just do machine learning with Python directly in Excel. You don't have to do the like load, work with stuff in memory, export sorts of things. You can just do it right there, which I think saves at least some errors in the translation. I'm looking at you, Excel, with dates. Anyway, you can combine the best of each tool to kind of make your work easier. Honestly, to me, though, one of the kind of killer features is the collaboration aspect. So probably a lot of folks here have had the fun of saying, oh, hey, I just wrote this script sort of thing. Here you can run it. You've got your own data, but you probably are going to need to specify how to run that. So you're going to need an environment, requirements.txt. Maybe you need outside of Python tools like Rust, if you're using polars, like Matthew's mentioning for favorite grids in chat. So it like can very quickly get hard to share even just something fairly simple with somebody in terms of like Python scripting or packaging and stuff, which sometimes you're just like, I don't feel like doing that. So here you can take that, whatever it is, small to medium Python code bytes and actually, or a full-on project, and just share it, the same way you would share a document link. And lastly, but not leastly, there's Microsoft is known for all of its enterprise level security things. The code, where the Python code actually runs, is in a secure container on the Microsoft Cloud, which is running an Anaconda distribution. So that's why it's going to come out of the box with a bunch of kind of the standard data science-y packages like pandas, matplotlib, scipy, scikit-learn, all kinds of stuff like that. So it's an environment that you've probably worked in before. So that's enough talking and enough slides. Let me just actually show you Python in Excel, Jupyter Notebooks in Excel. I mean, it is, I think, a fairly reasonable mental model. The main thing that obviously breaks in terms of comparing a Jupyter Notebook and Excel in the execution model is obviously this is 2D. You now have cells that can go left and right and down. So as a node, when it executes, it will actually go left to right and then down. That one got me. Wasn't exactly what I expected, but it's quite straightforward. So the spreadsheet I got here, please let me know if it's not big enough. I can try zooming it a bit here. So let me know. But I do a lot of tabletop gaming. I like playing Dungeons and Dragons and all kinds of other storytelling and collaborative games. And a lot of folks recently have been wanting to play Dungeons and Dragons 5th edition. So I was like, I'm not very good at taking notes on paper. I'm not very good at just like, I lose my scratch code in different places and stuff. So I decided, hey, what if I can try using Python to kind of do the calculations and manage the data state for our game. But in like a UI, I don't have to like write a UI in Python to make it work. So yeah, basically what what does it mean to actually write a Python function here in Excel? I can select a cell, just like I type any other function. I can do, sorry, I will narrate here. I can hit equals, which is starting a function. I can type capital P, capital Y. You can see it has the, oh wait, no, it doesn't. Oh, no, it's just slow on my preview. It shows you that it's going to create a Python formula. So I'll open the parentheses, and that kind of automatically promotes this cell. You can see the green sidebar here, and it says PY. And then I can basically run whatever. I can start typing my Python code. So we were talking about earlier, import this, which is a thing I do often to test when I'm running Python things. And you can see something happened here. So normally, if you're running this in your terminal or in like in a notebook, you would get this in the output cell. By default, the output of Python cells are set to Python objects, but there is two different ways you can kind of output from cells. So this makes sense that a Python object is just whatever that cell would normally return, which normally it would return this text here, which is the Zen of Python. So it's a great way. You don't have to install new packages. You can always test, and it displays a really neat poem that a lot of times I have to return to. Simple, explicit is better than implicit is usually the line I come back to. But yeah, but otherwise in the cell here, this doesn't really help. None type isn't, maybe what we're looking for. So if I maybe click over here, I'm going to stop editing that cell. I'm going to make this also a Python cell. And I can say, hey, please grab me the output from the cell. So in a very similar way that like you would normally work in Excel, you can refer to different cells in your sheet. That's kind of how you do formulas. When you're doing this in Python, there is an always loaded module called Excel. And that's basically your interface from Python to kind of the rest of the Excel, what Excel exposes to you in terms of data and features and things like that. So if I do this and I hit Shift Enter, it should just give me a copy of that. But if I, in this cell, say, hey, I would like you to output this as an Excel value, it should see that it's text, and it's still, why is it still calculating? Okay, I am not sure. I probably need to explicitly, how that returns as a module is maybe not the best example. But what I could do is I have a bunch of other, if you want to see like kind of what's running in, I made a little cell here that looks at, imports some packages. So just like I start my notebook or my script, I import a bunch of things. And then the main way to get cells to display things is basically to return a string. Printing, if you print something, it'll show up here in the diagnostic window. So here in this A6 here, what I'm going to do is basically grab information about that container that I'm running in, versions of packages and stuff like that. And I've got a block string here. Sorry, I'm not really sure how to make this part of the UI bigger. Hopefully you can see. But if I run that, then basically I can have a nice formatted string output here. So maybe an easier to see example is here. So like for this worksheet and stuff that I'm working on, I didn't want to keep typing the stat labels. So I just made a variable that's a list of those strings. And I could just do the format string syntax here and just say stat names and everything that you would expect out of standard kind of formatted strings in Python. And again, notably, you don't have to put print there. when you have errors in cells, they will also come up. You will get the little kind of normal error icon, as well as messages and stuff will come up in this diagnostic panel. So it's actually pretty easy to track down what cells. It even also says, like here at the top of the diagnostic window, this is from the start sheet and C3. So yeah, I know I need to move along here. So I have a couple other things defined here. Basically, I wanted to be able to roll some dice in this sheet, mainly just so people could potentially see or I could prove that if we're playing remotely. I can generate random character stats and basically random parties of characters. And the other thing so because of where this Python, the containers that this Python code runs in, they are locked off from the internet for security reasons. So you can't, at the moment, install other packages or access like download things or anything like that. So that's where using some of the kind of Excel tooling can make that a lot easier. I had not known about this feature before I started playing around with the Python in Excel, but there's something called Power Query in Excel. But you can see the tab comes up here because I'm in this sheet. But basically, I found somewhere on GitHub, somebody had a spreadsheet in their repo that was the 5th Ed bestiary, like monster manual. So I wanted to be able to randomly generate encounters for players. And so I didn't want to type in, and I didn't want to necessarily copy in, maybe I want to stay up to date to some other resource. Maybe I get some other like mods added in here. But yeah, so I can set up a Power Query. I give it the URL for the file, and then I get this nice query editor where it kind of shows me a preview of like what it sees at that end resource, which can be local, it can be connecting to a SQL database, it can be connecting, since they're SQL APIs, it could be connecting to Fabric, which is Microsoft Fabric, which is what I'll be talking about next. All kinds of things. And you can do some preliminary cleaning here. So there's definitely, like I'm very much a fan of and familiar with doing data cleaning in pandas, but maybe there's just some really quick things. Like I guess I should probably break up this attack parameters column. That might be okay to do in Python. I don't know, I haven't tried yet, but anyway, so you kind of get this query editor, and then that stays up to date. So that kind of always makes sure that this is a source of truth. And I can refer to this table elsewhere in my sheets. So I want to show some other examples. So let's talk real quick about execution. I will also look at chat here very briefly. I just want to make sure I get through the core things I want to show you. So in terms of when it runs cells, we talked about it goes left to right and then top to bottom. But you have, and when you run a cell, it will rerun every cell in a notebook. So that's kind of like if you were working in Jupyter Notebooks, it's rerun the whole, clear output and rerun the whole notebook. That may not be what you want, especially if you have some kind of like expensive calculations. I have some here that are a little bit longer, which is slowing things down a bit, but you can, in the formulas tab here, that's actually where you're going to, when you enable to use this, you're going to have to be on the Microsoft 365 Insiders right now while it's in preview, but there'll be a little Python part here to the formulas bar where you can put in samples and pull up like that diagnostics panel and even view what initialization happens. So like this is right now read only, but it shows you what's actually run when it starts up that container. But you can also see here, there's calculation options for the worksheet. So this was something that like really kind of changed my experience here, because like obviously if I'm running a game here, there's probably some cells I don't want to keep rerunning. Otherwise, you know, my party stats every time I roll a die is gonna update. There's some ways to get around that, but also I can just change the execution mode here to be partial or manual, just every cell at a time. But in general, Excel is looking to kind of make sure its entire state is up to date. So that's kind of why the default is, I don't know what happened when you were editing. I'm just gonna rerun everything and make sure what you see is the most up to date. But anyway, let's see. Enough about that. So I wanted to show you a little bit using some of the other cool Python packages that are in the Anaconda distribution here. Let me zoom us in here a little bit. I wanted to take a look a little bit at, I've got this bestiary or monster manual loaded here, and there's a lot of data. It has like all of the, if I look here, I've got the monster alignment, types, sizes, like all kinds of stats about it. And I was wondering if I could do some like categorization, use scikit-learn to kind of correlate and predict, you know, if I try to create a monster of my own, you know, help me predict stats for what I might want to create for an encounter, to make sure it's kind of consistent with the general design. So let's look at just a subset of those stats: the monster level, health points, armor class, and how much XP or experience points you get when you kill it or defeat it. So I can do something like this. I'm going to import scikit-learn, and in this case, just do a test train split. I'm getting ready to do some machine learning stuff. I'm not sure I'll have time to go through all of it, but basically I can just refer to this again with that XL module, just say, hey, give me the whole bestiary sheet, and I'll interact with that as if it's a data frame, because that XL module actually just returns a data frame. So I go through, I do a bunch of stuff there, and I can use Seaborn here. It's hard to show you the formula, but let me just make the bigify the picture. But here you can see, just like with basically 4 lines roughly of Seaborn, I can take that data set and look at those 4 parameters. And in this case, I was trying to figure out, like, are larger monsters always harder? Yeah, so like here, you know, I can start exploring that data, trying to figure out, you know, are there some correlations? Are lawful good creatures always easier? Like, I'm super excited to dig in more with this. But the last thing, kind of along the collaboration route, is there's some really neat ways you can share just selections of cells. And so I was playing around with, like, if I want to be able to show folks like what the current initiative table or some state of the game, but without showing them all my notes, this might be a really cool way to do it. So, because I know I'm short on time, I'm going to come back real quick here. And let's just really quickly review a lot of the cool stuff. There's so many neat things to show you. There's a lot of great blogs and content and stuff already online for you to explore. But basically, the main highlights are we can use all kinds of advanced Python package stuff for plotting, for machine learning, for statistical analysis, just right in Excel. And we don't have to go back and forth to spreadsheets, things like that. It's just pretty straightforward. You can also show some, you can use the best of both worlds for each tool. Again, date formatting might be a good application for that. Use Python packages to parse dates more accurately. But yeah, so you can use like conditional formatting in Excel for output on your pandas tables, things, so you don't have to write all that styling in Python. And it's really nice for collaboration. So seeing everybody's cursors, sharing a link, it's, kind of that experience I would expect out of a lot of my other tools at this point. And we talked about a lot of the security things. There's no network access. And the Python, when you show the Excel output formatted, it only understands strings, numbers, Booleans, and images. So that keeps it pretty simple, and that's why often it will also just say, hey, it's a Python object, if you try to give it something more than that. And yeah, it's been really exciting to kind of work with the team that's been building this, try out a lot of the cool stuff. Guido even consulted on this, so the Python part is solid. And yeah, so what can you do now? You can give it a go if you have, again, right now at least, a Windows machine and an M365 Insiders subscription. You can sign up for the Insiders part just from the settings on your Microsoft 365 subscription. So you can try out the Getting Started template there, or you can join, if you don't have access for some reason, you can join the wait list. And right now, while it's in public preview, it's free, and there'll be more updates as we approach GA about what sort of licensing will be available in the future. But yeah, if you have feedback, ideas, we've got a great GitHub repo, Microsoft/Python and Excel. Drop questions if you're actually trying it out. And yeah, thank you so much. I'm going to look at the questions here real quick and see if there's any. Also, if there's any we should highlight that I didn't get answered.
Yeah, we had great engagement from the chat. Hey, Sarah, how you doing? I just had to pop on. I loved this session. I love learning about Python and Excel, but also just hearing about D&D. My partner's in 2 campaigns, so I don't know much about it, but I hear a lot about it. And so this is a really, really great refresher to learn more about real world imaginary scenarios.
That's true. That's true.
So we do have a bunch of great questions. I do know, however, just based on the time, you are the next session. You are a wonderful double feature. So I will leave it to you if you want to answer maybe like one question before you roll into the next one, whichever one you think is most helpful right now. Or we can take these offline and answer in the chat later on.
Let's take a couple questions. I just haven't been following. If you have ones you want to highlight.
Yeah, so in the comments section, we have a bunch of the questions under the starred tab. Those are some of the good questions. We can start with, let's see.
Harry asks, can Python code query sources outside of the Excel workbook where it's running? As far as I understand, yes. The Power Query feature, like it can, as long as you have network access or a connection string to the database, whatever you need to get to it, that kind of syncing and querying is handled by that component, and then it effectively, there's either a symlink, or it copies the data in locally, so you can work with it there, and the rest of the sheet, it's as if it was there. You can obviously also work with local data. So you can just open up your favorite spreadsheet where you've been tracking stuff and just use it right from there.
Mm-hmm.
And there is a lot of also like tons of database connections and stuff. I didn't have a whole list of all of the things there. Let's see.
I'll also say that Peter says, fascinating initiative, great presentation. So thumbs up all around.
Yeah, I want everybody in chat to roll for initiative, and we'll see. That's how I should handle the questions. Dang it. Yeah, I definitely, I can't.
We can answer these in the chat later on too.
I will answer these in chat, and also I'm on the Python Discord as well. So just Jacob says, please make some sort of Excel version of Jupyter Notebook. I will just say, and watch the blog. This is a preview, so there is lots of stuff folks are working on.
Yeah. link to the Discord is below there.
Yes, aka.ms/python-discord. I am there all the time. Crazy for Pi 314.
Sweet.
So let me pull up our next presentation here. I don't have as exciting of a demo for this one, unfortunately. So
so while you're pulling it up, I'll just mention. So yeah, this is our first half of the day. After this next session, we'll get an hour break. So go get coffee, go get your lunch, go get a snack, recharge for the afternoon. So we want to see everyone back here with full energy here.
Yeah, definitely get a coffee for me.
Oh yeah.
So yeah, all right, cool. So part 2 of our double feature is talking about using all of your data with Microsoft Fabric. So we kind of talked about a cool kind of hybrid way of sharing and working with either like remotely connected data, but probably less working with like huge data sets or heterogeneous data sets. We kind of need maybe a different tool, especially if like it's really big data sets. Excel, unfortunately, does not scale to like, enterprise grade data as easily. So there is a lot of data out there, like a lot. I've been having a lot of fun playing around with data.gov lately. But I'm sure a lot of folks here in chat work with different kinds of data, whether it's like logs from your debugger or smart home logging things or tracking your board game collection. I don't know. But what's the hardest or most annoying thing that you have to do with your data? Is it like cleaning stuff? Is it like just getting it to stay in sync somewhere? Drop it in chat and we'll see if any of the things we talk about might address some of that. But I'll give an example from my own kind of background here. So I did a PhD in quantum computing and I was an experimentalist. So I had a lot of data to work with. I was working with laser communications to satellites in the Canadian wilderness. So we had like radio comm streams from satellites, photon detectors, air purifier logs, power supplies, weather forecasts coming from other places, manufacturer specs, so many different sources for data. Some of it just even a printed PDF. And sometimes those files could be really large. Like obviously you don't want that to be the case, but sometimes the tools that you're using, they're just like, I'm going to keep writing to this log until the end of time. And if you move it, I'll be angry. So, we had huge over gigabyte sized data files. And because we're working remotely, some limited network connectivity. So it wasn't super easy to just like stream everything immediately. And we also, because we were working on academic collaborations, a lot of folks use different tool chains. Some folks use MATLAB, some folks use Python, some folks used R. Like we had different data formats, usually some variant of a spreadsheet to the earlier talk, but not necessarily. And so we had to work through proprietary, like reverse engineer APIs for things. Or even just move them around on USB drives, which gives me panic attacks thinking about, because what if your USB drive walks away? And certainly none of that was often documented. So that is really frustrating. As we said in the last talk, I like grids, I like organizing, I like having everything kind of indexed. And so this was not a workflow that I felt happy with for my data. And I was kind of getting to the end of my rope towards the end of that project. Oh, deduping. Oh, that's got to be the worst. Because like you don't want to lose data. Thank you, JD. That's, I think, the winner. So these are a lot of problems. I want to talk about a cool new product that was launched at Build this year, so just in the spring, as a preview to basically address a lot of these challenges that if you're working on big teams, collaborating on data, people use lots of different tools, it might help with. So the way I kind of think about it is Fabric weaves together a lot of different services for Pythonistas. The services tools, it gives you a single point of truth or single source of truth for curating your data, whether that's it actually owns the data source itself, or it can basically link out to other data sources, even on other clouds. But basically, you can go to one place and see all your data of yours, your collaborators, everything kind of in one spot. There's all kinds of built-in analytics tools, AI tooling to build models really easily, like Azure ML, that already inherently understand all the data sources in Fabric. So you don't have to write connectors or everything to each individual tool you want to use. It just says, okay, where's your data lake? And Fabric takes it from there. As I kind of mentioned, we're Pythonistas, so we're probably interested in the Python related like interfaces and tools for Fabric. But there are lots and lots of other options. So if you're working with folks who are maybe less comfortable with code, who prefer low code or no code tools for exploring that data, for making workflows, there is all kinds of things for everyone. So you're all working on the same data, but in a way that you're most comfortable. And again, like Microsoft is well known for, all kinds of built-in security, governance, and compliance. So, especially if you're working with sensitive data or things, you can kind of, by having all your data in one place, rely on that as your kind of security story. But because security stuff is not something I'm a particular expert in, so I'm going to focus on kind of the first three aspects of Fabric right now, for getting and curating your data and using tools and sharing from Fabric to other collaborators. So from a definitional sense, so I started with kind of why I find it interesting. The actual literal producty things that you'll see that make up Fabric is basically there are these 6 kind of components and then a one lake. So that's basically like a data lake, and that's going to be your one source of truth data. And that's all. Fabric is kind of that which wraps together all of these pieces. So a lot of these components kind of were products or services before, and they've all kind of been integrated now in a way that you can just seamlessly connect and say, I would like to work with these pipelines over here. The one we'll kind of focus on today, as surprises no one, is the data science piece here. So that'd be Synapse Data Science. So let's jump straight into, I wanted to show an example of what it actually would look like to do this. So the first step to working with data is to get your data. And so we need to add it to that one lake. Just to give you a sense of what that actually, when you do, this is kind of what that, the one lake data hub looks like. So you upload, basically you connect all your data, upload things. It's JDS about querying Service Fabric Parquet files. I know that OneLake and a lot of the Fabric tools have a lot of have support for lots of different special data types, like Parquet files or other geodata, or I'm trying to think, specialized data formats such that that might work out pretty well. I'll definitely get back to you. Find me on Discord for that specific one. But basically, you can kind of go to one place and see everything for your org or that anyone else is sharing with you. Yeah, I forgot to say, but it's kind of, think about it as like OneDrive, but for all your data. So one way that you can add things to your OneLake is there's actually a desktop OneDrive like sync client. So I can add my OneLake as a folder on my local machine. And honestly, for a lot of the research or kind of like experimental applications, this is probably the most easy way to add some of the stuff that we had in these experiments, because I could just have the device directly logged to that folder on my machine, and then it would just be synced up. But you can also copy data in from other resources, maybe copy a database or something like that. And you can also just manually upload files, which is honestly what I have been doing to start with, to just get some data in there to play around with. The next kind of step up for adding data into the OneLake here is pipelines. So they basically give you a way, there's all kinds of like transformations and data sources that you can that are built in, and you can just say, hey, even here, like you can see in the like sample data here, there's a bunch of Parquet files for public holidays. And there's both a visual graphical editor here. If folks, you want to work with people who want to edit your pipelines, and maybe like myself, you prefer like YAML files, like GitHub Actions descriptions of pipelines. You can also write Python scripts to interact with these pipelines and configure and automate them as well. As a expanded zoom in here of a bunch of those different connectors that you can see, there's built-in stuff for Amazon and Google Clouds. There's something as basic as an HTTP query and web scraping that way. REST protocol, REST APIs, obviously all kinds of existing Azure data store options, even just your Microsoft 365 account. And tons more. So like you can combine and integrate all of these however you want in those pipelines. But all of those usually end in like copying the data into your OneLake. But the thing that I found really neat about this is you can also have shortcuts. So kind of in the same way that like Power Query in the Excel sheet example, we were kind of pointing to an external resource and having Power Query keep it up to date and synced in our Excel spreadsheet. We can add shortcuts here in our OneLake, pointing to resources that maybe we don't own. Maybe it's something a collaborator that might be updating, and we don't want it to get out of sync. So the shortcuts here, I think, is going to be a really cool thing that I'm going to play more around with, because I do have a lot of folks that have data in different places. So you can see here, like the wizard walks you through all of the connection credentials and stuff. Again, I think you can do this all from the Python scripting side as well. But when you look at the OneLake UI, then you see the little folder icons with the little link. And so that indicates to you that it is a shortcut to data living somewhere else. So we've got our data in the OneLake. Let's actually use it and play around with it with Python, since that's why we're here. There's kind of 4 main ways that if you're a Pythonista, that you might interact with Fabric. So we already, I feel like most of my work is handled here for the first one, because we had the great talk on the Azure Python API earlier from Rohit, I think. So that is an option. There is web-based Jupyter notebooks with a bunch of different kernel backend options. So you can do Python, you can do R, Scala, Spark, with some great collaboration features. You can also work on your data in Fabric locally in your VS Code with the same notebooks and stuff with the VS Code Synapse extension. And if you are working with folks who are kind of leaning towards the low and no code options, maybe like a Power BI, you can put Python scripts in some of these tools, like Excel and Python that we also just saw. You could use Power Query to connect to some of your Fabric resources that way. Because when you create the OneLake, it creates a SQL connection interface that you can access anything in there. So that's kind of like the lowest hanging fruit. So just to show quick sample of that API, obviously the kind of get everything of the Azure API is pip install Azure. But in particular, a lot of the features here that we're looking at here for the data lake management is in Azure management data lake store. It's fairly straightforward, like anything else. You import the client, you set up credentials to connect to it. And the second code sample here shows a snippet of asynchronously syncing a local file system with files on your OneLake. So if you want to see more of that example in its entirety, you can go to aka.ms/python-fabric-api-sample. I promise I tried to make that shorter, but that was the shortest, most clear one I could think of. So yeah, that's one way. Way two is to use web-based notebooks. So very similar to a lot of other interface web-based notebooks like Colab or Azure ML or Code Spaces. Like, you have a Jupyter notebook here in your browser, you can go to anywhere. There's no setup. It spins up a Spark cluster in the background, and in this case, you can see in that top menu bar, I selected PySpark. So I have a Python-based notebook, and I can just work with pandas and yeah, Don, explicit is better than implicit. Thank you. Internalized. So yeah, I can just run cells. You know, you can see the results for that pandas table loading, and you can see on the left I have a little explorer for my lake houses. So that's a type of partition in a OneLake. But I can look, in this case, I was uploading some file, playing around with some files from data.gov that were tracking manatees in the Everglades. So not only can you use them, though, use these notebooks, you can work with other people. So you have, similar to the Colab experience or other just like collaborative Word doc editing, you can have other people join the notebook, and by sending them a share link, and you can have comments on individual cells. And it just makes it really easy to not have to like manage versions through Git and stuff like that. Eric, I will definitely type that URL in, or maybe somebody else can help me out with that. But yeah, so, but maybe the browser, maybe you're like me and you have 800 million tabs open, and your browsers want to crash at any random time, and you want to work locally with this stuff. So you can see here, there's a button in the top menu bar that says Open in VS Code. You can click that, and it will, if you have the Synapse extension installed in your VS Code, it will connect to that workspace, which would be like your OneLake for your data, your computational resources like Spark clusters and notebooks that you have in that workspace. So you can see here, I've opened that same demo workspace here. You can see my manatee tracking, and I just opened the same notebook here, and the extension, when it installs, it actually creates a conda environment for you that you can use. You don't strictly have to, but it is convenient. So I picked that as my kernel, and then that kind of already handles automatically some of the authentication sorts of things. So I can just run the same code locally as well as on the cloud. Yeah, I think, and as I mentioned, there's all kinds of other tools like Power BI and Python and Excel that you can access all this data from Fabric in those tools, and possibly use Python scripting in there. But Doug says Databricks too. Yep, Databricks is definitely in there. And yeah, I'm going to wrap up real quick, and then I see there's a bunch of questions, so I'll get to those in a second. So yeah, long story short, Microsoft Fabric is kind of a one-stop shop for all of your data, all your tools to work with that data, and it has some great Python support, like right out of the box, ready to go. Got your notebooks, your APIs, and then that means also if you're writing Python code, you don't have to write code to connect to your Cosmos cluster, to connect to your SQL server, to connect to a blob storage somewhere. You can just write to the Fabric API and it'll handle everything else internally. So I'm looking forward to fixing up some of my projects that way. So we have the single data source curation, built-in analytics and packages for, I didn't touch much on the machine learning stuff, but that's the Azure ML tooling. Snowflake is also definitely in there, Mark. It's easy to share and collaborate with folks and is secure. So if you want to try out some of the stuff, it is in preview right now. So there is a lot of kind of features that are just free to use and try out. You can go to aka.ms/learnfabric. That'll take you to the docs to kind of, as you saw with some of those diagrams, there are a lot of moving pieces to Fabric, depending on kind of what your specialized work area is or domain. So that can be kind of overwhelming, but I would suggest start with focusing on the data science component of it. And then if you're familiar with a lot of the other tooling that folks are talking about in chat, you can kind of see how those interact and how there are some good docs pages of kind of comparisons to working with that tool and then working with that tool in Fabric. And because there is already a lot of ecosystem and community around the Synapse tooling and the Power BI tooling and things like that, there is some great community options at aka.ms/fabric community. I was blown away and I was reading through a lot of the forums and blog posts as I was preparing for this talk. But if you have questions and stuff, there's lots of great folks and user groups that you can get engaged with to start kind of weaving Python into your Fabric. So hopefully I think I've saved enough time here for a few questions. But yeah, if you want to just the general basic, learn more about Fabric, just aka.ms/fabric.
You're right on time, a consummate professional, as always, as I know you to be. We have a couple of questions. I did want to just start with, can you please share that URL again? Do you want to just go scroll back a couple of slides so we can just get it on the screen?
We're gonna,
perfect.
And oh yeah, I can't, I don't have good access to the chat, how I've set up my computers here, so.
Cool,
Thank
and we'll leave
you.
that on screen for a second while we all scribble that down, because it was an amazing presentation. We also got a couple of claps in the chat. Amazing talk about Fabric. I would agree. I think it was very informative as well. It was really great. We also have a question. Does Fabric have a Discord?
Not that I know of. Okay. There is a general Azure Discord, which I know has some channels for like the Synapse.
I'll leave you on the screen. And I'm going to bring it up on my screen. So
okay, cool. Yeah. Thank you.
Okay.
So in addition to our Python and Microsoft Discord, there is a more general anything Azure Discord that will definitely have some folks knowledgeable about Fabric and some of the stuff in it. But as I said, like the community blog for this is just kind of off the chain. Like there were so many cool examples that I saw. So definitely give that a look.
Awesome. And maybe we can do one more question or two more questions. I don't want to hold everyone up before their lunch as well. Do you see one that looks good?
Let's see.
We could start at the bottom because those are the most recent ones.
Got it. Doug asks if we already have a workflow of data factory pipelines that calls a series of Synapse jobs. Is that easy to integrate, or do we need to set it all up again? To the best of my understanding, and I'll definitely follow up with you in Discord if that's helpful, but basically Fabric, it's working with those existing services. So I think if you have them set up already, you basically just kind of add them under that umbrella, say, hey, this resource is part of this working group, and I think you should just have access to them as they are. Alternately, like you can use pipelines in Fabric to ingest from those. I think there's a lot of, like many tools here, once you have a lot of options, there's lots of ways to plug them together. So
that was the
but
name of your whole presentation. Flexibility. We are giving you a dozen different ways, more than a dozen different ways to do any one thing at any stored anywhere. I appreciate
with great
that.
power comes great responsibility. So,
Exactly.
I know that can be very, like, even for me, some preparation for this was a little bit overwhelming because I don't use a lot on my day-to-day, a lot of these kind of low and no code tools. And I'm just like, there's so many, which is good. So, but it means, like, the thing that really appealed to me about that is I can work with people who would normally work with other tools than me. Like, I can work, I work in usually VS Code, Jupyter Notebooks, Python scripting. I can work with someone, even working sometimes with someone in PyCharm might be a little tricky just because we work differently. Now, like, imagine working with someone who works in Power BI or even Excel. Like, obviously that's a cool combination, but it is kind of a different mindset. And so I also see it as kind of an accessibility tool that, is easy for me to then work with other people.
Very cool. All right, I can keep you on the stream while we go through a few of the closing announcements and say goodbye. Cool. So excellent talk. I just want to remind everyone today, this may be where you are. You could also be joining us from Twitch. Make sure you like and subscribe. We have great content coming out on both of these channels, wherever you are. And let's give it a like because I love that presentation. It was fantastic. I unliked and then liked because I wanted the whole thing with it. I wanted the interaction. I'm that corny. We also have Python Day collection in the description in the show notes that I'm showing you. I opened it up on a new tab. We have a whole bunch of resources for you. I clicked through to the Cloud Skills Challenge that is working, and we'd love for you to all join. And then here's the Cloud Skills Challenge. We have a GitHub repo that is advertising all of the Cloud Skills Challenges today. I'm a web dev. I think you should go for number 2 first, but you get your pick in. You don't have to listen to me. You can do any of these Cloud Skills Challenges, and we'd be more than happy to have you join us with this learning journey. I also want to encourage everybody to join us at MS Azure Dev on Twitter. We have tons of chatter over there. We have tons of conversations. We talk about the live streams that are going to be coming up. And then we also talk about new features and releases on Twitter. So join us there as well. And I have the Discords up. I hope this is large enough. I increased the size several times over. So we have the Azure Discord, and then we also have the Microsoft Python Discord. Tons of friends over there. And then we also have the event details. That's what we're doing today. All full circle. We keep all of this updated. So thanks so much for joining us. We're going to be back in an hour for lunch break. Go stretch your legs, have a chai, but you don't want to be late for the next presentation. We're going to be building intelligent Python apps and microservices with Azure Container Apps. We have great conversation lined up for you all. So join us back in just a bit.
Let's see everybody on Discord.
Bye, y'all.
Welcome back, everyone. I hope everyone got a coffee, got a matcha latte. That's what I ended up making myself over here. Whatever caffeinated beverage or stretch you wanted to do to wake up for the second half of the day, because we have so much great content here to share. While we were all on break, we also added some of the links here. Oop, that way. The links are over there. Just the Cloud Skills Challenge that we keep mentioning. And so that's now available for everyone to try it out. No matter what your level is, no matter what you're trying to learn, it's a great way to get started because we've seen so much cool content here today. And so how do you take that and actually start actioning on it and start becoming an incredible Python developer? We also have the weekly community stand-ups with all of our Azure service teams that we've mentioned along the way as well. The next session is Container Apps, and their stand-up is the first Thursday of every month. It's the first Tuesday. I wrote it down, actually. It is the first Tuesday of every month. So please join with that link there. And that's also where today's recording will be. So remember that, subscribe to the YouTube, and so you'll get all the notifications of the cool Azure community stand-ups that are happening and the links to the recordings from today. More ways to get connected with our Twitter, Discord for both Azure and Python, and then more Learn documentation there with just all of our collections of things and how to get started. For the second half of the day here, we have first starting out Anthony and Pamela. We're going to learn about Azure Container Apps. Bring them on now. How y'all doing?
Hello. Hello.
Welcome, welcome. So what are we going to be learning about today?
We are going to be talking about Azure Container Apps, but also for this talk, we have ported my favorite OpenAI sample to Container Apps. So we'll also talk, a little bit about how that works.
Awesome. Well, we are so thrilled to have y'all joining us. I'm really excited for your session. I'll let y'all take it away, and I won't take up any more of your time.
All right, sweet. So let's just start with intros. So I'm Pamela, and I am a Python advocate on the cloud advocacy team. So I work on all sorts of Microsoft products, any intersection between Python and Microsoft and Azure, whatever helps Python developers be more successful with Python projects. And I really like Python. I've been programming it since 2006, I think. So it's really fun to get to work on it all the time. Anthony, you're muted. Are you able to unmute yourself?
Yes, I don't know how I was muted. That was interesting. Okay. No meeting ever goes without somebody doing that. So I'm glad I'm the one. So my name is Anthony. I am a product manager on Azure Container Apps, and I'm super excited to kind of show you this really cool demo that I learned about a couple weeks ago from Pamela. It's actually it's not just a demo app. It's an app that's actually practical that you can install into your company and actually use it with your company's data. So can't wait to show it to you all.
All right, thank you, Anthony. Okay, so let's dive into that actual demo. So let's go into the screen share. I don't know how to control it. That's usually the magic behind the scenes. Thank you. There it is. All right, sweet. Okay, so yeah, let's just start off with actually seeing this app that we're building, because that's what's really fun. So here it is. It is running on Container Apps, and this is a chat with your data app. It's one of our most popular samples. It's been deployed thousands of times, and I've been helping to maintain it and figure out what the best practices are for deploying OpenAI apps on Azure. Now, originally, it actually deploys to Azure App Service, but special for today, we ported it to deploy to Azure Container Apps, because it's also a great place to host something like this. So you have a lot of options for where to host your apps on Azure. So what do we got here? We have this app where we can chat with data. And right now it has a bunch of sample data. It's just like a bunch of kind of corporate company stuff like benefits and perks and all that thing. And we have all these sample questions here. So, I can just click on one of these sample questions, and it's, I'm asking it what's included in my, health insurance plan that's not in the standard plan. And you can see that it, replied. And the cool thing here is that it has citations. So this is something really cool that you can do, with OpenAI, is actually get it to provide citations. And we do this using a technique called retrieval augmented generation. And the idea is that, basically we store some data in a search index, and then we ask it to search on that data and to answer the question based on that data. So in this app, you can actually see the thought process, which is really cool. Well, first, let's just click on a citation. So the citation, when we click on it, we see a page from PDF, and it's where it thinks the relevant content is. We can click on the other citation, and we see another page from the PDF. So we can also click on supporting content, and these are the actual search results that we told ChatGPT to constrain itself to. So we said, answer this question based off of these search results. So these are search results that we got back from Azure Cognitive Search. You could also use another vector database, and there's a talk coming up about like Cosmos Vector. And if you want to go one level deeper, we can even show the thought process, which is the actual conversation that we've had with ChatGPT. And this is using the chat completions API, where it's a list of conversations, a list of messages, and each message has a role. So you can have role system, which is what's called the system prompt, which is where you give overall instructions. So we say like, okay, you're this helpful bot, and you try to keep your answers only to the sources. And here is how you can list the sources. So, we tell it how exactly to, write those sources with brackets. And then here we have the actual question from the user with the sources that we found from cognitive search. And then we get back the answer that we see here. So this is a very cool way of working with OpenAI. It's increasingly very popular because it's a way of harnessing the power of ChatGPT to synthesize information while also keeping it on topic, constraining it to the data. So here's the sample. So how does this actually set up? How does this work? So here's, how we can do retrieval augmented generation. We get the user question, it comes in, and we use the question to search Azure Cognitive Search. And actually, we even do a step right before this where we use ChatGPT to convert the user question into a good search query, because sometimes a user question isn't actually like the optimal search query. So we actually use ChatGPT to say, okay, here's the question. Can you, formulate this as a keyword query? And it'll like kind of get rid of fluff and, make it into something that's a little better for a search index. So we take that search query and we send it into Azure Cognitive Search. And then we get back a bunch of results. And then, we send those results and the system prompt and the user's, past conversation history, all of that. We send all of that to ChatGPT again, and then we get back this response here. So this is the general approach for doing RAG. And of course, you can sub out different document searches, different large language models. You can experiment with different system prompts. This is all very new, so we're all learning, and there's like lots of really interesting papers and different techniques that are people coming up with the best way to, work with a system like that. And it's actually really exciting. Now we have, how do we actually deploy this on Azure? So I was saying, like, originally I deployed this on app service, but it was pretty easy to actually get it working on container apps as well. So for the actual container that's running here, you can see this is hosted on container apps. We've got, it's using some resources. So this particular container is using Azure Cognitive Search, Azure OpenAI, and Azure Storage. So I've got all of those deployed in the same resource group, and I use a system identity in order to authenticate to each of these so that I don't use keys. I never, ever want to use keys. I don't want to see a key. I always try to use, a managed identity in order to authenticate when possible, and it's almost always possible. So, that's how the container is able to, talk to these services. Is via using its identity, and its identity has permissions, specific permissions to use these resources. Now, there's also a script that I ran locally as part of the deployment process called prepdocs.py. and it's the script that does the data ingestion and indexing. So what it does is that we give it like a folder of documents, right? So we've got, a bunch of docs inside a data folder, and it'll be like a bunch of PDFs. I might have deleted those, but it'll have a bunch of PDFs in a folder. And the first thing it does is it splits it into individual pages and uploads each of those pages to blob storage using the Azure Python SDK that Rohit showed earlier. Then for each of those pages, it sends those through Azure Form Recognizer. And that's something that's just good at extracting information from PDFs. So that pulls out the text from the PDFs. And now we've got the text, but we still need to chunk it because we don't want to throw 20 pages into the search index at once. So we have, kind of a little algorithm that tries to figure out the optimal chunking to, maybe like split it paragraphs, split it tables, split it diagrams, that sort of thing. So the script does, this chunking. And then once we have the chunks, if we're using vector search, then we can use Azure OpenAI to compute embeddings. So that'll actually compute vectors that correspond to that text. And then finally, it puts the text and the vectors into Azure Cognitive Search into an index. So I can show you what that index looks like here. Here is my search index, and I just searched for star. And then you can see, it's just going to show me, everything. So you can see here's a particular, document in the index or, chunk in the index, and it's got a score, it's got an ID, and the ID has the name of the PDF and also a little hash there. It's got the actual text content. So there's the text content. So that's what we'd be, ultimately putting it inside our prompt to ChatGPT. It also has the embedding. So if we are using vector search, we can have it use embeddings as well as an option. So in this sample, you can use text, you can use vectors, and you can use hybrid. Hybrid is considered the best approach because then you're taking advantage of both vector search, but also, text-based search. But you have all those options. And then we can see, it came from this PDF and it was page 4. So that's just what, each chunk looks like in our search index. And then, when we actually search for health insurance plan, then it would filter the results based off that query string. All right, so that is the architecture for what I've shown you. And Anthony's actually going to be building on top of that architecture soon. But let's keep talking about, about how we achieved this. So I did deploy everything using the Azure Developer CLI, which Savannah showed earlier. I am a huge fan of the Azure Developer CLI. I'm kind of known as like the AZD fangirl around our team. So I pretty much AZDify everything I can. I have fallen in love with infrastructure as code, even though it's not perfect, but I do love it. So I do use AZD to deploy it, and you can see, so this is my azure.yaml, and this tells AZD that the host is going to be container app, and it shows it what code to use, and then it can look into the bicep file, and the bicep file has information about the container app and how it's going to set up the container app, and also passes some environment variables to it as well. So it is deployed with AZD. And so if you want to try deploying it yourself, we have it all in this branch, aka.ms/aka-rag. So you can, in theory, you should be able to check out that branch and run AZD up and get this running yourself. And we are using containers. So there's many ways to deploy containers on Azure, and they range in terms of their flexibility and the amount of features you get. So I think of Azure Kubernetes service as being the most flexible, but also requires a lot of ops. Now, I personally do not know Kubernetes. If any of you, in the chat do know Kubernetes, it's cool. Tell us. I have not learned Kubernetes yet. And then we also have these, platform as a service like Azure App Service, Azure Functions, and they provide a lot of features. So I do use those quite a bit as well because I do like all the, the platform as a service features. But then Azure Container Apps is really nice because, you get the ease of having a container and hosting it at Azure, but you don't have to do as many ops, right? Azure is taking care of the ops for you so that you can have these containers. So with Azure Container Apps, we can have this container apps environment, and inside that container apps environment, we can have multiple container apps, and each of those can have revisions, and the revisions can have replicas. So you can have this orchestration of containers without really having to know Kubernetes. As I was saying, I don't know Kubernetes, but I've run my personal site on Azure Container Apps for a year, and it's been great. So with Azure Container Apps, you can pull images from any container registry. Here I use Azure Container Registry, but you can use another one. The pricing is consumption-based. So if you're not using it a lot, then that's fine. You're not going to pay a lot. And you can even scale all the way down to 0. So that's why we consider this a serverless option, because you do have that scale to 0 consumption-based pricing. So let's talk about that scaling. With Azure Container Apps, there is auto scaling, and we are going to show that off. Let me get my Locust running here, and let's get the scaling open up. Let me reload this. All right, so right now I've got a single replica going, and I can see like scale rules here. The default scaling rule is going to look when there's more than 10 requests per second, and then scale it up. So right now there's only a single replica. So let me just get the interface open here. Burr, burr, burr. Okay, or if it's not loading, that's why we have a preloaded demo. Yay! All right, I'll just open this. Okay, so we'll just watch this. Okay, so what I did is set up a load test using Locust. Locust is a tool in Python for running load tests. You could also use Azure load tests, whatever works for you. And then we've got the replicas tab over here, and we can see it starts off as 1, and then I just keep refreshing it as the RPS goes up. So you see very quickly, I'm load testing 50 users that are really, really quickly hitting up this app, 300 RPS, which is a lot, but still 0% failures, which is awesome. And you see, as I refresh, it's starting to spin up more replicas. So you see a bunch of replicas that are in the not running state, but they are getting started. They're building, warming up that container. So as keep refreshing, we see more and more replicas will come online here, and so they're coming on there. And there we've got 4, and then we go to the end. And there's my YouTube recommendations. Nice. But by the end of it, we get all 10 running. So it doesn't take very long to ACA to realize that, oh, we've got a lot going on. Okay, let's go over to Anthony.
All right. Let's switch over to my screen here. Can I do this myself? Looks like I can. Awesome. So we just learned about how we can deploy an app to Azure Container Apps. So I'll kind of quickly go over what does this do? So we'll quickly go over what else you can do with Azure Container Apps. So we just deployed a web app. So that's an app that's currently running, it could be running on a Python server, it could be running Node, it could be running really any kind of HTTP endpoint. And we can also do public APIs as well. That includes HTTP APIs as well as gRPC. And we can also do event-driven processing in Azure Container Apps. So these could be applications that are kind of constantly pulling messages off of a queue, so that you can process them in pretty much real time as messages appear. And we can also do background processing. These could be things like a scheduled job that runs in the background, or you can actually have a job that you can trigger manually or on demand. So like applications can actually trigger jobs programmatically in container apps. And we can combine all these things together and build microservices. So this allows us to add functionality to our app without kind of adding it all to a single app and making a giant bloated app. Instead, we can actually deploy multiple services that each implement a different functionality, and then we can scale and work on each of them separately. Cool. So let's head over to this app here. I'm going to quickly ask it a question that it doesn't know. So what is Azure Container Apps? So it should not know about this information because we only loaded it with some fake HR documents for our kind of fictitious company here. So let's figure out how we can add and index some information about Azure Container Apps. So currently, as Pamela pointed out, we are running a local script that is able to take a PDF and deploy that, or kind of index that into our Azure cognitive search. And what I'm going to do is I'm actually going to take that script and turn it into a Container Apps job. And then we're also going to deploy a web front end for that. And just quickly about apps and jobs. So apps are things that kind of run continuously. You can think of those as web server, like web servers is a good example of it. And a job is something that runs to completion. So, so the script that we have is going to go and process a single file, and then it's going to stop. So that's the difference between apps and jobs in Azure Container Apps. All right, so let's take a quick look at our code. So this is our the same script that Pamela went over earlier. That's going to do all the chunking and indexing of the of the PDF into Azure Cognitive Search. I won't go into too much details there. I did want to say the word chunking because I thought that was a pretty cool word. And then, in order for us to turn it into a Container Apps job, we just created a Docker file for it. And then we ran a couple of commands. And that is here. So the first command is we ran a build in Azure Container Registry. So this is actually a build of our container image, but it's actually running it in the cloud. So you actually don't have to have access to Docker on your local machine to even run this build. And the next command that we run is a little bit longer, but the main things to focus on is that we're deploying a container app job, and with the trigger type manual, because we're going to trigger it from our web UI. And we've set a bunch of environment variables. There's actually another like 12 of them that we set. But that's it. We just ran those two commands, and we have our job up and running. And the next thing that we did was that we built a pretty simple web UI. I actually did this part, so this is probably the simplest web app you can probably build. It's got a file upload box and then an upload button. And then when you click the upload button, it is actually going to first upload a PDF to Azure Storage as a blob. And then it's going to first set a URL, and then pass that URL into the job as an environment variable. So it's actually going to kick off an execution of the job, which is that prep docs Python script that we saw earlier. And I think that's it. And then we also built a Docker file for it, a pretty standard Docker file. And the command that we ran to deploy it is this AZ container app up command. I can run it here, but it's already been ran before, so I won't. But what it does is it's in a single step, it's going to build our application into a container image, push it to Azure Container Registry, and then deploy it to a container app. Okay, so let's see this thing in action. So here's the app that's already been deployed. And I'm going to go and select a file. And then I'm going to go ahead and upload it. So the file that I uploaded is, so you can see that it's starting the job now. The file that I uploaded was I went to the Azure Container Apps documentation, and I just clicked this download PDF link. It actually downloaded like some 600-page PDF, and I just uploaded that to our app. And here in the Azure portal, you can see the job that I deployed before. You can see there's a manual job and some settings here. If I wanted to, I can actually click run and run the job from here if I wanted to, but I won't. And here, if I click on the execution history, you can see that it's currently running. So let's go back to our UI and see if the job is starting. So you can see that it's there it goes. It's actually getting some live output from the job. So it's going to take another 15, 20 seconds or so to basically chunk everything and then index it all into Azure Cognitive Search. So we'll wait another few seconds for that to finish. It's almost there. Waiting. All right, it's done. So let's switch over to back to our app here. And then if I ask the same question, and if anyone else has a question that you want to ask about container apps, please throw it into the chat and then we can test this out. So what is Azure Container Apps? And hopefully this time it'll actually know the answer because we added it to our search index. And it did. And I don't know if anyone else actually asked a question about container apps. Pamela, do you have a question that you want to ask about container apps that we can try here?
Well, Daniel wants to know if there's going to be a saving or reserved options for container apps. I don't know if the docs are going to have that information.
Yeah, because we don't have that yet. We are actually working on it. You should hear something about that in the next 3 to 6 months, I would say, but we're currently working on that. I guess we can try it out. Maybe we can say, how does billing work in container apps? Hopefully it'll give us a good answer. If not, it's probably because of that terrible web app that I wrote.
There we go.
There you go. It actually gave a pretty good answer about how billing works in container apps.
Oh, so it is, but it says resource consumptions of vCPU seconds and HTTP requests.
Yeah, so how container apps are built is that when your container apps are running, we're billing you by basically a couple of metrics called vCPU seconds and GB seconds. That's basically how much CPU and memory your app is using. But as soon as it scales down to 0, you stop getting billed.
Yeah, I mean, I was saying I ran my personal site on container apps for a year, and my personal site's not very popular, but I was happy to not have to pay very much.
Awesome. Yeah, so that's it for this demo. I can switch back to my slides, actually.
Okay, so this is what we wanted to show today. We've got a bunch more links here if you're excited about container apps and and want to give it a go. We've got tutorials about deploying a very simple Flask and Fast API app to container apps. Even if you're brand new to Docker, you should be able to follow that. There's lots of AZD templates for Python plus Azure Container Apps if you're excited to combine AZD and Python. There is this sample that we showed. This is in a branch of the main repo since the main repo does deploy to app service right now. So we'll have to decide, ultimately where to go. So many good options. But you can, check out this branch and run AZD up on it and get this all running. And Anthony, it looks like Container App team has a whole GitHub where you all receive feedback, right?
Yeah, so if you have any questions, go to that AKA link there. It goes to our GitHub repo where you can actually file issues. That's where we can answer a lot of your questions, as well as on that README in that repo, we give you a link to join our Discord server, and you can ask those questions there as well.
Nice. So do we have any more questions for us or for ChatGPT?
We got a lot of questions going while you were speaking. Oh, we did get one. Did get another one. Let's see. Do you have a preference for Flask Fast API over Django or for containerizing apps?
That's a really good question. So we have we've containerized all of those. Our tutorial only shows Flask and Fast API because that particular tutorial doesn't include a database. And of course, if you're doing Django, you're using a database. So we were making that a simpler tutorial. Because in that tutorial, we do use the AZ container app command, which Anthony showed for deploying the job. And I think that's a great command when all you're doing is deploying a single container. As soon as I start using multiple resources, like if I'm making a Django app, then I've got Postgres, maybe I've got Redis for caching. That's the point where I start using AZD because I like to declare all my resources declarative, in the bicep. But in terms of what works well on ACA, I mean, I think they all work really well. That's the beauty of containers, right? Is that, you set up the environment and it works well for it. I don't know if Anthony has any, thoughts on that.
No, you covered it pretty well.
I think we have a time for another one. Let's do this one.
Yeah, so Doug is asking about PDFs for the data ingestion. So this is specific to the REG sample. That is a very popular question. This particular sample only handles PDFs. There's another sample I work on that does ingest a few other types. I have seen, requests for images and maybe even seen some WIPs about that. So, I think give it give it a few months and we'll see more types added. And of course it's open source, so you could fork it and work on it, but we're also actively working on these things too. So check back soon.
Awesome. I think that's all we have time for today. It was a jam-packed presentation. Thank you so much, Anthony and Pamela. It was great. We had so much interaction in the chat.
Thank you.
Thanks for having
Bye,
us.
y'all.
Wait, should we go?
It was a great chat today. Let's put there you go. Let's put the schedule back on. It was so exciting to chat with everyone today. We're going to continue our AI push for the second half of the session. There are a lot of ways Azure Functions come in handy, and I'm a fan right here. And we have a really cool demo in store. I love that any presentation that also includes testing, and it's a high bar because it includes testing in the title. Let's bring Anton up. Anton, it's great to meet you.
Hey, hello everyone. Nice to meet you too. That will be... Sorry, go ahead.
Yeah, tell me a little bit more about what's going on. I was interrupting you.
Yeah. I mean, I was just about to say that will probably be my longest session, because for me it will start on Thursday and end on Friday, because I'm based in Ukraine, and now it's 11, basically 30 minutes till midnight for me.
Oh my God, thanks for being here. That's so great. Sending good energies to you. And you're going to have some great dreams about snakes and Python and geo-distributed APIs. It's going to be awesome.
Definitely.
So without further ado, I'll let you get to it.
Yeah, thanks. So let me share my screen first. I would like to share my entire screen, and I would also like to put my presentation there. So yeah. Hello everyone, my name is Anton. I'm Microsoft Regional Director and also Microsoft Azure MVP. I'm based in Kyiv, Ukraine, and here you can see my email. If you will have any questions about this session, even after my presentation, feel free to drop me an email. I usually answer them on a regular basis. So today I would like to basically tell you a story about how we built an geo-distributed API based on the Azure Functions for one of the projects. Unfortunately, that project is under NDA, but I will make all of my examples about pretty much a very similar company, pretty much a very similar concept that I was able to find over the internet. So the first question is, why do we actually need the geo-distributed API in the first place? So usually when I'm asked that kind of question, I go for recovery, availability, and performance. So first of all, recovery, in case you have an issue with the data center, with some of your underlying hardware or even like virtual resources, if you have some other copies of your app deployed into the other data centers, you can actually switch the traffic there, and in that way you actually achieve the high availability as well, because now you don't have a single point of failure. And of course, performance. Why performance? Because if you deploy your app globally, if you will have the global presence, in that way you will eliminate the effect of the network latency for your users. So therefore, you will be able to get more performance. And actually, it will be also easier for you to manage the performance, because now you don't need to have like a huge super duper mega cluster for your app. You will just have like a bunch of smaller copies of your app, which will be much easier to scale. So let's actually get down to that story. So once upon a time, what was happening once upon a time? Once upon a time, I was doing my groceries, and this is the company based in Ukraine. This company, they produce a lot of stuff like food products like ketchups, mayonnaises, and so on and so forth. And they are actually doing the exact same thing that we were doing for one of my clients, who is unfortunately under the NDA. So what was the business need? The main business need was try to go through the digital transformation of that company and also enrich user experience by breaking down the physical dimensions of item packaging. So that company, they produced a lot of luxurious goods, and they want to get their clients more engaged. And that's why that was the idea, that we can try to break those the physical boundaries of physical dimensions. So what we decided to do, on each item, on each SKU, we printed a unique QR code on the package. Okay, and that's how we were able to identify each and every unique product. Those QR codes, they were printed directly on the factory which manufactured those items, but on the same hand, we didn't know exactly from that factory to which country that shipment will go. So basically, they have like a huge assembly line which produces like, I don't know, thousands of those items per day or per week, whatever. But then they are distributed globally, and we don't have the control over which exact item will go to which country. So that is why when the person will scan with his or her phone, will scan basically that QR code on that package, we need to be able to redirect that person to the local website according to the rules that marketing team define. And also by tracking those scans, we aimed to get more insight on the correlation between the interest and the actual purchase of each particular product. So that was actually a really, really interesting project, not only from the technical standpoint, but also from the business standpoint. And let me try to talk a bit more about the usage flow, so how it actually look like for the client. So let's say that we have our factory. Let's assume that the factory is in Ukraine. So we basically produce that item in Ukraine, and we print, as I was saying, that QR code also on the factory in Ukraine directly on that package. Now we distribute it to the 3 different locations, to 3 other different countries. And for example, when a person in UK will scan that QR code, we want to redirect that person to the local website, something like www.co.uk. When the person in Ukraine will scan the same QR code, we want to redirect him to www.uk. Let's assume that we also have a person in Sweden who will do the same, but for the Swedish market, we don't have a local website yet. So that is why, as a fallback option, we will direct that person to the UK site as well. So this is what we need to configure on our side. This is what we need to create, the way to use the same QR code redirect the person to the local website according to the different marketing rules. So what were the challenges that we faced during the implementation of that project? So the first challenge was how to create a single entry point. And to solve that kind of a challenge, to address that, so the usual scenario will be to go with the services like the traffic manager. The traffic manager is basically a service that allows you to manage your DNS and configure how the DNS will be resolved according to the different profiles, and it will allow you to create a single entry point, like a global DNS name, and then you can connect, for example, your West Europe endpoint, your Japan East endpoint, and your Central US endpoint to that global DNS name, and it will be resolved. If we are talking about the performance profile, then it will always be resolved to the closest host to the actual user. And also in case if the central US for any reason will go down and the health checks will start to show that that part of the region is unhealthy, then the traffic manager will automatically basically remove the central US region, and all traffic will go only to the healthy regions. Unfortunately, the traffic manager, and I do like this service, but the thing that I don't like about this service is that it's allow you to only manage the DNS. So it's really cool, but it's not always enough. So that's why, as an alternative, a bit more complicated service, which actually addresses the challenge from a totally different angle, this is the Azure front door, because the Azure front door allows you, so it's intercept the traffic. First of all, it's not only resolves the DNS name, it intercepts the traffic. It allows you to define your routing rules. It can handle the SSL offloading for you. It has the web application firewall capabilities. It allows you to do the VNet integration in case you want to ensure that all of the traffic that goes into your app will need to pass the front door first, and actually much more features. But I don't want to talk a lot about that. I want to jump into my first demo because I don't have a lot of time. And actually, this session, it was originally created and meant to be like an hour and a half, but I have only 30 minutes now. So what I have here, I hope you can see my Azure portal. I've already pre-configured some infrastructure, and the points that are interesting for us are the following. So first of all, I have 2 instances of my Azure function. Both of them are using consumption plan, and as you can see, one is deployed in East Europe, the other one is deployed to East US region. I can actually go through each function directly. That's not a problem at all. Let me just show you. I've deployed a sample function there, so I can just call it like this, just to show you that something is there. And I can also try hello PyDay, for example. Yeah, name PyDay. Okay, it works. So the Azure function actually works. It's based on Python, of course. And what I have here, the first thing that I would like to show, I have the traffic manager profile. So if you will take a closer look, then the domain name for my Azure function now looks like PyDay Demo West Europe, for example. But if I will go here, I have a totally new domain name, which is PyDay Demo DM for traffic manager. So let me just copy this guy and let me try to paste it here. And yeah, as you can see, it's 404, not found. And probably you also noticed one detail. So it says not secure, and we don't have a valid HTTPS certificate. But this is actually how it should be. I can go to sample. I can see the same response as I showed you before. The reason why we don't have a valid SSL certificate in the case of a traffic manager, but we do have a valid SSL certificate in the case of Azure Function, it's because the traffic manager will only route the DNS for you. That's it. So if you want to add the support for a custom domain, you will need to bind a new custom domain name to this traffic manager endpoint. That's the first thing. And then the other thing, you need to manage all of those certificates by yourself. You need to go to each and every instance of the Azure function and then basically put the certificate there, which is doable, but still this is a lot of unnecessary work. What I also wanted to show, I want to show that my traffic manager is connected to 2 different endpoints, and they are working fine. I can go to the configuration, and as you can see here, I can choose the routing method. I can choose the monitoring protocol, the URL, which is sample, and so on and so forth. So it's really customizable. I can configure a lot of things here, and everything will work like a charm. The second option, the Azure Front Door, as I was saying, the Azure Front Door will do much more than just DNS resolving for you. So the Azure Front Door also has its own domain name. Let me try to access this one. And I will go to sample. Yep, it works fine. And let's do hello AFD for Azure Front Door. Yeah, hello AFD for Azure Front Door works as well. So what the Azure Front Door can offer you when we're talking about creating a single entry point for your globally distributed solution. So let me go to the front-end manager, because here I will show you everything basically on one plate. So first of all, it allows me to define my origin group, and now I have only one. I named it backend. And if I will go here and expand it, oh, sorry, no, I need to go here. Yeah, if I will go here to the backend, you will see that I actually have 2 endpoints here. It's again my East US and my West European endpoints. If I want, I can enable the sticky sessions or the session affinity, as it's called here. Usually I don't do that. And if you have an option not to use sticky sessions, then please don't use sticky sessions. I can enable health probes if I want. I basically can configure the health probe in the same way here, providing the path, providing the method, the interval in seconds, and so on and so forth. And for each endpoint, as you can see, I can configure that for this endpoint, it's the app setting, and this is this app service, and this is the actual name of my app service. So everything is working out of the box. It can actually work exactly the same even if you have your infrastructure deployed somewhere else outside Azure, because if I will add a new endpoint, you can see that there are a bunch of different types of endpoints that are supported here. So I can go with public IP address. And if I will choose public IP address, that basically means that I can route the traffic to any point in the world. I just need to know the exact IP address. But also, there are a lot of native Azure services that are supported out of the box. And for those services, the configuration is simplified, and it's much easier to handle that, especially if you're just starting to work with this service. And also, I have one associated route to this backend pool. And okay, sorry for that. I probably need to go. Oh no, sorry. This one. Yeah, sorry, I just clicked in the wrong place. So I do have one associated route, and for now I have only one public domain name that is binded to my front door, and this is this name. It looks a bit random, which is also a fact, but the reason for that is because all of those names should be unique across all of the data centers across the entire world. But you can easily bind your own CNAME to this endpoint, no issues at all. And furthermore, you can not only bind your own CNAME, you can also ask Microsoft to provide a free managed SSL certificate for you. I mean, like, how awesome is that? So additionally, I can define the pattern to match, and in this case, I will match basically any URL. I will accept, as you can see, both HTTP and HTTPS protocol. I can say that I want to redirect all the traffics to HTTPS, and that redirection, it will happen on edge. So let me talk a bit more about the Azure Front Door. The Azure Front Door, it's a service that is always deployed globally across all of the data centers simultaneously, but not only that, it also will be deployed across all of the points of presence, which you may also know as the CDN nodes or edge nodes. Which basically means that when the user will send the request, it will not hit the Azure data center directly, it will hit the edge node first. And if you have this option selected here, then the traffic from the HTTP will be redirected to HTTPS directly from that edge node. And additionally, because the traffic is intercepted by the front door, it's another awesome thing, because in that case, Microsoft will guarantee you the quality of service for a network connection. So now you don't need to think about, okay, how my user will connect to my endpoint if the user is located, for example, in Ukraine and my host is located in US or something like that. No, you will hit the closest point of presence, and then from that point of presence to the actual host, in case you have it in Azure, the traffic will go through the Microsoft-owned network, where Microsoft will guarantee the quality of service, as I was saying. Yeah. Also, what I have configured here, the traffic from this domain that matches this pattern will be redirected to the backend associated origin group. And the forwarding protocol will be HTTPS only. That basically means that even if I will disable that, the traffic will hit the front door with the HTTPS protocol, but the front door will redirect that traffic to the original endpoint using the HTTPS only. Or I can do match request or something else. And also, if I want, I can also enable caching, because front door can also work as the CDN for me. So those were really kind of a quick explanation of all of the features that you have here right out of the box. But another thing that I also like, unfortunately, I didn't configure anything yet, but you can configure your custom rules. And when you're configuring your custom rules, let me try to do that really fast. You can say that you can add a condition. For example, let's say that, I don't know, request file name contains, I don't know, PNG. Oh, sorry, I need to hit edit here. Contains PNG. Then I can also do like to lowercase, for example, to make sure that if it's PNG capital or something like that, then it will have this rule. I can add an action. I can modify request header, modify response header, and do a bunch of other things. So there are a lot of applications for that one, but the one that I want to at least partially talk about will be the, let's say, security application. And by security application, I mean the following, that usually when you create an API, the API can expose with the HTTP headers, same as the website, by the way, it can expose to the HTTP headers some additional information about the, I don't know, like which web server we're running on, which operational system we're running on, and so on and so forth. And you don't want that information to be public. So in this case, you can define your own rules and you can modify the response for, we can modify the response header for all of the responses, for all the traffic basically that goes through your front door. And in that case, that will be one more option for you to also increase the overall security of your setup. So yeah, really cool service, really love it, and definitely recommend to try it. Let me actually get back to my presentation because I can see that I have only 10 minutes left, and I also want to talk about a few other things. So things about the global presence, and this slide is actually a bit outdated. I know that there are definitely more regions now, and also on this slide, as you can see, the Poland region was just announced, but now the Poland region is up and running. So the idea about the global presence is that the Azure was pretty much the only option for us when we were choosing between 3 different global cloud providers. And the reason why Azure was pretty much the only one option for us is because Azure has the biggest amount of data centers that are basically deployed all around the world. So the goal of the company was to deploy the API as close as possible to each and every user. So that's why, as I was saying, basically Azure was pretty much the only option for us. But now when we're talking about creating a host for our API in each and every region, and there are a lot of them, let's talk about the next challenge, the reasonable cost of ownership. And for this one, I would like to talk a bit about the consumption model of Azure Function. And as you can see, the issue with the regular VM or similar services deployment where you have the fixed, let's say, amount of dedicated resources that you request from the vendor is that at some point when you will need to scale, of course, you can configure auto scale for Azure Container Apps, for the VMs, for Azure App Services, and so on and so forth. But you always need to scale up front. And usually the recommendation is to trigger the auto scaling when your utilization reached around 70% of the CPU. But the thing is that, for example, at this point in time, as you can see, you will need to scale, but still all of that capacity that you have here under this area, it's underutilized, but you need to pay for that. With the consumption plan, you get the true taste of, let's say, pay-as-you-go cloud pricing model. Also, when you need to scale down, you always need to scale down with the delay. And the reason why you need to scale down with the delay is because scaling up is not instantaneous. So even when the load is gone, you still, just to be sure, usually wait like 5, 10, or whatever minutes before you trigger the scale down process. And also you, in most of the cases, will need to suffer from over provision of your resources because when you are requesting, let's say, a new instance of your host, if it's the VM or if it's the app service, you cannot request, I don't know, something like 2.1 CPU. You need to request either 2 CPUs or 3 CPUs. And in this case, if you need more than 2 CPUs, or actually it's more than 3 CPUs, you need to go for 4 CPUs. You cannot choose like 4.1 or 4.2 that you need to actually cover this load. And also talking about the reserved and on-demand capacity, this is, as I was saying, the big benefit, at least to me, of Azure Functions is that when you have a reserved capacity, you can imagine that as a funnel. And the bottom, basically the bottom area of the funnel, it's your reserved capacity. And the top area of the funnel, it's all of your users that are trying to submit some jobs to your app, whether this is the HTTP request or anything else. So that's why with the reserved capacity, you, in most cases, will have something that is called queuing. But with the on-demand capacity, you can imagine that as a scale, and on one side of that scale, your users will start basically putting those jobs, and on the other side of the scale, the cloud vendor will start putting the workers to basically balance the amount of load with the amount of compute resources that needs to handle that load. I will skip the slide about pros and cons of Azure Functions because that was already mentioned, I do believe, even a few times during the presentation. The most important part is that you can run your Azure Functions not only in Azure. You can run them on premise, you can run them in Docker, which means Kubernetes, you can run them locally. So this is the really, really good and flexible framework in a way that you can literally run it everywhere. So challenge number 4 was the cold start, because when you're just starting your app, if it's cold, it needs to do a lot of stuff before it will actually run your code. When it's warm, it runs your code directly. The way how we actually solve that, the way how we handle that, it's a very, very easy thing. We handle the cold start with the health probes. So we configure the Azure front door, and we configure the health probes to continuously hit all of the instances of our Azure Functions. And if we're talking about the Azure Functions, let me pull this information up. This is the pricing model of the Azure Functions. So with the pay-as-you-go for the consumption model, you will pay literally peanuts for those health check endpoints. I don't have the math right now, but I do remember that when I was calculating that for the other project, the price for the health check endpoints was something like $2 or $3 per month for every new region to keep it warm, just because of the health check endpoints. So you can imagine that comparing to the entire price of the entire infrastructure, paying like even $5 extra bucks for keeping your app always warm, it's a really good deal. Basically the only one more thing that I would like to talk about was the last challenge, because now what we also need to do, all the traffic will go through the front door. The front door will add a specific HTTP header, which called x-forwarded4, and that header will show you basically what was the original IP address of the user who sent that request. So the challenge number 5 was to have an engine that will allow us to basically map the IP address of the user to the country code. And we had 3 options for that. So first of all, we had an option to use a third-party service, but we didn't want to go there because, first of all, that's extra latency. Second, that's extra dependency. We don't know how to manage the basically uptime of those services. Of course, we can always believe that the vendor will do their best, but still, if there is an option to avoid that, then we wanted to avoid that. The next option was to go with the SQL database, or maybe like the NoSQL database, but we didn't want to go there as well because of the cost, because we wanted to deploy that database again as close to the function as possible. So the function needs to be deployed in every region, so that database or that engine needs to be also deployed in each and every region. So that's why we went for the option number 3, the key value store. In this case, we were using the Azure Table Storage. And for the Azure Table Storage, this is, again, probably my second favorite service after the Azure Functions. The idea there is that Azure Table Storage allows you to store a lot of data and allows you to do that really, really cheap. And if you're always accessing those data by well-known key, then it will show you a tremendous performance. So really, really recommend that. that, unfortunately, the Azure table storage, because it's not like any other database or data storage, it needs some re-engineering. So, but if you will apply a little bit of the elbow grease to that, then that will work as well. I know that was really fast, but I tried to squeeze as much as possible into that presentation. So for now, that's it. Thanks, guys, for your attention. Do you have any questions?
That was so awesome. I wish our streaming service had like features where we could put up like a whole bunch of claps or confetti or celebration, because that was awesome. I've never seen anyone take an hour-and-a-half long presentation and put it into a half hour where it still made perfect sense, and it was awesome. Not only that, but also you're at midnight, so so many rounds of applause. Thank you so much, Anton. This is wonderful, and we're so thrilled to have had you here today with us.
Thank you. As for the questions,
I think you've answered pretty much all of the questions that I have seen. So I think we are, we got lots of thank yous and way to go, awesomes.
Cool.
So I hope you sleep well and get some good rest after that. Your energy was awesome for being so late. So I hope you didn't have too much caffeine to keep you up all night.
No, it was just 10 cups of coffee, so that's a regular day for me.
Oh, good. So you'll be able to sleep perfectly fine here in a second.
Exactly.
Thank you, Anton.
Okay, thanks everyone. Have fun. Bye.
So thank you so much, y'all, for sticking around for the second half of the day. This is going to be super exciting because we are now moving into the AI portion of the day. To start us off, we're going to start off with a session on coding a drone, which is a really cool use case for AI. So I'm going to bring on Bruno here to join me. I'm super excited for this. I love AI. AI is like the hot topic. And so we're starting off strong with making a drone. Can you tell us more about that?
Yes. Hey, no pressure. I've seen the stream so far. So many amazing people, so much knowledge here. And then I came here with my toy, with a small drone to play around with Azure OpenAI and more. But yes, that's kind of the idea. So first of all, thanks. Hey, and this has been amazing. I've been watching this in the second monitor, and it's a great day. I'm looking forward to share my 20 minutes of AI and a drone.
Yeah, I mean, I've had so much fun, and I've learned a lot, and I'm excited to keep learning. So I will hand it off to you so you can get us started.
Perfect. So as I said, hello, everyone. My name is Bruno Capuano. I live in a small city near Toronto. Not in Toronto. You're probably not Canadian. You probably noticed the accent. I was born and raised in Argentina, live in Spain, and moved to Canada several years ago. And hey, I love to tinker around, learn new technologies. I lead a team of advocates focused on programming language. And today I want to talk about drones and OpenAI and Azure OpenAI and how we can use GPT models to generate code to fly the drone. So if we can share my screen, I am going to use 2 or 3 slides just to basically set up the context. This is what we are going to do. We are going to basically connect to the drone. I already showed the drone. It's a small drone. And we are going to write the SDK to do this from scratch. This is the drone that we are using. It's not a professional drone. It's not in the $1,000. This is around $100. It's literally a toy, so you don't expect much. You can see here in my hand that it's super, super small, 10 minutes battery, but it's good enough to play around. Why? Because even if we don't have an official SDK, there is a document around the cloud that you can find that basically explains how these drones work. So when we connect to the drone is going to allow us to connect via Wi-Fi. And by the way, if you use an official app for the drone, you are going to have access to the control of the drone and more. But if you want to write something on your own, you can basically connect to the drone. And then when you are connected to the drone, you can open a couple of UDP ports. UDP, not the best communication protocol. It's if you are used to TCP, UDP, I have so many jokes about UDP. I'm not going to go to the joke sections, but hey, you open a couple of ports and you have a port to send commands to the drone. You have another port to read information from the drone, like the battery and the altimeter and a couple more. And then you have a third port to access to the camera. So I am going to share the resource at the end. So if you want to dig around this SDK, this PDF, the drone and more. But once you have this, you can start to play around with the drone. And this is my last slide before going to code. But I want to show you this because it's important. This is a toy. So when I connect this from my machine to the drone, right now I'm connected via a wireless network cable to the internet, and then I am going to connect to the drone, but the drone gets disconnected. Usually in the middle of the demo, it stopped working, these kind of things. So that's why I am going to do the fly demos at the end. So this is kind of the idea. This is kind of what we will see today. So stop slides, no more slides. Let's try to write some code. Before going to the code, this is something that we are going to see a lot. This is my command window where I have here, let me minimize this and show you what I have here. I have a ping to the IP of the drone that I already know in T because I want to know when I am connected. And when I turn on the drone is going to start a Wi-Fi hotspot. I can connect using Windows, but Windows is going to detect that I don't have internet connection with the drone, so it's going to get disconnected. What I do here is basically I do a net sh with a command to connect to the drone, and you can see here that I have the reply that, hey, I am connected here. So I have a reply from the drone, the pin is working. From time to time, I need to go back here to see am I unconnected. Once that is done, let's write some code to connect to the drone. So first, as usual, some imports. What are we going to do here? What are we going to use? Sockets. Remember, we talked about we need to open a couple of sockets using UDP. Time to do the worst, literally, the worst timeout routine ever that you're going to see, and threads, because I am going to open the connection to each one of the sockets in different threads so I don't block the main operation, the main application. So once I have that, couple of lines to basically receive information from the drone. Don't do this at home. I am writing here literally a while true with a try, catch, a try except with no condition, no anything, but hey, kind of works for this demo. And I'm going to read from the sockets. I'm going to read from the client sockets in chunks of 1024 bytes. And the state sockets is I'm going to read information in chunks of 256 bytes. And then I'm going to decode this to AXI, and I know the positions here. So in the position 21 of the array, I will have the battery information. So very straightforward. This is how I read information from the drone. By the way, I'm going to open the sockets later. Now, how do I send information to the drone? This is the one that you need to be careful. I have a send command that is going to basically use a string to send. We have commands in the PDF that are described. You need to take off, land, move forward, move back, flip, and do these kind of things. And I'm going to use, again, the socket. I need to encode the command in UTF-8, and I am going to do kind of a while response to see if I have something for 5 seconds to control timeout. Again, not the best way to do this, but kind of nice to have it here. And it works. It's kind of nice. The other functions are overloads of the original ones, where I basically check if everything is working. I am reading the information from the drone. I am sending information to the drone. Let's move to the threads. So remember my receive data for one socket and my read state for the other sockets. That has an eternal loop internal. I am going to open those two functions in a new thread. We can do this in the same thread, and we can do this in the main app, but it's going to basically slow everything. So I prefer to do it like this, and it kind of works. And I'm taking a look at the comments here. If you have a question, I will try to answer this online. But hey, I hope it makes sense so far, because we are literally at the end of write a very basic SDK to control the drone. So the last one is, okay, let's write an application, and that's it. So I am going to ask for the battery value. Remember that at the top, let me scroll here in the top. Here it is. So I have here, I am reading the battery value that I know that in the array of states is the item 21. So I have my battery here, and I want to do that. And hey, I am going to send the first command to the drone that needs to be the string command. This is part of the PDF. It took me a while to realize that if you are not in developer mode or whatever, you need to send this. And then I have a read command of battery to do this. And then I'm going to print the battery. that's basically it. Let's run this one. Let's connect to the drone and run this. So I'm still connected. I have here my drone application. This is the 2 files that I have. 5:10 p.m. This is the file that I have. So I can do Python demo.py, and I'm missing my sockets. I missed something. Hey, this is live demos. This is what we like. So I didn't create the sockets. I miss my sockets. So this is the connection to the drone, which is kind of important. So I know the IP of the drone. By the way, this is live. You can just realize that this is live. I know the IP of the drone. I know the ports that we have, and I'm going to open the 2 sockets right now, client and state, to work with this. So now we have it. Let's save it again. Let's go back to, I am still connected. Yes. And let's do CLS, Python demo.py, and welcome to the most boring demo ever. The battery of the drone is 54%. So I hope it's good enough to get to the end of the session. But that's it. That's how we can connect to the drone. Let me do a quick tweak here so you can see that it's working. Let me go here to 20 seconds and time sleep. And when I am reading the drone information, I am going to print this list of values. So what I am going to do here is I am reading the drone info, and I am going to print the drone info. So when I do this, there is a lot of info here. And if I start to move the drone around, I have the drone here and I start to move the drone around, you can see how the info is changing because the drone internally have an accelerator. So the accelerator value is changing. This has the values for the 3 axes, X, Y, and Z. And we also see, I'm going to finish this right now, but we also see here that we have temperature, low and high in Fahrenheit, time of flight, the battery somewhere here in the back, the vector of accelerometer somewhere here. So there is a lot of info that I can access here from the drone. And remember, it literally took me 5 minutes, 10 minutes to write 90 lines of code. And let me go here. It usually, yes, 90 lines of code, and you can access the drone. I'm not going to do anything with the camera. I also have some demos where I access the camera and show the camera, but it's cool to know that if we want to access the camera, we can use OpenCV to access the camera. And the way that basically do this is I use a video capture element in OpenCV. I define that I am going to access the UDP, IP, and the port 11,111 for this. And then I get frame by frame of the drone camera, and I show this here. And let's do Azure. Let's name a window here, Azure Python Day. And in eternal loop, I have basically accessing the frame, showing the frame in an OpenCV window. I do a small resize to have access to basically make it 640, 480 is kind of small enough, and then show the camera. And if I press the letter Q, stop the while and working. So if I'm still connected, yeah, I'm still connected, super cool. Let's do Python camera.py. This is the file that we just created. This is all OpenCV debugging info, and any moment soon, unless I am disconnected, which usually happen at this moment. Yes, this just happened. If we see the ping in the back, it got disconnected. So I need to go here back and stop this one. This is what happened with live demos. So hey, no problem. Let's try to connect again. In the meantime, I will check the comments. Still trying to connect. Working there. When I am connected back, I'm going to launch the camera. Hey, live demos doing the drone. So let me turn on the drone again. Try to connect. Again, sorry for the most boring demo ever, which is showing the battery value, but hey, the camera is a little better. One more time, trying to connect to the drone. Once I have the IP, should be there. There it is. Let's run the camera there. So second story of the day will be right now when the Windows camera started. There it is. So here is my drone. You don't sign up here probably to see 2 Brunos here, but hey, it's kind of nice how in real time I'm accessing the camera, and the response is very good. By the way, there you are. You can wave here or somewhere there. I don't know where you are, in one of the screens. But it works. It's fine. It's nice. And as I said before, I am not oh my God, that angle. I am not going to do flight demos until the end, because usually hit my guitars, the Captain American shield, my crappy cancer sign there. So there is a lot there, but it's super, super easy. A couple of hundreds, not even 200 lines of code. Access the drone, make the drone fly, access the camera, and more. So that's part one. This is what we can do. But how about make the drone fly? Well, how we do this? How we can do this? So basically, I need to send commands to the drone. So I can go here and basically send the command. Hey, copilot is doing amazing. So take off. So this is going to, yes, we have similar code. So we have take off. If I want to do send command, I don't know, forward 50 is going to move 50. So I can send command to the drone. And I know the commands, they are parts of the PDF. So I was thinking, hey, what about this? What about using some GPT models, the one that we have in Azure OpenAI, an example, to generate the code, to generate the stuff that we have. So I am going to use the text models. I'm not going to use Codex. I'm not going to use DALL-E. Codex may work, but I'm going to use the text models in the chat completion scenario. And basically, the first test that I did, it was in ChatGPT. I went to ChatGPT and I said, hey, act as a programmer. Read the following code. And I show here a couple of samples that, hey, this is how you read the battery, how you move forward, take off, flip, do up, down, and then generate code. And it works, but I want to do the same in Azure. I want to go back here to my Azure portal, to my Azure OpenAI service. I want to use a GPT 3.5 Turbo. And using this code, I am going to basically share some reference codes here with a couple of commands. Take off, flip left, move up, move left. I am going to ask the GPT model to generate Python code to take off the drone, move forward, flip right, move down, and land. So once I have this, and I do generate, you know the deal. And by the way, here, there are a couple of configurations and parameters that I work at the beginning that I'm not going to explain right now, like the temperature or top probability. But I have a very decent, very, very decent code. So I ask for takeoff, and I have here takeoff. I have for move forward, and I have the move forward. I ask for flip right, and I have the flip right. And by the way, I didn't even share all of the sample activities. I only share the flip left, I think, or flip forward. I can't remember. But the GPT model, GPT 3.5, it's kind of connect the dots and generate the right code. So at this moment, when I have this, I was starting to think, okay, I have this. I have my GPT on Azure. I have my drone ready to fly here. How could I make it work? So I created, again, let's cancel this. Let me delete these lines of code, because if I sometimes execute this with the takeoff, it's going to make some fun moments. So I have here a super simple application that use internally semantic kernel to basically create a skill to ask the drone to fly. And then I am going to type in the console a set of actions, and it's going to generate the code. And this is the prompt from the skill, which is no surprise. It's literally the same that I use online. So it's the same that we have here. So let me see here. Oh, perfect. So let me see here. I have the drone, so use this Python code that reference code start, my sample code, code end, and the important lines here is generate Python code only to follow these orders. And I have the inputs, which are going to be the orders. So right now, if I go back here to my file, demosign code, let me open this one, and let's copy this file. If I go back to my console, let's minimize this so you have a better light view, minimize some stuff. So let me go to that direction. And I can do Python 05 demos encode. This is going to ask me for the actions for the drone. I have a default that is take off the drone, move forward 25 centimeters. Oh, sorry. Take off the drone, move forward 25 centimeters, flip right, move down 30 and land. And this is the code that was generated. Take off, forward, flip right, down, and land. But remember that we talked that and I don't want to execute this because I don't have this is not the full demo for execute. But remember that we talk about how UDP is not the best communication protocol. If I run this code like this with the drone, it's going to probably pick up the first command, take off, and then forget about the others because it's going to be like this in all one behind the other. So I'm going to go to the skill here and said, okay, you know what? Add a 5 seconds delay between commands because I want to run a command. Then after I run the command, I want to add a delay and then the other, then the other. And when I have this, if I go back here and I run my demo again, we are going to see that, yes, I am going to use the first one, the one that I have. Hey, GPT is super smart enough to say, okay, I'm going to add a time slip between commands, and that's basically it. So that said, I have everything here to make it fly, to make it run, to see if we are going to use it and really work. So this is the moment that let me set up this one here on the right, minimize this. And I have a camera here that I'm going to pop that is going to show the drone. Let me connect to the drone. This is the moment that it takes some time. And let's have some fun. Let's see if it flies. So it's connecting. I have this camera here. Oh, sorry, I don't want to do this like this. This camera here. I can even open my main camera that you're already seeing the main camera. So it's connecting one more time. There it is. I'm connected. So what I am going to do here is I am going to do a Python. This is the 10th. And let me put this in the back. And to have more light here, to have a better view, I have a kind of a professional lights for these kind of things. So there it is. And I hope you see the small drone in the back. You're going to see the drone in 2 cameras. So once I have this, I am going to, it access the battery, action for the drone. I don't want the drone. It's going to use Azure OpenAI to generate the code and execute the code. Yes. So it's kind of flying. Move forward. Don't do a flip. No flips. Okay, down and into land anytime soon. Okay, you didn't, I hope that you didn't hear, but it hit something landing. All of the pieces are together and everything is connected. So this is kind of, I know, it's super fast. If we have 2 hours, we can even go deeper in each one of the steps, but it works and it's nice and it's literally using semantic kernel to use Azure OpenAI to generate the code and to run the code. And to run the code, by the way, I use basically save the code in a file, .py file, and then I use exec of the content of the file. So that's basically it. And I know I went super fast, but let me share with you. This is what we've seen today, super fast. How we can write a SDK of the drone and with the 90, 100 lines, start to interact with the drone. Access to telemetry, access to the camera, and more. And then, hey, how we can even use semantic kernel as a library to create a prompt, to validate a prompt that we have there generating code, and putting everything there all together to make the drone fly. And by the way, everything that we showed today is available in that AKS that basically shows this. I have 20 plus something posts about how you can connect to the drone, how you can access the camera, how you can make it fly, how you can do some object detection using OpenCV and other stuff, how you can connect the drone. And the last ones are around Azure OpenAI. So everything is here. And I think that's basically it. I went super fast, but I want to have time. I see a couple of questions here. So any questions that you
That was
think?
fantastic. I was on mute in the background, just going, yes, when it raised. And I can't believe you said it was a boring presentation. I was the drum roll the whole time. And you did live coding. So just like round of applause. There's some people echoing that in the chat as well. And we can leave the slide up as we answer a few questions so people can visit that QR code and those extra links and resources that you provided. Let's see. Do we have any additional questions? This one's a great one. How many crashes while testing the code?
Hey, I have 3 drones, so as a backup plan. So I hope that the number of drones that I have here give you an idea of how bad this can go. And I think today is the first time they didn't hit the guitar or something else. So
we get a special presentation then, I guess. That's great.
Yeah.
And those dents in that Captain America armor, those were earned by real combat.
Yeah.
Awesome. Let's see if we have any more questions in the chat. It was a really great presentation. We're just getting a bunch of awesomes in the chat as well. So thank you so much for stopping by, sharing all of this knowledge. I'm going to go through and look at your presentations, and maybe I can do a little response to all of your blog posts with a blog post of my own of following it up.
Yes. And hey, to leave a note, basically said to everyone, give it a try. I've been doing the drone, whatever, for a while. And then one day I was running, I think, or walking. I said, hey, Azure OpenAI may do something here. And it literally works. I can start to write a full, make it fly, make it up, translate, generate the code. It's amazing. Ideas are here to basically, it's amazing. And
So
it's
cool.
easy, which I love it.
So cool. You make it look easy. So I'm definitely gonna have to rewatch this presentation. You went fast, but it was really well paced. So again, props to you. Anyway, thank you so much. I really appreciate you being here. It was lovely.
Perfect. Goodbye, everyone.
All right, we are next up on our schedule. Just Pythonistas are nothing if not practical. So I can appreciate a practical AI application. Join the over 9,000 subscribers to our Azure developers YouTube. Let's bring that on screen. Yep. Join the over 9,000 who have subscribed to our Microsoft developers YouTube. And also check out the show notes. We have some really important links on there. So we have a welcome to Python Day. We have a Python Day collection and additional resources. I have them already open because we want you to join the Cloud Skills Challenge. So make sure you do that. And Haley, you have some stuff.
Yeah, I actually wanted to pose a question just to the audience. So I feel like all day we've both been plugging our community stand-ups, which are like the live engagement with the audience for all of the different services. So we don't have one specifically around AI. What kind of topics would people be interested in learning more about AI? Because I know there's so many things that we could cover in that. And I think I'm super interested in learning just Azure AI and all the things you can do with it. Because I've seen Bruno's session, and we have a full 3 more sessions just on Azure AI stuff you can do. I think it's super cool. Is there anything anyone's super interested in seeing, just so I can take notes and maybe launch another YouTube community stand-up on AI? So pop it in the chat. I'm curious to see what people think, and I wanted to put that in there just to get people thinking on that before we move into the next sessions.
Are we going to bring them up on screen? I'm just seeing messages already.
Oh my goodness. People have thoughts. All right.
Well, there we go. Cool.
Cognitive search. Okay, people like cognitive search. I like it. This is super helpful because we want to bring y'all the content that you want. We want to connect with the community and chat and answer your questions. And so we're all in this together, just trying to make the best developer experience possible.
Cool.
But please keep commenting. I'll write all these down and make note of them. Thanks.
Great. Don't forget to check out the Cloud Skills Challenges. We have Discord and Twitter links and the Python Day collection with more resources. And if you want to keep track of all the resources we're sharing, make sure you check out the show notes for the Python Day collection. And you can also check back here for any of these videos on demand after they're all done. We've had some really, really great ones all day. So you can visit that at aka.ms/azuredevelopers/YouTube. And so without further ado, Haley, let's introduce Kyle. Super excited for your presentation.
Awesome. I'm excited to be here. It's tough to follow the cool AI drone example, but I will do my best.
Oh, you have me all ears. I love practical approaches on things. I'm like, just tell me how to use it. So super excited.
Awesome. Well, I'm excited to present.
All right. I'll let you get to it.
Sounds good. And I'll add my slides. There we go. Hey, folks. My name is Kyle Teagarden. I'm a senior product manager here at Microsoft for Azure Cache for Redis specifically. And my presentation today is about getting real practical. We have all heard a lot about AI and the many benefits of AI, but what does that mean in reality? So you've probably seen all the highlights. You've probably used ChatGPT. It is legitimately awesome. AI is going to change the world in one way or another, but there is a lot of hype. Will AI cure cancer within 5 years? Maybe not. What does AI actually mean for you and your applications and your businesses right now? So you may have seen this post. It's a few years old now, about ML is written in Python, AI is written in PowerPoint. There's a little bit of truth to that, right? Like, people talk about these things like they're around the corner, but it's important to actually get down to brass tacks and understand what you can and cannot do with AI and languages like Python today. And so my objective in this presentation is to get down to ground level and understand, all right, if you're going to build an AI-based app, what is your toolkit? Like, what's the stack? What are the Python libraries you should be using? What are the practical steps to make this a reality? And how would you actually go about deploying the application on Azure? So this is meant to be for people that have heard about AI, maybe have some skills with Python and want to understand how to get started. And so the goal of this exercise is to build a movie recommendation app. So I want to be able to input a phrase or a description of a plot or just keywords, and then get an output of a movie recommendation and a score of how closely it matches the input. And if you kind of see this, you're familiar with some of the latest AI stuff. This is a vector similarity search use case. So in terms of theory, it looks kind of like this. So if we go on the conceptual AI side for a second, there's a bunch of different ML models, right? You might be familiar with some of the text generation models and things like ChatGPT, which are available right now on Azure OpenAI Service. But there's models that are kind of a layer beneath that into this concept called embeddings. And the idea here is that you can run text, and in some cases, video or even audio, almost anything, through an ML model called an embedding model. And you get an output that's a vector of basically like an n-dimensional unit vector of various different magnitudes. So you can see an example here. If I put the text spaceships, aliens, and heroes saving America into my embedding model, I'll get this 1,536 dimension output of that many unit vectors with slightly different magnitudes for each of them. And based on the magic of your ML model, that vector output will be different for every different block of text you put in. And we don't really know what each dimension means, right? Like, one way to think of it is if there was just like a two-dimensional vector, then you could have like a vector for spaceships and a vector for America. And a movie like Lincoln would fit very much on the America side, so maybe a large magnitude for the America vector, but a very, very small magnitude for the spaceship vector. Where a movie like Star Trek II, The Wrath of Khan, great movie, would have a pretty high magnitude for the spaceship vector and a very low magnitude for the America vector. Maybe a little bit greater of a magnitude for America than Lincoln would have for spaceships, but pretty low there. a movie like, say, Independence Day, the classic from 1995, I believe, has a little bit of spaceships and also a little bit of America. And so that vector is somewhere in the middle. And what we can do is we can compare the vector for our query about spaceships, aliens, and America with the vector for the plot summaries of different movies and compare the distance between them. And there's a whole bunch of different ways to compare the distance in Euclidean space by using a cosine, which is maybe the most popular, et cetera, et cetera. And so this is like a really interesting and kind of elegant way to compare two bits of text or two bits of media together without having kind of a defined schema around those bits of text or media. And so the challenge here is, all right, we need a way to generate the vectors, we need a way to store the vectors, and we need a way to compare these vectors together. So that takes us to this application. I see some love for Star Trek 2 in the comments, completely agree. I'll also mention, if you have any questions, please put those in the chat at any point during this presentation. I'll try to watch the chat and address them during the presentation, and if I don't, we'll get to them at the end. Okay, so this is kind of our general AI concept. What does this look like in practice? So this is what we're going to try to put together. We're going to take a data set that's from Kaggle, great resource for different ML learning data sets. We're going to ingest that data set into Pandas, which is our beloved Python framework. We're going to use LangChain to tie multiple different services together, which is this really useful integration kind of library for ML applications. And then we're going to use Azure Cache for Redis, specifically our enterprise tier, to be our vector DB. So we're going to store our vectors there and use it to do the searches as well. And then, of course, our good friend Azure OpenAI Service to generate the embeddings. And then the UI and the application itself will run in this framework called Streamlit, which is a way to make these really simple applications all in Python. All right, so let's break this down step by step. The first step is the data set. This should be pretty familiar for folks. I found this great data set on Kaggle that is the descriptions of the plots for 35,000 movies from Wikipedia. So it's a pretty solid data set. We have some good metadata there. Here's the top items in the data set, right? So the movies go all the way back to 1901 and ends in 2017. And this is great for us because we can generate our embeddings on the plot column, and we can use the other data for filtering, which I'll explain a bit later. Step 2 is we will ingest and clean that data. And I will mention that I got the code here up in the PowerPoint slides. I do have a link at the end to a repo with a Jupyter notebook with all this step by step, and also the application I'll be showing at the end as well. So if you've used Pandas before, it's awesome. I refer to it as kind of like Excel and Python, which probably really upsets people that are both Excel power users and also Pandas power users. But it's a great way to organize and structure data in Python. And so this lets us do things like we can filter the number of years, like take only movies from after 1970 or only English-speaking movies. And then we can also clean the data, right? So we want to clean the data both for clarity and for our embeddings model. We don't want to pay more than we have to embed empty spaces or extra periods, that type of thing. All right, so pretty simple to do that in Pandas. And then we set up our embeddings model in Azure OpenAI. So this is as simple as going to Azure OpenAI, just creating an embeddings model. It takes like 5 seconds. And then all you got to do basically is put the information into LangChain. They have an object for OpenAI embeddings. And we just send in our information on our deployment model name, the endpoint, and your connection key, and you're connected. So it's really easy to set up using LangChain as kind of a platform or a layer in between. And then you need a vector database. And if you can see my little title on the screen, I am a product manager on the Azure Cache for Redis team. So if you'll indulge me, I will take a few extra moments to talk about using Redis as your vector database, because this is a really important part of your application. So if you don't know about Redis, it's a very, very popular open source in-memory data store and cache. It's used everywhere. It's really flexible. And we have a managed version of it on Azure. It's called Azure Cache for Redis, which is just taking that goodness of Redis and then adding some more powerful features like active geo-replication and also support for the Redis stack, which includes functionality like vector search. And then we also add some reliability features, right? So if you deploy all this to production, it helps to have automatic failover when you're doing patching and scaling support and financially backed SLAs. And then there's this functionality that's built into Redis. It's part of the Redis search module. I think it's been renamed now to the Redis stack. And it's been around actually for years. It's one of the most mature vector DBs and vector search kind of platforms. And so it offers a pretty rich feature set to index your vectors and also to compare the vectors. So you can use a couple different ways. HNSW stands for, I think it's hierarchical navigatable small worlds, if my memory serves. It's basically an approximate nearest neighbor. So it'll give you the nearest results, but it's not perfectly precise, but you get a little more speed from it. And then also a flat index method, which is more kind of rigorous, but takes a little while longer. So you have a performance precision trade-off. So Redis supports both, which is kind of unique. Most support one or the other. And then 3 different distance metrics for measuring the distance between those vectors. Like I mentioned, cosine, I think, is the most popular at this point. So that's what I used in this demo. And then the really cool thing about Redis is that you can actually do more than just vector comparison. So I mentioned metadata. You can use that metadata and do a lot of pretty rich search queries on top of your vector search, because Redis has all this built-in Redis functionality. And Pamela, to answer your question, the Q is meant to be an eyeglass kind of thing. So it's just an abstract representation of Redis search. Yeah, so it's more than just vector search, right? It's also this kind of rich search with all sorts of functionality around geo search, text search, fuzzy match, pretty much anything you're looking for from a search standpoint is also available in Redis. And then the other really good thing about Redis and using it for vector DBs and vector search is that it has a lot of great integrations. So there's a really rich integration with LangChain, which I'm using in this demo, and is a very popular way to do a lot of these applications. So you get a lot more functionality and documentation with Redis than you might with other vector stores. And also, Redis has been around for almost 15 years at this point. And so there's a lot of examples on how to use Redis and get started, and other libraries and integrations to use Redis for other things. So if you're using Redis as a cache or as a session store, it's easy to also use that to do to store vectors and to search vectors. Cool. All right. So what does it actually look like in Python? Here's an example. We just import a couple libraries from LangChain. We load our data frame in 2 lines of code into a LangChain concept called a document, basically. We set up our URL to our Redis instance running on Azure, or if you're running on-prem, you could still do this on-prem. And then we set up our vector store. We basically just pass in our documents from pandas, pass in the reference to our Azure OpenAI service. We give the name of the index, and we give the link to Redis. And that little block of code will take all of your documents from pandas. It'll take the plot column, which we specified, generate embeddings on all of those by handing them to Azure OpenAI, and then store all of those in Redis in a hash data type. So it literally does all of that for you, basically, which is pretty nifty. And I'll actually show you real quick. Check time. This is called Redis Insights. It's the desktop application for viewing your keys in Redis. And so this is just an example of how this works, right? So for example, here's we're looking at our movie index here. Each of these are an entry in Redis, basically 1 per movie. And you can see the different values, right? So we have the year, we have the Wikipedia page, we have things like directors and actors, origin, and the plot. And then this here is the vector that was generated. It's in bytecode, so it's not human readable. But this was what was generated by Azure OpenAI and then stored in Redis. So you can kind of see what's going on behind the scenes. All right. And then when it comes time to search, that also is pretty straightforward, surprisingly easy. all you do is you call the vector store similarity search function, put your query in, and then you get your answers. And you can ask for as many nearest neighbor results as you would like. So example here, right, if I search for alien spaceships and heroes saving America, it tells me Independence Day is the closest match with a distance of 0.1652. And the really cool thing is, since Redis has all this rich search functionality, you also can filter on things. So in this case, we have metadata on genre, so we can filter based on the genre comedy. And in this case, you see that we get the result Remote Control, which is a movie from the 1980s that I have never seen, but is, I guess, a comedy that involves like aliens coming to America. So it like triggered on some of those words. And you'll see that it's still pretty close, like it's not that far away, but it's a little further away than Independence Day is. And that's because that vector distance is just a little bit further, right? Some of those vectors don't align quite as well. Okay, so this is what that looks like. To show you what this looks like in practice, let me pull up Jupyter Notebook. And again, this is in a repo. There's a link at the end of the slide, so you're welcome to try all this out yourself. It's all kind of set up. And you can see this is exactly what we did. So, you know, we're getting our CSV, uploading that into pandas. We have our data here. We're cleaning it to only take more recent movies. More cleaning of the data. We can generate the number of tokens to calculate the cost. So in this case, we're running at about 7 million tokens. And I think, I forget the latest pricing, but I think that's about 50 cents to generate all of these embeddings. Loading it into LangChain, we have our Redis instance. That's actually just kind of for testing. You know, here we have our embeddings that are being set up, our Redis instance that's being set up, and then this will load our embeddings. And then if we want to like see what this looks like, we can just run this, right? So running that query, get our title, Independence Day, and distance. I can change this to whatever, right? I can say like a cute movie about dogs and kids playing basketball. And we run this and we get a movie all in good taste. Not familiar with that movie. Or like, for instance, cartoon characters playing basketball against monsters with NBA players. It's a pretty specific vector, and we get Space Jam as our output. So this is kind of fundamentals of how all this stuff works, like in real world, and it really isn't that crazy. It's not that many lines of code to get some pretty powerful results from this, because there are existing Python libraries that abstract a lot of the details under the scenes. All right, so let me jump back to the slides. All right, so that gives us kind of the core of this application and how this all works. The next step is to add a UI. How do we make this like a real application and not just in the command line? And I stumbled upon this really cool framework called Streamlit, which is all in Python. And it's a really easy way to create some pretty rich user experiences without having to learn a bunch of JavaScript or React or anything like that. So the code over on the right, that literally creates the experience that you see on the left. Right, it's really straightforward, all in Python, easy to get started. So it's a great way to do testing and prototypes of an application, especially machine learning applications. I think the caveats here are that there's like a pretty good selection of different UI elements you can use, but there's not a lot of customization you can use. So maybe not the best for a production application, but a great way to test things out without having to have a ton of front-end knowledge. Okay, so we have all this stuff. We have our data set. We've got everything in. We're using LangChain to put everything together. We have our UI with Streamlit. We have our application set up. The next step is just to deploy that to Azure, right? So Azure OpenAI and Azure Cache Redis already running in Azure. That's easy. And then all we got to do is take the middle piece, throw that into a container, and then deploy that container to Azure Container Apps. And so that's exactly what I've done. And you can see that if I go to my web browser. Here you go. So I got all the different components here. I got Redis, I got my OpenAI service, and then I have this container app that's set up. And the really cool thing here is that there's a command called Azure Container App up that you can use, and that'll basically take your Docker file and do all the steps required to deploy that into a Azure Container App that's ready to go. And so it literally is a one-line command to get everything going. And if I go there, you can see that it's all running, no problem. I can go to the application. And this is actually live on the public internet. So if you want to give this a try, feel free to go ahead and do that. And I can do my search. What was my specific query? It was, I'll copy and paste it. Yeah, spaceships, aliens, and heroes saving America. So I can do this, boom, hit enter, and it gives me Independence Day, and it gives me the score. This is actually an inverse score in this case. This is vector similarity rather than vector distance, but same thing. And then it gives us other examples here too. And I can actually go all the way up to the 10 nearest neighbors, search for that, and we get a whole bunch of different options here. So we get things like Exogenesis by James Cameron and The Flying Machine, so on and so forth. And if people have any question or any suggestions on queries in the chat, I'm happy to try those out too. It might be the same as AZD up. I actually don't know, Sarah. That's a good question. It wouldn't surprise me if there's an AZD command that makes kind of abstracts all that. And then you can see here too, talks about additional filters. That all can be done through Streamlit as well. So I can filter the years. So if I, like, for instance, let's do a test. If I limit this to just 1977, we might see something like Star Wars come up. Let's see. I get Starship Invasions in 1977 is the closest example there. Yeah, there's a lot of weird movies here. Yeah, and Star Wars shows up there. And you can see that the more that I filter these results, the lower the similarity score is, right? So like if the best score from all filters from all these years was like a 0.84 similarity, and something from, if I limit it just to 1 year, we go down to 0.81. I can limit this further, right? If I say like drama, for instance, it's kind of a weird query. The score is going down further. And so some of these movies, they probably have nothing to do with aliens or spaceships, but maybe the vector is triggering more on America than the other ones. So just an example of kind of the fun things you can do with this. Okay, so this application, like I said, is live. Feel free to go ahead and give it a try. All right, and that was the demo. So just going over a few of the use cases, I said this would be a practical AI application. I'm hoping the instructions are very practical. Obviously, I'm guessing most people on this event probably don't have a pressing need for a movie recommendation or a movie similarity application. But you can see that there's a lot of applications that are similar to this that could be useful. So visual search is a really great example where you don't have to just use text for your embeddings models. You can use, like I said, audio or pictures. The Azure OpenAI embeddings model is just for text right now, but there's a whole bunch of embeddings models from different, different companies or vendors. Like you can use Llama or Hugging Face. And LangChain makes it really easy to plug and play different models in. So if you want to swap your model out, you just swap it out in LangChain and everything else should work as expected. Semantic search is a really good example here. And so you see a lot of companies that we talk to that they, for example, have like a really complicated internal document for their like healthcare plan. We have that at Microsoft. It's 200 pages. And so I did a demo where you throw that into this same type of application and you can ask a question and it'll find you the paragraph or chunk of information in the complicated document that's most relevant. And you even can use the different text models from Azure OpenAI to summarize that data and make it even more convenient. So it's kind of like Q&A bot style application on custom data sources is another great application here. And then the last is just recommendation, right? If even if it's not a consumer application, it's still helpful to have searches to recommend products or applications or new features. And this is a great way to do that using AI. Awesome. In terms of next steps, like I mentioned, that repo at the top has the code from the application and also the Jupyter notebook. So if you want to get started, that's a great way to give things a try and get going. There's a couple other examples linked there of other similar applications that are good to start with. And we have a blog post that talks about this in some more detail too. So all ways to get started, learn more about vectors, embeddings, and using Redis as a vector data store. So I think we have a few minutes left. I'd be happy to take any questions you all would have.
That's awesome.
Does that work, Haley?
Yeah, Pamela just added another question here. How would you compare Redis vector search to Azure Cognitive Search, which now has vector support, of course?
Yeah, no, both awesome services, right? All part of the same Azure family. I think, to be totally transparent, the advantages and disadvantages of Redis, I should say, first of all, a lot of the same features, right? So a lot of it kind of comes down to what are you already using? What are you familiar with? There's not like a clear winner or not here. I think the advantages of Redis is that it does support flat indexing, which I don't think Cognitive Search does yet. And it's GA. It's just been around longer. And so there are a few things that maybe are a little more battle hardened, or there's like more integration support in some ways for Redis than there might be for Cognitive Search, just because it's been around a bit longer. I think the other advantage is if you're already using Redis in an application, it's easier to get started with Redis because you already have it there. It's not hard to add vector capabilities to it. I think the disadvantage of Redis is right now it's only supported on our enterprise tier, and so the price point to get started, if you're not already using Redis, might be a little bit higher. And I think Cognitive Search has some really awesome entry points, and maybe even a free tier you can use to get started. So both awesome things worth checking out. I think a lot of it comes down to kind of your personal preference.
And of course, we got to call out that Azure Cache for Redis also has a community stand-up. I know I've been plugging these all day. That's the 4th Tuesday of every month. And so I think the next one's on the 26th of September. So you can learn lots more. I'm putting the YouTube link again below here. And so subscribe to get notifications as these community stand-ups are coming up. And so, yeah, Kyle did a great intro into what is Azure Cache for Redis. And you can learn plenty more about that on the 26th, and then every 4th Tuesday of each month after that. But yeah, this was such a great session. I know when I graduated in, I think, 2018 with my CS degree, I didn't learn a lot about AI. I didn't take many classes on AI. So just thinking about all of this new AI stuff coming out, and everyone, it's the craze. It's the newest thing. It's a little daunting, and I was a little worried. I didn't know if I was going to be able to get on board, but hearing you talk about it, hearing all of these sessions, I realized it's completely in our grasp, but we have all the tools to learn it, to make it awesome. Yeah, I'm ready to get started and get learning. This has been super cool to hear about this. So thank you so much, Kyle.
Absolutely. And if there's one thing people take away is that it's a lot easier to get started than you might expect.
Yep. Yeah, on that, please do the cloud skills challenges. I'll plug that again because there's an entire challenge on AI and machine learning. And so if you want to figure out how to get started and what to do, it's laid out there for you. It's an easy stepping stone to get started. So always going to keep putting that link down there to get started. And there's also cloud skills challenges for if you're a beginner and you just want to learn Python. So any level you're at, come learn how to develop on Python, come learn how to do AI. And it's all right there laid out for you. We love to give action items so people can convert this into their real world scenarios. But thank you so much, Kyle.
Awesome. Thank you all.
Yeah. I also got a lot of great movie recommendations out of that. And a lot of them I hadn't seen. So yeah, in addition to learning AI, I've learned a lot of movies that I need to start watching.
If you haven't seen Independence Day, it is a true classic. Although it's not as good of a movie as Star Trek 2. So, there you go.
But I'll definitely look this up. So thanks so much, Kyle.
Perfect. Thank you all.
Yeah. Bringing on our next session, we're going to be talking about Copilot to continue the topic of AI. So I'd love to pull up Kinfi here. How are you? You are on mute. I am not able to unmute you, but if you look at your little camera down below there.
Hello. Good afternoon, good morning, good evening. Yeah.
Yeah, welcome.
Let me share the screen. Yeah.
Absolutely.
Okay. Okay. I think this time is very, very early to me, but I think it's the word time. Good morning, good afternoon, good evening. My name is Kim Fei Lo. This is my session is to let you to know how to create your first Copilot solutions. Maybe I need to introduce myself more. I'm Microsoft Senior Cloud Advocate. I work in next generation experiments team. I focus AI and data. This time, I think this is the Python day. Many Microsoft FTE to introduce different scenario in Python. This time, I will introduce some AI scenario. Well, the first thing, welcome, because I think this is my first time to use English to talk about Python topics. So I think if I will speak slowly, because my English is not well. The first step, I will introduce Copilot step. The word enter the new area because large language model changed the world, just like GPT-3, GPT 3.5, GPT-4. We can use that to create more contents. Not just before. No GPT. We only build model. Only focus one thing. Just like you build computer vision, it only focus some image classification or some object detections. But this time, we can use GPT to do more. Not only focus understanding NLP, it can create NLP. So it's amazing. It changed the world. Many people or an enterprise want to use GPT to create new applications. It will give different customer, different people to feel new experiments. Just like that, in the last session, we can set a movie and to find many things. We can summarize different contents for the movie. I think it's good scenario. But the the new scenario is you can use different document to ask and Q&A solutions. I think many enterprise want to use their data into large language model. And this time, enterprise face many transformations. The first step is transformations is digital, but now it's intelligence. I think enterprise is very more things to think. What I need to do in the enterprise solutions, because they need to face different things. Just like that, large language model, because they can choose GPT and many more different the same model as GPT in Hugging Face. I think some people say, if I use OpenAI, the enterprise data, how to let the enterprise data is the security things, but yet they can use Hugging Face to tighten their models to focus their enterprise data. Another is the prompt. Many people to know, prompt is good. Enterprise prompt can help the enterprise and company to focus their business scenario, just like their data, their files, their behaviors. I think prompt library is important to the enterprise. Another is the Copilot application. Just like many people say, Microsoft has cool Copilot solutions, just like Office Copilot, just like some GPT plugin is cool. So, enterprise maybe face choose model, choose how to control their enterprise prompt and Copilot applications. I think if you are enterprise developer, maybe some suggestion is you need to think your enterprise data and enterprise solution, which is important. Yeah, but I think these three things is important because you need to focus from end and back end and the middleware in your solutions. Copilot stack open the door in Microsoft View. We talk about Copilot stack because Copilot stack, it can tell you how to connect to your back end, including some AI infra and foundation model. Another is the front end, because the plugin and the applications. You can see that this diagram. You can think, oh, this is very easy to talk about how to combine AI orchestrations connect the front end and back end. Copilot stack is very easy to let everyone know how to create your applications with a large language model and prompt. So I think Copilot stack open the door to tell you, you can create the Copilot applications. RAG is the more people to choose solutions because it's very easy. Some people say, AI infra applies some foundation model and fighter model and BYO model, bring your own model in the enterprise. I think it's the same. But RAG model give you the suggestion is the vector DB plus web API and plus the plugin. This is the very easy solutions to do this because you can choose different vector DB. You can use test embedding into vector DB and create some web API and Azure functions in there. Another is the plugin to a plugin here. So we can create RAG together. Maybe some people say, we need to Python the model to finish the enterprise application. But you know that if you choose Python, it's very, very more expensive because you need to depending more GPU and something. So RAG can give you embedding and your data is very easy and save money. I think some people will say how to let RAG to landing in the enterprise application because you create many things. You can watch many videos and something just like you can see 5 minutes to create RAG solutions in YouTube. But this time I will tell you how to create your first Copilot. Many people to choose a LangChain, but I think semantic kernel is the good things to help you to use a Copilot stack to finish some Copilot applications. I love to use semantic kernel. Why? Because semantic kernel can support different languages, not just Python. You can use .NET, you can Java to use semantic kernel. The another thing is it can help you to control or manage your prompt. Just another is it has a very important concept, connector and plugin and memory, different key concept. But I think connector is very important because you can use connector to connect OpenAI and some vector DB. Another is the connect different models. Another is you can use planner to set your command to finish something. So I think semantic kernel is very good. Another is if you use different things, semantic kernel to help you not only focus core memory or query plan, it can connect graph API and functions and native functions. I think semantic kernel is very easy in Python. I will show you how to use semantic kernel in Python. This is the first sample is the Python how to call a function. The first thing you can import a semantic kernel library. Another is create the semantic kernel, and import the library to check completion because I use the GPT 3.5. Another is the set environment. It's very easy. Like in semantic kernel, we can set prompt is the skill. The skill is how you to something is you can compile the skill here in the skill folder. Another is the you can use the skill to set a variable and set the function, or just like here I set a prompt here and set some configuration. You can use different language, just like here I use Chinese here to write prompt, and then it will run. It can give you the answer. You can use very small or like I can read the content to finish the semantic kernel. Another is the planner. Planner is the very special things in semantic kernel. It can help you to separate different skill. Just like here, I will send a planner here, check the weather in Guangzhou and translate into English, Chinese, and generate Jason tips based on the results and write item as travel weather with my email. So a semantic kernel plan, it will help you to separate a different skill. Just like here, it can include a weather function and translate and tips and weather mail. Four skills here. It can it is focus 1, 2, 3 translate and some tips and email skill and the weather skill. Oh yeah, so it can run step by step in the skill. I think semantic kernel will help you to do more. So, semantic kernel is very good to Python user. If you are Python, you try LangChain, but I think I suggest you to choose semantic kernel. Another is okay. We talk copilot and semantic kernel, and now I will tell you how to create your first copilot in enterprise solutions. The first thing is many enterprise want to large language model to understand the enterprise data. The enterprise data is more because you can use different data, just like structured data and unstructured data. In the enterprise, they only choose many SQL version, just like SQL Server, MySQL, Oracle, and PostgreSQL. Another is there has some files, some documents, some images. So we need to focus, connect different data. But this time, how to combine the different data resource in the in a platform? I think Microsoft Fabric will give you the good solutions because it can give you the unified solutions to combine all data in one lake. End-to-end analyze platform that brings the data together, all the data and analyze tools that organize need to go from the data lake to the business user. You can choose different roles to finish some data jobs. Just like here, you can if you are a data science, if you are a data engineer, you can work in the same platform to compile data to finish the solutions. So I create the solutions here. If you are a data engineer, you can combine your unstructured data or structured data together in the Microsoft Fabric. Another is if you are a data scientist, you can use Lobo to finish the Fabric Lakehouse, to import Fabric Lakehouse to embedding to the different vector database. Here I choose the Azure Cognitive Search to be my vector database, and use Azure OpenAI Service and semantic kernel to finish the jobs. Let's see how to do this. The first thing is you need to have Microsoft Fabric. I think Microsoft Fabric is in the preview stage, but this time you can use Microsoft Fabric very easy. It's free to trial. Another is you need to import your data to the Lakehouse. Just like here, I import the Azure Block Storage in the data Lakehouse. And another is this is the docs file from my Azure Block Storage. But this time you can see I use Microsoft Fabric platform in the document to the document, and how to analyze the document. Another is I choose data scientists to finish some embedding jobs. Just like here, because data scientists you can use the Jupyter Notebook. Just like here, I install a semantic kernel and use the Azure Search document preview version. Another is you can see the import the library. Another is the ChatGPT and embedding, and use the semantic kernel to chat service and test embedding. Another is the register memory storage. This here is Azure Cognitive Search and some your Azure Cognitive Search endpoint and key. Another is I choose the Lakehouse file folder. Another is to just like you can use the semantic kernel to finish the test embedding. This is the trial. I asked the when you finish, you can ask the semantic kernel to trial to finish the QA prototype. It can give you the answer. I think I choose the Microsoft Fabric documents to finish some RAG retrieve to embedding and the data to the data vector DB. Yeah. And then some people will say, oh, Kim-Fei, how to compile the Lakehouse? You can choose the data engineering to finish that. Just like here, I choose the Lakehouse to connect my Azure Block Storage. Here, you can see the block storage you can choose different block storage resource. Here I choose the block storage and some skill because a semantic kernel will read this skill. So I think some enterprise prompt library can save in the skill. So you can combine the skill and unstructured data and some database together to let semantic kernel to finish the enterprise data embedding. When you finish embedding your data, you will think that I disabled it of the IH application. Just like you can use the enterprise to embedding here, you can use Azure OpenAI and Azure OpenAI Service and cognitive search and semantic kernel. And in the back end, maybe you need to compile it to the Azure Functions. And the front end, we can use Power Virtual Agent to help me to finish the front end solutions. This scenario, maybe we can tell you how to use the enterprise data and your Azure cloud native solutions and low-code solutions together. I think we can. I will show you here. The first thing you can see, I use the Power Virtual Agent to finish something. Here is include some Power Virtual Agent flow template. It can set it can call the Azure function here. In your Azure function, you can set some fabric functions combined together and set some question. It's very easy to create your chatbot solutions finish the copilot applications. Another is some people say, I can use different scenario, but at this time, if you create your first copilot solution, I suggest you to trial this Power Virtual Agent because it's very easy to create. To let you to feel copilot apps is very easy to create that. Yeah. Some people will say, oh, Kim-Fei, do you know give you more because semantic kernel and LangChain, many people to comparison or some Python and some developer only focus how to improve their code or their efficiency. But this time I found for commercial logics, we have a fixed business problem. Just like here, we can use data and prompt and finish knowledge. But just like if you are asked HR document or some documents, the prompt is the same. Not will change, but the format, the prompt is not stable because you need to give command to different people. From different people, they can express different languages and different things here. But for the business scenario, the prompt is feasible. So, maybe we can choose prompt flow on AI Studio is better choice because you can let you to finish some business prompt to finish something. Just like here, stand flow and chat flow and emulation flow. This is the three level of flows here. So you can create the flow in the AI Studio. Just like here, we can see the flow is here. If you are a Python developer or different language developer, you can see we can create the prompt flow in your AI Studio. You can set the prompt. You can set the input and output things. Another is very easy to compile embedding because here I choose connect my Azure OpenAI. So this is the large language model. Another is the lookup. Where's the lookup? Lookup is the vector DB. Vector DB is very easy to set here in the prompt flow. You can choose different things: embedding, translator, and fuzzy and language model and vector DB lookup. Here is because I have embedding data in the Microsoft Fabric notebooks, and here I need to look up the vector DB. So I will set the vector DB here and the path and some method. Another is you can write the Python here to finish the search. So I set this flow. Another is it's very easy to deploy in the endpoint. You can choose. You can see I have deployed the endpoint here. You can test the endpoint and consumption. You can create this endpoint to use Python and C# and R. It's very easy to call the endpoint here. So you can embedding, and you can compile you can call the API in Python is very easy. So I think Pronto is another choice in your solutions. So this time we create more Azure function, create your first copilot of applications in different things. You can use a semantic kernel. You can use Microsoft Fabric. You can use prompt flow together. So the fee rates is different, but I think you can choose the best way you feel is the good scenario is best for you. So this time I think I finish all the sessions. Thank you very much. Another is if you have some question, you can give me the email and GitHub here. Thank you. Hello. Hello.
Hello. Yes, I was talking. So sorry. Thank you so much, Kim Fei. This was an amazing chat. And I'm looking into the chat to see if we have any open questions. But we're getting a lot of people saying thank you for the presentation. Pamela Fox says there are so many tools I need to try: SK, Prompt Flow, and Fabric. I thought that too. And then at the end you said there are 3 ways that we can accomplish this same approach. I'm really like taken aback at all of the options and the way that really I'm excited about Microsoft Fabric, that we can jump into these things. So thank you so much. And let's see, we also have another comment from Chris. This is really helpful. I was excited about Fabric when it was announced. Okay, great, me too. But I hadn't considered how it could participate in these AI scenarios. Not quite a question, but do you have any responses to some of these like really exciting messages we're getting?
Yeah. But I think this scenario is Microsoft Fabric help you to let your data binding together. Not you because sorry, my English is not well. Because vector DB you need to combine different data. Just like here, I combine unstructured files. But another is you need some just like financial scenario. You need to combine different resources, data resource. So we can use Fabric to give us the unified data resource to embedding vector DB. So I think Microsoft Fabric give you to unify the data together. Yeah.
Exactly. That's exciting. Yay. Oh, and some more. Thanks. Great talk. Awesome. It sounds like we all are really excited to have you speak with us today. You did an excellent job. I appreciate that. And yeah, so look forward to hearing from you more and following all of your work presenting on this topic. Thanks.
Thanks. Bye.
Bye. All right, we are moving through the day. We've been knee deep in our AI chats today. We have vector search, Cosmos DB, cognitive search, and OpenAI. And I know I'm going to learn a lot again in this session. As we discussed previously in I think Pamela mentioned it in her previous presentation with Anthony earlier. We talked a little bit about vector search, but I'm really excited about this approach. If you want to go back to see any of these previous videos, if you had run out, for example, it's been a long day full of content. You can check in to see to any of these talks at this link at aka.ms/azuredevelopers/YouTube right here. And you'll be able to see the full list of all of the great talks we've had today. Let's bring Chris on screen. We'll get to say hi to Chris. Hello.
Hey, how are you?
Great. Thanks for joining us. So what are we going to be talking about today? I know it's going to be really different from the previous conversations that we've had. What are we getting into?
Yeah, so we're going to talk about vector search
in
Azure with Cosmos DB and a few of its friends, OpenAI, and Azure Cognitive Search.
Awesome.
There's 3 ways to do this in Cosmos DB, and I'm just going to talk about one of the ways, but all 3 are in the GitHub repo that is referenced in the presentation.
Oh, I'm excited to dive in. I'll get off the screen and let you do your magic.
Oh, nice. All right, so I can see the slides. So so hey everybody, I'm honored to be here. I'd like to just talk to you about vector search and Cosmos DB, and just a brief confession. I actually knew nothing about the subject maybe 3 months ago, right? So this has been a self-education project, and I think it's super pertinent, and so I'm glad to share what I've learned with you. Nice. All right, so let's talk about the outline of the presentation. So we're going to talk about vector search in Azure with Azure OpenAI, Cosmos DB NoSQL API, Azure Cognitive Search, and I love this data set. So there's a fellow named Sean Layman, who's I believe a sports writer, but he's created this epic data set. He calls it a database, but it's a beautiful set of CSV files, essentially the history of baseball. So I use that for a lot of my demos. So we're going to explore baseball statistics and searching players. And so we're going to talk, so the outline of the presentation is number 1 is just concepts, amazingly simple concepts, very few. We're going to talk about the business use case for, what it is I've implemented here, and then talk about the actual implementation. Just a little bit about me. So you might notice some gray hair. I've been around a long time. I've been in this field for many more years than I like to say. So it took me it's Python day, right? So I started way back in COBOL, the Smalltalk, Java, Node, et cetera, et cetera. It took me about 25 or 30 years to find Python. It's become my primary language. I find I can do virtually anything in it. For folks who maybe aren't using Python or curious about it, I really encourage you to take a look at Python, reach out to any of the speakers, including myself. I'd love to help you. Likewise, I've worked with many databases, hierarchical databases way back when, a whole bunch of relational databases. A really serendipitous thing happened to my career in 2009 when I started to use MongoDB on an application. It turned out to be 50 times faster for the particular use case that we otherwise use MySQL with. And so I was kind of sold at that point. So I've been very passionate about NoSQL since. Again, this presentation is based on this repo right here. So maybe take a screenshot of that. And I've authored a few small PyPy packages. Yeah, so my point here is, and maybe especially for the younger folks, is that there's a tremendous amount of change here in this field. So please keep up with it. It's been a great ride for me. I absolutely love it, learning new things all the time, and including Python. All right, let's get on with it. So concepts. So amazingly few concepts to talk about. So vector search, right? So what exactly is a vector, you might ask? So a vector is a one-dimensional array of scalar values, meaning they're primitive values. For the Python folks, you can think of them as a NumPy array of floats, of Python floats. So that's simply what a vector is, just a one-dimensional array, in this case, of floats. So vectorization is the process of taking text data. Sorry for the shouting with my red font, bold. But that's the essential thing to understand, is that when you create a vector, you're passing in text data. You're not passing in numeric data, maybe like machine learning with features and columns. You're passing in text data to the OpenAI SDK. Now, the OpenAI SDK calls vectors embeddings, the exact same concept, just a different word for it. So basically, you pass in text data to OpenAI, and you get back embeddings, which again is an array of floats. Yeah, the OpenAI SDK is super simple to use. I'm going to show surprisingly little code in this presentation, but you can do a lot with one line of Python code, and so I'll show you that shortly. What exactly are embeddings anyway? So embeddings measure the relatedness of text strings, right? So we're in this baseball example, we're going to pass in a string for one player, we're going to pass in a string for another player, and via vector search, we're going to compare the players to see how close they are. Embeddings are information dense, but are computationally efficient. I will say when you print out a vector, you might at first be horrified at how large and verbose it is. But again, you have to think that that's the printed version. In memory, right? A number of floats. So in memory, it's going to be much more efficient than what you might think. All right. So the next concept is, okay, great. That's a vector. What is vector search? So a vector search is simply searching a database using vectors, right? So search engines now are optimized for vector searching. In the case of Azure Cognitive Search that I'm going to be talking about, they can do traditional searching, but also it can do vector search. One thing that's super interesting about vector search is that the parameters you pass in to the search is a vector itself, right? So you're gonna pass in a vector to the search engine, and the search engine is going to give you results. In this case, Azure Cognitive Search is going to give us JSON documents with the search results. So the next thing to cover is, okay, great. What exactly does a vector look like? So in the case of the OpenAI embeddings, we're going to get back an array of 1,536 floats, all in the range from -1 to +1. This is some of the magic that OpenAI does. This is an array of 3 floats, ... and it ends with 3 floats. So just imagine this is 1,536 floats. So you might think that it's very verbose, but it's actually an extremely efficient data structure. These vectors or embeddings, and it's compared to like text, like processing text in a search engine versus processing vector. There's like orders of magnitude more efficiency with vectors as opposed to processing raw text. Okay, so that's great. So you have search engines, vector search engines, so what exactly can you do with them? So you can essentially do any search case, any use case that you're currently doing with search. So you can handle images, documents, text data. I'm going to show you the way how I crafted numeric data into text. I'll cover that shortly. We can handle searching for baseball players. Now, I will say, in my opinion, vector search is great. You're going to get some great pertinent search results, but sometimes you just want to do a simple search, and so traditional search engines, can be best for some use cases, and vector search can be good for other use cases. Now, the beautiful thing is Azure Cognitive Search offers both. Right? You can do vector search or traditional search. Now, okay, so you're probably saying, okay, great. Where does OpenAI come into this? Chris, you're talking about Cosmos and cognitive search, but where does OpenAI come into this? So OpenAI is used to generate the embeddings, right? So we're going to pass in the text value, and we're going to get back embeddings from the OpenAI service. Now, you're probably familiar with some of the models in OpenAI. You know, ChatGPT, right? Who on the planet at this point hasn't heard of ChatGPT? DALL-E, you know, for image generation. But maybe lesser known are some other models, such as text-embedding-Ada 002. So that is the OpenAI model that we use to generate these embeddings. And I'll show you some code about that shortly. All right, so that's all the concepts we need to cover: vectors, vectorization, vector search. Business use case. Let's talk about that. So again, the domain for this data is baseball data. And you know, I kind of asked the question. Certain traditional search engines are great for answering things like, okay, great, who hits home runs at a similar rate as Hank Aaron, you know, a great slugger, Major League Baseball Hall of Famer. Who steals bases at a similar rate as Ricky Henderson? You know, who has an earned run average as Ron Guidry? I mean, you can ask kind of relatively simple questions, right, with a few parameters. But, you know, the business use case I'm trying to satisfy is that who has similar overall performance profile as player X? You know, given the full breadth of their baseball statistics. And let me apologize here for folks that aren't familiar with baseball, especially not in the U.S. But the game of baseball is loaded with statistics. There are so many statistics, and they've been captured since 1890. So it's a very dense statistical domain. But nonetheless, baseball players can be measured by many statistics. And so what I'm striving to do is take those many statistics for a player and bundle them into something that OpenAI can create an embedding on. I'll get to that shortly. Yeah, I've found that the search results, you'll find you're going to get really subtle and great search results. You're going to get some search results that you didn't expect. So I was searching through this and I was getting baseball players back, and it's like, oh yeah, I didn't think about this player, but man, that's a great result, and that, you know, that player does meet that criteria. All right, let's talk about one of my favorite players of all time, Ricky Henderson. This fellow here, he is in the Baseball Hall of Fame. I admiringly call him a statistical unicorn, in that he is an utter rare combination of speed and power, as well as some other things. He's the all-time Major League Baseball leader in terms of stolen bases, by far. I mean, nobody is even close. Yet he also hit a lot of home runs. He hit a lot of triples. He scored a lot of runs. He's a run-scoring machine. He's a left-hander. He played left field. So the question I'm asking in this demo is, okay, who is like Ricky? Who is like Ricky Henderson? You know, the full breadth of their statistics. Who is like Ricky? Now, you know, all these vectors for all the players are loaded into into Cosmos, and therefore cognitive search. So you can search on any player, right? So I didn't build this around one player. I'm just using Ricky Henderson as an example. All right, so sorry for the busy slide, but you can, so basically you can try to use simplistic measures to try to find players like Ricky Henderson. So again, sorry for the eye chart, but I essentially loaded this data to a Cosmos DB Postgres database, and therefore I can query it in a relational way just for ad hoc queries. So this particular query is querying for players who've hit at least 100 home runs, stole 500 bases, and have a stolen base percentage success of 80%. Now, you know, so it yields Ricky Henderson, Ty Cobb, Tim Raines. You know, not bad. However, you know, this search is only on 3 dimensions, right? You know, the baseball data, you know, the player might have 20, 30, 40 different attributes. You know, this particular query is just on 3, right? So it's going to have a bias towards those 3 attributes. What I'm looking for, and what you might look for in vector search is, hey, just tell me who's like Ricky Henderson, right? As simple as that. And the nice thing is you don't even have to construct the query, right? So here, the SQL, for example, so this is representative of your search engine. So you have, the burden is on you to construct this query. With vector search, you essentially just pass in a vector, right? And say, okay, match that vector. It's really quite a different way to do things. All right, so let's talk about the implementation. In the repo, as I said up front, there's 3 different implementations of vector search with Cosmos DB. I'll just call them out first. So we have Cosmos DB Mongo vCore API that offers in-database vector search. I'll slide to the bottom. We also have Cosmos DB Postgres API, which is obviously distributed Postgres database. It offers vector search via the PG vector extension. But what I'm going to talk to today about is vector search with Cosmos DB, cognitive search, and this combination. So again, in the repo, there's 3 different ways to do vector search. I'm just talking about this middle path here today. Now, the process is not shown is that I started with the CSV files from the Sean Lehman database. I wrangled them with Python into, in the repo, there's a file called documents.json with 18,000-ish players. And so what you do with, what you can opt to do with your OpenAI subscription is run this vectorization program. So it reads this input, for each document of the 18,000-ish, it will compute the vector, invoke OpenAI to get the vectors. And then at the end of that process, it writes out this documents with embeddings JSON file. Then there's 3 different database loader programs that load each of these databases. So that in a nutshell is the architecture of what I'm showing today. So let's go forward. All right, so let's go back. So yeah, that's the architecture. So let's dive in. You're probably curious, like, okay, great, but what does this data look like, Chris? So let's take a look. So I'm going to have 4 slides in a row here of what this JSON data looks like. Doing a time check. I think I'm on time. Here's the top of the baseball player document for Ricky Henderson. Birth year and first name, last name. He was 5'10", 180 pounds. He bats left, bats right, throws left, et cetera, et cetera. Nothing spectacular here. His batting statistics from in the database, there's a batting CSV file. So his batting statistics got merged in. And this is where you might see that indeed he is a statistical unicorn. Stole 1,406 bases, all-time leader in baseball. Yet he hit 297 home runs, which is just an astounding number. He was caught stealing 335 times, so he was successful over 80% of the times. He was a run-scoring machine. I'll talk about that next. So anyway, this is part 2 of the document. Part 3 is where I've done some machine learning in my past, and as a machine learning data engineer, one creates features, right, in your data. You might start with some raw data, but you need to kind of wrangle or craft that data into features, numeric columns that are normalized with normalized values between like 0 and 1 to pass to the machine learning algorithm. So it was my instinct to do this. And actually my first attempt was simply to use numeric values, and the search results were less than I expected. But nonetheless, I did these calculations, right? Given the raw data from the previous documents, like he scored at a rate of like every 5th at bat, he scored a run. So that's basically, he's a run scoring machine. He hit a pretty high home run percentage. Stolen base percentage was pretty high. So that's kind of like the calculated information for this baseball player. So again, at the bottom, I posed the question, hey, this is starting to look like machine learning, but is this the right approach? I personally concluded no. All right, so this is the end of the baseball player document for Ricky Henderson. So you'll see that I've included the embeddings, right? So this is the output from the OpenAI call, right, to get the embeddings. Now the question is, what value do we pass in to OpenAI to get the embeddings, right? Do we just pass in, Fielder 1979? I'm just looking at these previous attributes. Do we pass in, 3081, 10961, et cetera? Do we just pass in all those values as text and hope that it'll produce the right results? And I actually concluded no, right? So instead, I created this what I'm calling an embedding string. I'm creating this string value that I'm using to pass to OpenAI. So here's a little bit more detail on the embedding string. So if you've done machine learning, you're probably familiar with like binning values, like t-shirts. Like for example, if your chest is between 38 and 40, you're a medium, and at 40 to 42, you're a large, etc. So those are the bins. Given these numeric values, those are the bins. So I took that same approach. So instead of passing into the text, Ricky Henderson's batting average was 0.2787, blah blah blah. I instead crafted this string called batting average _279, right? Which is a string version of this statistic, but it has the label with it. And then here are all these other statistics, right? So his total games, he bats R, throws L, throws left. He had a number of hits, strikeout average, so all the many facets of the baseball player are represented in the string value as quote unquote binned text that we're passing into OpenAI. So I would like to coin this phrase if nobody else has claimed it. So we've all heard of in machine learning, there's feature engineering, right? Where you take this raw data and you craft it and you create numeric features that aid the AI or the machine learning model. Likewise, with ChatGPT, we've heard of prompt engineering, right? It's a kind of an art and a science in crafting prompts that you pass to OpenAI. So I would like to coin the phrase text engineering, right? And that's taking your values from your data, right, and crafting a text value that you can pass to OpenAI. So we'll have to see if that term survives. All right. So now that we've created the open embeddings or the embedding string value, let's figure out. Let's look at some code. So I believe this is the first code I showed, but this is the code for creating the embeddings, right? So this is just a snippet of Python code, but you do a pip install OpenAI. That's their SDK. You do the imports of the OpenAI object. You configure the Azure OpenAI SDK with those 4 values. The URL, the key, the type is Azure, the version, right? So these URL and key come from your Azure OpenAI service. You can go to Azure portal to get those values. And to get the embeddings is as simple as this one highlighted line of code here, right? So OpenAI.embeddings.create. And the input that we're passing in is that text string, right? That embedding string value that I just showed in the previous page. And we're saying, okay, use this this model, OpenAI model called text embedding ADA002. Once we invoke that line of code, we get back E. So E is the result of the embeddings. And the embeddings themselves is nested here. So E at the key data, the first element, at the key at embedding. So that's the thing that returns the list of 1,536 floats. So literally in a half dozen lines of code, you can use the OpenAI SDK to get your embeddings. All right, so that's how we got the embeddings. So let's revisit the architecture. So I've talked about this on the left. So let's just talk about the right and focus here on cognitive search and NoSQL, Cosmos NoSQL. So where we're going next, we're just going to configure now cognitive search, and we're going to load Cosmos. Now, cognitive search, if you haven't worked with it, I use the word beautiful. It has a beautiful REST API where one configures cognitive search and where one executes searches with. So it has a number of REST endpoints, either GET or POSTs, pass in authentication headers. But it's a beautiful thing to work with. With Python, you certainly use the requests library on PyPy. So that is how the repo is implemented. Now, there are three key objects in Azure Cognitive Search. So one needs to first create a data source, and that's the thing that points to your Cosmos DB account. And then you need to create an index, and that's the thing that defines, okay, my documents look like this, so I want to make these fields searchable and indexable, et cetera, et cetera. And then the third thing you create is an indexer, and that is the object in Cognitive Search that meshes the data source and the index. So so the indexer reads from the data source and populates the search index. You can set that indexer on a schedule. It can be as little as 5 minutes. And again, examples and working code for all of this is in the repo. It was just way too much to present in one session. Just briefly, you might be wondering why is it called Azure Cognitive Search, right? Not just Azure Search. So it's Cognitive Search because it integrates beautifully with Azure Cognitive Services. And for example, you can do things like, let's say you're starting with documents like PDFs or Word documents, and maybe you want to have English users, but maybe the documents are in Spanish, right? And maybe the documents have images, and the images have text, right? And you want to extract that text. So Azure Cognitive Search can do that. You can create a pipeline of these built-in skills. You can write your own skills. So you can kind of, that document, the PDF, you can crack the document is the terminology, extract the images, get the text from the images, get all the text, translate it into English, and then ultimately put the data into Cosmos. So that, in short, that's why it's called Cognitive Search. It has the full array of cognitive services behind it. All right, so this is how one configures Azure Cognitive Search. Everything is JSON, so you configure the index with this. For example, I'll look at the second field. So the Cosmos DB documents have an attribute called player ID. It's of type string. We want to make it searchable, filterable, sortable, and facetable, right? So that's how we define that field. So there's nothing spectacular about this. This is standard Cognitive Search. But page 2 of the schema is where the OpenAI vector search comes into play. So you define a vector search here. This is kind of boilerplate code. You define some name. This name here corresponds to this name here. And this is saying that there's a field in the Cosmos document called embeddings, and it's a collection of scalars. And the dimension is 1536, right, as we talked about earlier. So this is the vector of data, and this is how we define a vector search in Cognitive Search. And again, all this is in the repo. Loading Cosmos DB, this is super simple. I have some reusable classes that are in the repo. I'm not going to dive into this, but essentially we just read the JSON file and load the database. Super simple. You do a pip install Azure Cosmos. That's the SDK. Accelerating slightly. All right, so I think 2 more real content slides. So first, we're going to search finally for players like Ricky Henderson. So the first thing, remember I said when you do a vector search, you have to pass in a vector itself, right? So what we do here, and I didn't call it out on a separate page, but we execute a search to Azure Cognitive Search just for Ricky Henderson. Just for Ricky Henderson, we get the Ricky Henderson document back, and it has his embeddings, right? So armed with that embeddings or vector value, we're going to invoke Cognitive Search with this search and say we want to get these attributes, but we're passing in this vector. Right, so this is the vector that describes Ricky Henderson. So that's all we need to do. We do a HTTP post to the endpoint, and we're saying K is 10, so we want up to 10 results. 1 minute to go. All right, I'm hustling. And then finally, ta-da! This is the search result, right? So I'm not going to execute it, but these just happened to be the first 2 search results, and they were like an epic success in that it got a broad range of players that I wasn't really expecting. So Ricky Henderson was left fielder. They're both left fielders. Barry Bonds was a slugger. Well, kind of so was Ricky Henderson. They both had a lot of home runs. And Lou Brock, he was like the epic base stealer before Ricky Henderson. So these are both great and pertinent search results. These are just the top 2. There were others that I omitted. So yeah, it really excellent quality search results. So in summary, vectors are computationally efficient. You can do what I call a full spectrum search on the full breadth of the statistics of a baseball player or whatever it is in your domain that you wish to search for. I think there's emerging art of text engineering. You can execute vector search with these 3 different ways in Cosmos. And if you're not familiar with Python, please take a look. It's a great language. You can do so much with it. And okay, so I am the closer for Python Day. I'd like to ask you to applause for everybody who you got to hear present today. This is Mariano Rivera, who is the closer for the New York Yankees. So basically, whenever he came into the game, it was over, right? He was shut down the other team. And with that, I'll say thank you very much. And if there's any questions.
I'd say you hit a home run. I think you did pretty awesome there. Just to add a little pun to end the day here.
Nice.
Yeah, so many great comments. People loved the session in the chat. Lots of good puns in there as well. So thank you so much, Chris, for joining us. This has been absolutely wonderful to hear all about.
Okay. Thank you, everybody.
Yeah, have a great afternoon.
Right. Bye-bye.
Thank you all so much for joining us and staying all the way through the day. I'll bring back my co-host, Dawn. Hey, what's up? You're still muted. You gotta unmute this time.
It's been a really great day.
Right?
This was so great.
So.
And we rounded it out with some really great puns. Love that.
We did. Can we get a high five? I don't know if we can do this.
Yeah. There you go. Oh, wait, they're doing it to the side. Okay.
Do it to the side. There we go. We got it. We got there.
It works.
It works. This has been super, super awesome. And so I'll pull up the links one last time just for everyone to see all these ways to get connected with us. And so we would love for y'all to get started, just some action items so you can take what you've learned today and actually roll with it and start getting actual real world practice. The Cloud Skills Challenge will be available until August of 2024. So it's like almost a full year. So lots of time to experiment, to try out different ways to work with Python. And I keep plugging all of the Azure community stand-ups because I absolutely love those. It's a great way to actually talk to the people who are building the products, give them feedback on the products when you're having issues with the products. Let them know what you'd like fixed or what features you'd like to see next. And learn about all the newest things that you can do. A lot of times I don't even know all the ways that I can utilize all the Azure services. And so each week that I'm on there watching, I learn about 10 more things that I can do with the services that I already use every day, which is super, super cool. And then also learning about new services that I haven't used and connecting them in with all of my other services. But that's also where all of the recordings from today will live. We'll include links to all of the things people showed. So definitely go check out the Azure Developers YouTube and subscribe. Get connected with us.
Goodbye.
Yeah,
I hope people can put in the chat things that they've learned today. I'm gonna add a couple of things. I learned so much, and I really just want to do that because I want to celebrate the team that put this all on this channel. Haley, you've done a fantastic job, and there's tons of names behind the scenes as well. Thank you so much for inviting me as well. I didn't want to interrupt. I just wanted to do a little applause for you as well.
Yeah, we got to shout out Jamie, of course. Jamie Singleton, you've been our producer behind the scenes all day today and helped put this whole thing on for months in advance of this, just making sure all of the content. Chris Harris, thank you so much. We have a full team of people who have been helping here. Mustafa Branch also, I've got to shout out all of the team, people who have made this happen. And so we're super grateful. This content has been really helpful for me personally, and I hope for everyone else as well, to learn how we can be better Python developers on Azure. And so thank you so much. Well, I think with that, we've got all the links here. Screenshot it, save it. It'll still be included in the recording, and so you can access this whenever. But have a wonderful day, afternoon, morning, evening, whatever time you're joining us from. We'll keep doing these in the future. We've had .NET Day back in March. The recording is also on that YouTube, and we'll do more language days, including another Python day at some point in the future. Oh no, that's it. We're good. We can sign off now.